Good morning again. My name is Giacomo Persipaoli. I'm the head of the Security and Technology Program at UNIDIR, and I have the pleasure of being at least one of your MCs over the course of the next 2 days. And before we formally kick off the conference with Director Robin Geis and his opening remarks, I just wanted to take a moment to welcome you here, the sunny Geneva, for the second edition, the 2026 edition of the Global Conference on AI Security and Ethics that is organized by UNIDIR under the auspices of the newly established Center of Excellence for AI, Peace and Security. I'll take a few moments first and foremost to thank all of you and all of the audience following us online for joining us. Over the course of the next 2 days, we're going to have many interesting discussions. I will share with you how we would like you to engage with us. If last year's data point is any indication, we're really looking forward to receiving many of your questions, and I will explain how. Those that are here in the room can already see the flyer in front of them. For those following us online, we'll give you instructions shortly. But I would like to start first and foremost by thanking our donors and sponsors. As you know, UNIDIR is a voluntary funded organization and institute, and this conference would not have been possible without the generous contributions of the donors and the sponsors of the Center of Excellence. These, you can see them on the slide, include la Fondation pour l'Adaptation de la Genève Internationale, France, Italy, Germany, the Netherlands, the Republic of Korea, Pakistan, Switzerland, and Microsoft. To all of our sponsors, some of which are here in the room today, goes our gratitude for making this event possible. As I mentioned, a couple of housekeeping remarks before we start. For those of you that are here in the room, in case you have trouble hearing the speakers, I think the microphones are quite high, but in case you have any trouble, of course, you can use the earpiece that is on your desk. If you want to ask questions, and perhaps we can go on the next slide, we will be collecting all of the questions, whether they're here in the room or from the audience online through the platform Slido. You can see the instructions on the screen or on the flyer in front of you. This platform, for those of you who don't know it already, will allow you to submit your questions, and once they're cleared by the moderation team, they will be displayed for everyone to see, as well as from the moderator that will be on stage. If you see a question that you particularly like or similar to what you want to ask, instead of asking the same thing in different words, please do like and vote for questions that have already been asked. This will help a lot moderators in prioritizing questions to be asked to our speakers. Again, based on experience that unfortunately or fortunately there tends to be more questions than there is time to answer them. So anything that you can do to help us prioritize would be deeply appreciated. And now, without further ado, I would like to invite here on the podium Dr. Robin Geis, the director of UNIDIR, for his opening remarks. Robin, please.
Thank you, Giacomo. Good morning, Excellencies, distinguished delegates, colleagues, and friends. And it is a very great pleasure for me to welcome you all to UNIDIR's Global Conference on AI, Security, and Ethics 2026. It's the second edition and the first that we're holding under the auspices of our newly established Center of Excellence on AI, Peace, and Security, which we launched just last night. When we met here last year for the first edition of ACE, one message that came through very clearly was the issue is no longer whether AI will shape military and security environments, but how it will do so and what the consequences will be. And over the past year, this reality has only become more evident, more complex, and certainly also more urgent. Reports of AI-enabled applications in conflicts are growing, from intelligence analysis and targeting support to information operations, autonomous and uncrewed systems, and cyber activities. The sensor shooter time is falling. The number of targets that can be engaged in any given day is dramatically increasing, and so is the pace of battle overall. And at the same time, the AI industry's national security relevance has become much more visible. Questions that were once seen as technical or commercial, such as who has access to frontier models, under what conditions they may be used, what safeguards should apply, and who controls the infrastructure on which all these systems depend. All these are now clearly security issues. And the same trend to see things through a security lens also equally applies to the infrastructure that enables AI, data centers, cloud services, and model access. They're no longer simple enablers of innovation. They are becoming strategic assets, potential vulnerabilities, and at times objects of geopolitical contestation. This shift forces us to rethink notions of resilience, dependency, escalation, and the protection of civilian infrastructure and societies. The community engaged in all these discussions is also expanding, quite naturally so. States remain central, but industry, researchers, technical experts, civil society, and humanitarian actors, they're all increasingly involved. This is essential because many relevant capabilities are developed outside defense institutions, and many risks extend far beyond just the battlefield. But broader participation also brings new challenges. Different communities often use the same terms: responsibility, reliability, assurance, human judgment, transparency, and so on, but they do mean different things. Without structured dialogue and without a shared lexicon, governance risks fragmenting into parallel conversations, aligned maybe politically, but disconnected in practice. And in this context, UNIDIR's conference comes at a critical moment. Our task here is clearly not simply to restate AI risks and opportunities and discuss all of this, but clearly to define what responsible governance requires in practice and how to make it credible and usable in real-world contexts. Last year's discussions provided an important baseline for our work over the next 2 days here at this conference. And 3 observations stand out from those discussions we had past year, and they've only gained in urgency over the past 12 months. First, we must move from principles to implementation. Norms and political commitments matter, but they do not tell a procurement officer what to buy. They do not tell a commander what to trust, a developer what to document, or a legal advisor what evidence is required. Second, the technical foundations of governance are key. Responsible AI cannot be separated from data governance or data assurance. And systems used in security contexts must be reliable, not only in ideal laboratory settings, but clearly under pressure, adversarial, uncertain, and rapidly changing conditions. And third, context matters. Principles gain meaning only when they apply to concrete use cases. The requirement for human judgment, accountability, responsible use, all these will look different depending on whether AI is used for targeting, for intelligence, for logistics, border security, or peacekeeping purposes. Each raises different questions of responsibility, safeguards, rules, risks, and compliance. And AI governance must therefore become more specific and more grounded in real systems, in real decisions, and that's what we're here to do. All of these points highlight a broader challenge. AI governance and security cannot be built by any one community alone. It requires sustained engagement across states, international organizations, industry, researchers, civil society, and technical experts. And it also demands coherence. Without it, we clearly risk multiple frameworks using similar language but meaning very different things. So this is precisely the purpose of this conference and why we're here. This is not a negotiating forum. The value of this conference lies in enabling open, inclusive, evidence-based, and technically grounded exchanges, where assumptions can be tested. We certainly want to experiment with some of the arguments, and policy discussions can be connected to operational realities. So in this spirit, I wish all of us interactive and engaging, informative discussions over the next 2 days, and I want to close by thanking our donors and supporters, the various speakers and moderators, partners, and of course the UNIDIR Security and Technology team led by my colleague, Dr. Giacomo Persi Paoli, for making this conference possible. Thank you all very much for being here with us. And without further ado, and I'll continue speaking, I make my way back to the podium. We will kick off the day with the High Representative for Disarmament Affairs, Madame Izumi Nakamitsu. We will have a fireside chat up here on the podium to set the stage for the discussions to come. So, Izumi, I have spoken at length, so I'll hand it over to you pretty directly. Thank you. We've had the informal discussions, of course, over the past 3 days, extremely timely from my perspective and extremely urgent, so urgent and timely that it got coverage by Le Monde, which I found quite astounding with all the attention being in Evian across the lake this week. But the dialogues made it up there, and that clearly underlines how relevant this topic just is. It's easy with AI topics to slide down into doom and gloom. So to avoid doing this at the start of this conference, I would rather like to start on a positive note and ask you, what gives you the greatest sense of optimism with regard to how states and stakeholders approach this topic, AI in the military domain? Over to you.
Thank you, Robin, and good morning to you all. Thank you for being here, and thank you for this opportunity. Now, I have to get a hold of that Le Monde article. I haven't seen it yet, but great to actually start with some positive, some encouraging signs. Now, there are a couple of reasons why I think we are encouraged. The first one is, the conversations about this issue has matured rather quickly. I mean, compared to some of the other tech-related issues, whether that is ICT or outer space, the speed with which the maturity of conversations is being achieved is quite encouraging. Also, together with it, or perhaps it is because of the growing willingness, that is, of course, the other sign of the fact that many actually are concerned about it. But I think the past 3 days with the informal consultations, we saw that there is definitely a growing willingness to engage across existing differences. Now, states all have different perspectives, but they are still, I felt that there is a keen interest amongst the vast majority of member states that they would like to engage in these conversations. So I think that's a really good. The second reason why I am encouraged, and you mentioned it a little bit in your opening remarks, but the discussions are also becoming more practical. Again, member states, yesterday for the next steps discussions I've heard, many states are really emphasizing the need to become more practical in their conversations. So, principle, theoretical, abstract discussions to what needs to be done. And they are really increasingly asking very concrete questions, which is very important. How AI systems are designed, tested, evaluated, and deployed. What kinds of safeguards are needed, and then how they actually want to arrive at those, how to mitigate risks throughout the AI life cycle. Those are very concrete and practical questions, and the fact that they are willing to actually tackle those practical questions are very important. And then another source for optimism is the breadth of participation. I mean, I don't need to really emphasize, I mean, you are actually the testimony to that broad spectrum of people who are interested and keen to engage. And that is absolutely important, going beyond government representatives and intergovernmental organizations. Many of you are from academia, civil society, industry, and those broad participation indeed is very important. So I feel that in the intergovernmental discussions, we need to capture this and we need to make sure this broad stakeholder participation will be maintained. And then finally, I think I am encouraged that states seem to be actually saying that we need to have a balanced discussions on both the risks, but also opportunities. And I think, you know, I always joke about this because I'm a lady from the dark side. We always talk about the dark side of AI and emerging technologies. But I think we really should be discussing more about how we can utilize AI for international security. I mean, there are many things that we could do with it, and we could benefit from the artificial intelligence for arms control, non-proliferation, and disarmament as well. So I think this balanced approach that we hear from member states and across the board from various stakeholders is a quite encouraging thing.
Thank you, Izumi. Yeah, and I think all of this is encouraging, especially this willingness to go more concrete, to drill down on specific real-world challenges. I think that really is quite clear to me. That is the task of the moment. But you spoke of the dark side, and we wouldn't be the UN if we didn't look at that side too. And I think it's extremely important to always state this is not a tech-averse approach in any sense. We see huge opportunities in the technology, but of course it comes with especially our job description to also consider the risks. And of course, it's quite challenging because it's such a broad field. Even if we're just looking to the military domain, AI has become so pervasive and so relevant in so many different areas, and many of them still fraught with some uncertainty of where things really will go because the technology is constantly evolving. So I would like to ask you, Izumi, from also the dialogues and your general impression, what are some of the unresolved challenges that we're currently facing, and unresolved challenges that could also impact the way forward of how we're approaching this issue?
Right, yes. So again, there are a couple of concrete challenges that we need to overcome. Maybe the biggest is what you also emphasized, how to move from dialogue and conversations to action. And this is really important. But there are challenges related to, of course, different perspectives and different stages of engagement or deployment of artificial intelligence by different kinds of member states, right? I mean, some are already developing and deploying AI-enabled military capabilities. Others are basically at the moment concerned about access to technology and really focusing on capacity building from that kind of perspectives. But also they are, you know, we heard yesterday many states talking about risk reduction and safeguards. Also, this is not just limited to this particular issue, but a few states, they don't seem to, I mean, they don't want to have the issue discussed within the United Nations system. So these are some of the concrete challenges we need to overcome. I mean, these relate also to different starting points of particular perspectives and different views on priorities and governance. And I mean, there are ways to tackle them. I mean, I do remember the earlier stages of ICT security discussions. I mean, they were similar concerns, and then we really had to invest in efforts for all states to really understand why the engagement is important and why the inclusive conversations at the United Nations will be beneficial to all. Now, what struck me in the discussions is that there is also often broad agreement on objectives, which is good. Many states, I think, want to use the concept of responsibility, although not all of them actually agree on the particular terminology of responsibility, and we heard those differences yesterday also. But I think many states stress human responsibility and accountability in decision making, but there is definitely much less agreement on how and what these concepts mean in practice and how they should be implemented. Again, you emphasized implementation. So we're in the process, we're entering the process of taking these broad agreements on the concept of responsibility, and then how we can concretize and then bring that to the implementation. This is a key challenge that we need to really start tackling. Another challenge is the pace, of course, of technological change or the progress itself. There is a constant risk, because of the speed of the technology advancing, there is a constant risk that policy discussions become, if you will, disconnected from the technological realities, and that's a very concrete challenge. And here we really need advice and real serious contributions from those that are developing and innovating and making advances in the technologies themselves. I think this will point to, yet again, the key issue of a multi-stakeholderness, or put differently, maintaining dialogue that is both inclusive and informed, the two I's that you used also in your many remarks. And so that's inclusiveness and informed discussions, absolutely key, that moves beyond talking to doing. But this is a challenge when it comes to intergovernmental discussions very often, and you know all about that. So what this means is that we need a mechanism or mechanisms that will allow policymakers, technical experts, and military practitioners and legal practitioners, specialists, to continue learning from each other. Interdisciplinary approach is absolutely crucial. And we need to make sure that these respective perspectives and expertise will be really utilized to the best in the intergovernmental discussion. So ultimately, the challenge is to build sufficient trust, both in the process and the mechanisms of dialogues, but these discussions actually taking place with a view to achieving a better understanding and cooperation among states, so that they will be able to make norms and guardrails that are really fit to the technological realities of today. We are starting to face the real test, if you will, in the coming years. Whether we can translate the growing awareness and engagement that we have seen into practical cooperation, confidence buildings, and norms discussions and developments, and then obviously risk reduction measures to start with. And then this is an ongoing challenge as we actually speak. It's no longer a future issue, but it is already today's issue as well.
Yes, certainly on risk reduction, a lot of work ahead of us in an ever-evolving space. Izumi, this is an urgent and huge topic in and of itself, but of course the United Nations pursues a much broader agenda when it comes to artificial intelligence. There's a strong development perspective and element to it, of course, and a range of other issues that the UN is rightly concerned about. So how would you say do these discussions that we're having in the disarmament arms control space connect to broader issues and initiatives like the global dialogue on AI that will be held in Geneva in a couple of weeks? How do you see the interconnections between these different debates?
Right. I think this is absolutely a key issue as well. Now, arms control, disarmament, non-proliferation community is very specific, and there is a very good reason why those types of discussions will be really taking place amongst the security experts. But at the same time, I think most of us will agree that those different processes and platforms that have been created in the recent months are actually deeply connected and increasingly inseparable, I think. The mandates are all very different. There are different focuses, the global dialogues on civilian use. And ours, military domain discussions are really hardcore security issues. But there's also the scientific panel as well that will be also making, I hope, I mean, you know, we talked about it for several years, even before the scientific panel was created. You know, to have something like IPCC on the climate side, making a huge contribution and therefore moving the file will be quite useful. And then we now have it, the International Independent Scientific Panel on AI that exists. So we need to look at those whole spectrum of various processes in its totality, and then really think very smartly about how to connect the substance of those matters, making sure that the mandates of those respective bodies are obviously very independent. Discussions within the disarmament communities are, as I said, focused on probably one of the most consequential aspects of the artificial intelligence. You know, the questions involving the role of human operators, the use of force, and how the decisions should be made when it comes to engaging the force, especially lethal force, arms control, accountability, compliance with international law, to name a few. These are really consequential to all of us. And these, therefore, these are actually really important issues that will require dedicated attention, and hence our mandate of military domain discussions. But AI does not exist in isolation, and we often also talk about how the civilian AI is now adapted and then utilized in the military domain as well. So one of the themes highlighted repeatedly, both in the SG's report and the informal exchanges that just concluded yesterday, is the increasingly blurred boundary between civilian and military AI. The same advances in foundational models, computing power and infrastructure autonomy that drive civilian innovation, can also have implications for military applications. So this means that discussions on AI governance and discussions on international peace and security can no longer be really treated entirely separate tracks. So I am trying to play my small contribution, small role, to make sure that everything that is happening in this community will be informed to the co-facilitators, co-chairs of the global dialogue. I mean, we need to make sure that people involved in the discussions in other tracks actually are fully aware of what is being discussed in this particular military domain conversations. And I think the global dialogue, I think 6th and 7th of July, provides a really important opportunity to unpack conversations on human rights, transparency, accountability, and international cooperation as well. And these themes are directly, obviously, relevant to our discussions on military AI as well. So let's make sure that you know, connections be built between those conversations, and we also need to make sure that the connections are built between conversations that are taking place in the UN community, and also there are so many processes happening outside the UN as well. So, you know, we need to, again, look at those various conversations in their totality, and making sure that they would not all go separate ways, but they will actually achieve good coherence. In other words, to avoid the risk of fragmentation in those various processes. And I think the UN actually can play a unique role as a place where these conversations can be connected. And if I could actually also remind ourselves that the cybersecurity, ICT security discussions happened more or less the same way. I mean, there are many different regional discussions taking place. At some point, we also had mandates from the GA to organize regional conversations, and then they all actually came together and informed the global conversations at the UN level. And I think those various conversations outside the UN mechanisms and also at the regional level really came together, and then we have now a permanent mechanism on ICT security. So we need to make a same or similar efforts to make sure that those various conversations actually come all together and achieve conversions, and they will contribute as well. So, I mean, most importantly, I think we need to always remind ourselves that the discussions are ultimately asking the same question, and that is, how do we ensure that AI serves humanity rather than undermines it? And that's true for all of those conversations. So the international security community ourselves, we need to contribute to an essential perspective to that question. Because, as I mentioned, we are dealing with probably one of the most consequential aspects of the AI, we have to make sure that these powerful technologies like AI would not intersect and exacerbate already very severe competitions, geostrategic, geopolitical issues, put more fuel into the fire as it speaks. So we have a lot of work to do, but having these overall perspectives, looking at many efforts will be absolutely critical. But let's speed up our work from discussions, dialogues to action and implementation, because time is actually running out.
Yeah, thank you, Izumi, for this tour d'horizon of the various initiatives. And just to fragmentation, I mean, we see that risk and initiatives here and there. And we also, of course, agree that the UN is a primary forum to keep things together, to serve as that hub. And the center we launched at UNIDIR last night is intended to serve exactly that purpose. So I think 4.5 minutes ago, I was handed a 5-minute timeline reminder, but I did say in my opening remarks we want this to be interactive. So if you allow, Izumi, I know you have to run and Giacomo has to keep the house in order, but maybe just one question from the floor that has come through the Slido system. What are the main concerns regarding having these themes discussed at the United Nations? What are the main concerns? Because you said in one of your answers that there's concern about doing it at the UN. I think that pertains to the military side, not so much to the other initiatives. What are the main concerns of discussing these issues, AI in the military, at the UN?
The UN discussions, because of the key aspect of being inclusive, which is very, very important. AI is not going to impact just a handful of states, but it will impact global community. So there is a good reason to make it inclusive. But inclusive discussions take time and efforts. And as a result, we have a real challenge of actually keeping pace with the speed of the technological advances. So that is a very concrete challenge. Many people who are doing these dialogues outside the UN platform use that argument as one, very important reason why we should not be actually having these conversations in the UN. There are more issues, more reasons why. I think there is probably a political intentions. Why don't we have, those technologically advanced states should get together and then make the governance guardrails and normative discussions quickly, and then bring that bring it to other states to accept it. That will be, a combination of a sort of speed considerations, but also political and self-interest to maintain the way they want to actually create the norms and guardrails and standards. So we need to make sure that that is not, at the end of the day, it's not going to be a very effective governance systems, because by definition, governance and norms would mean that everyone really needs to adhere to. And that would require constant efforts, but with urgency. And that is quite a tall order. It's because of different perspectives, different levels of understanding. We need to make sure that the global community, in an inclusive manner, they will be ready to take these very concrete discussions very, very urgently. So it's going to be difficult, but we have to do it.
Well, Izumi, thank you so much for setting the stage for us so nicely. It is a tall order, plus time pressure, so lots of work to do at this conference. Thank you for joining us this morning, and if the audience will please join me in giving a hand to the High Representative. Thank you.
Thank you so much.
Thank you, Izumi. Thank you, Robin, for opening this conference with such a thoughtful segment and fireside chat. We will now move straight into the first substantive segment of the conference, which focuses on technology. We call it Technology 101. We heard how important it is to have a strong technological foundation to really approach this topic. So while the first speaker of the segments will join me here on stage, just wanted to give you a little bit of a background on this segment. So this first cluster of sessions will include both deep dives like the one we're about to hear, and very short lightning talk, almost elevator's pitch if you want. So clearly there won't be a lot of time for engaging, but all of the speakers are here. So if you're here in the room, please do feel free to approach them. And as I let our speakers settle, I also wanted to remind you of the poster exhibition that we have outside. We received many interesting proposals to have posters displayed. We selected the ones that are out there, so make sure that over the course of the next 2 days you take the time to see them and to look at them. Very happy now to introduce our first speakers of this segment. And the first thematic deep dive, very successful sequel to an event we had last year of the Lost in Translation series. This time we will be focusing on the issue of bias, and I'm very happy to welcome back here at ACE our two speakers, Dr. Jane Pinellis and Kirsten Vignard, both joining us from the Johns Hopkins University Applied Physics Lab. Kirsten, Jane, take us away. Thank you.
Thank you, Giacomo, and to UNIDIR and the SecTech team. It's a pleasure to be back. Welcome, colleagues. It's always hard to follow a Robin and a Izumi act. I mean, that's a dynamic duo. So we're going to do our very, very best to get us started well. So I have a question for you. Ever been in a meeting where everyone seems to agree and later you find out that you all understood something different? That happens all the time when policymakers, technologists, and military operators talk about AI. The vocabulary can sound shared, but the assumptions underneath it and understandings underneath it are not. And that's the problem this Lost in Translation series is designed to address. Jane and I work together at APL, but we come to these questions from very different professional disciplines. Jane comes from math, statistics, and technology, and I am pretty sure she doesn't know the difference between a GGE and an OEWG. I, on the other hand, come from this world. And don't tell Jane, but I don't know the difference between a projit and a logit. So I even said that wrong. I still don't know. Oh, all right. This series began with a simple observation. Even when technical and policy communities use the same terms, they often attach different meanings different risks and responsibilities to them. Last year, we talked about everyone's favorite AI adjective bingo card, the difference between responsible AI and assured AI. We're back, and this year we're talking about bias.
Everyone talks about bias, but in reality, we all mean different things. The same term triggers very different concerns across communities. So engineers like myself, policymakers, operators, we all assume we're discussing the same problem, but we're not. And the goal of this talk is not to converge on a single definitions, but rather to appreciate the difference in our definitions and to help bridge some of the gap and help understand what different remedies, solutions, and explanations we all bring to the table. We can sometimes say that a data set is biased. We can say that a model is biased. We can say that the output of the model is biased, or that we experience different consequences of the system. And so the central thesis of this talk, the central argument really is that we're actually just not talking about the same thing. And so we're going to try, instead of making one definition explicit, to address the different definitions, discuss what kind of requirements and solutions they imply and what that means for governance. This is especially important, of course, in AI in defense systems, where bias can affect not only mission performance, but also escalation, civilian harms, operator trust, and the entire legitimacy behind AI-guided military decision support.
Next slide, please. So bias isn't a new concern. Look at that. Bias isn't a new concern in discussions on military AI. It's been raised for some time in the CCW discussions on lethal autonomous weapon systems, and it appears across national statements and things like responsible AI principles, and even last year's report of the Secretary General on AI in the military domain. All of the phrases on this slide come from that report or from the national or stakeholder contributions to it. And what's striking is not simply how often bias appears in the Secretary General's report, but how many different things the word is doing. Some references point to technical concerns, such as biased data sets. Others refer to social biases, such as racism or sexism. Others point to human or cognitive bias. And then there are the catch-all references, such as various or other biases, which show how often the term is used as a residual category rather than a precise concept. So when we hear commitments to mitigate bias, the obvious question has to be, which one? Without that clarification, the commitment can sound clear while remaining very hard to operationalize. Next slide. So quick review. 3 dominant framings of bias emerge in our military AI discussions. Some actors focus on mitigating unintended technical bias. That's the world of Jane. Others focus on fairness, equity, discriminatory outcomes. That's more this world. And even others approach bias through human rights and protection frameworks. That's kind of also this world. In policy discussions, bias is usually associated with harm, especially harm that is systematically disadvantaging particular groups. And in our international conversations, these concerns are often grounded in international humanitarian law, human rights law, dignity, accountability, and broader societal and humanitarian impact questions. So pop quiz for the room. Do you remember the first time that you heard the term algorithmic bias? I know I do. I bet I'm not the only one who thinks of examples like facial recognition systems that fail to recognize non-white skin tones, or decision support tools that were used in prison sentencing that disadvantaged one race over another. These earliest public stories about algorithmic bias matter to how we show up for these conversations in non-technical fora. And they're a great example of anchoring bias, one of the cognitive biases that we were concerned about. So for many people outside of the technical community, when we hear algorithmic bias, we often immediately kind of go right to the racial question. But to a statistician, a biased outcome is a data point. It's neither really inherently good or bad. From a policy lens, a biased outcome is one that produces unjustified or disproportionate harm, regardless of its statistical accuracy. So to put it another way, to Jane, a biased outcome is about distance from statistical truth, And to me, a biased outcome is about distance from justice. Same word, but one points to math and the other one to our values. Next slide.
So the word bias really prompts different questions in the different communities, and we show just 3 of them here. Engineers like myself would ask, what does the model do? Does it consistently overestimate or underestimate? Does it perhaps give you different rates of errors in different situations on certain classes? Does it produce uneven error rates? Potentially, does the model behave differently across different sensors or across different languages or data sources? At the same time, policymakers would ask who is harmed and disadvantaged or advantaged by this technology. Does that advantage spread equally among different communities or partners or units? Are there any missions that are exposed to disproportionate risks? Does the system potentially introduce discriminatory effects? And are there ethical or institutional commitments that we may not be able to uphold as we use this system? And then we have our operator community, and the operators ask, what does this change about my mission? So that is very much a use and context kind of question. They ask, does AI change the output maybe that an analyst sees? Does it go through evidence so quickly, at the same time reducing the scope of evidence that an analyst is exposed to? What about operator trust, and what about the action that ultimately follows whatever intelligence AI provides? Does it change the escalation paths? All of those questions are equally valid. The problem starts when we think we're all answering the same question, when in fact we're not. Because an engineer like myself might say, we did in fact test for bias and the model meets all of our bias thresholds. But the policy team might ask, what kind of bias threshold for harm to whom and under what authority, and who takes on that residual risk? And then an operator might ask, was it tested for anything like the environment in which I will actually use it? Can we defend this decision, especially if it leads to a bad outcome? So that's what we mean when we say different vocabulary, and it's going to bring different evidence to different risk owners and potentially come with different remedies.
So spoiler alert, bias is everywhere, and it comes from different sources. So first source, we have computational or statistical, and this is the area most familiar to our technical teams. Here, bias can come from things like skewed samples, measurement error, missing or stale data, domain shift, etc. These problems can often be measured, at least partially, using technical tools. For example, a model trained mostly on clear weather imagery may perform poorly in dust or fog or darkness. A model trained on historical examples might not generalize after your adversary's behavior changes. These are technical concerns, but in defense settings, they quickly become operational ones. The second source is systemic. This is where bias comes from institutions, incentives, historical inequities, governance practices, and patterns that exist in our real world, the good, the bad, and the ugly, that data may faithfully encode. Systemic bias is harder to solve because the model may not be the actual source of the bias. It may be reflecting collection practices, reporting practices, or historical priorities. The temptation may be to say that if the data reflects reality, the model is neutral, but it's not always true. Data reflects a slice of reality shaped by human decisions. What was collected? What was ignored? What did we label? How did we label it? What outcomes were recorded? And the third source is human or cognitive. This includes automation bias, confirmation bias, anchoring, trust by proxy, those sorts of things. These biases don't live in the model, they live in us. They emerge when we interact with AI outputs. A highly capable system can still create bad outcomes if a user overtrusts it, misunderstands confidence scores, ignores uncertainty, those sorts of things. Next slide.
Whether the system is biased is usually not a good question to ask. It's not the most useful. And the reason it's the most useful is not because bias is unimportant. It's just that it invites a yes or no answer to a question that is really just goes beyond binary. Most systems will contain some kind of bias. We can never get rid of bias unilaterally. Having said that, for each type of bias, where we really want to get to is understanding it, measuring where it exists, figuring out where it's necessary to mitigate it, and then how to govern it using the right authority. So instead of asking, is the system biased, what we should ask is, what kind of bias? Is it sampling bias? Is it historical bias? Is it measurement bias, et cetera? Is there a discriminatory impact? We should also ask, for whom? Does the concern affect a particular protected class or a civilian potentially, et cetera? Of course, we also must tie our bias to the context in which we're discussing it. Everything ultimately comes down to mission. And we also need to ask the unpopular question of how much does this bias need to be addressed, right? If the bias leads to a system recommending the wrong movie to you, perhaps that's not something we want to pay a ton of attention to. If the bias leads to a bad mission outcome, that's where we start shifting to solutions. And as we get to solutions, the next important question is, at what point in the life cycle should we address that bias? And we'll talk to that on the next few slides. And in particular, who should be addressing it, who's responsible to address it, and who's able to address it. And as they are addressing it, how do we know they got it right? What evidence counts? Who has to bring that evidence and to whom? And are there benchmarks that we have to meet? And then we finish with, now that we figured out what the bias is, whom it affects, what its context is, and what the benchmarks are, what are the technical and policy tools that we can be using for it? Next slide, please. And so as we went through this exercise in the different communities, we figured out that there are literally hundreds of places where different types of bias can be introduced into our models. So to me, that's a number, it's a really large number. Kirsten pointed out, being the more positive person that she is, that that also gives you hundreds of opportunities to actually mitigate bias in different stages of the AI lifecycle. And so this here we show a technical version of an AI lifecycle and just some options for the types of biases that we as humans, frankly, tend to introduce to the engineering process. We start with data, right? And this might look discouraging, by the way, but again, just think of the solution opportunities. So as we start with data, there are multitudes of ways in which we can introduce bias, and the way we collect data in a biased way, in the way that the data reflect our historical opinions, et cetera. Then we process data. As we process data, we often throw out observations that look incorrect or that look unusual, right? That can bias the data as well. And in fact, outlier observations are often the most interesting to investigate. As we build our models, we build them necessarily by making assumptions, trying to simplify the actual data generating process that occurs. And as we build those assumptions, we bias a model in another set of ways. And then we further then evaluate how good our systems are. And as we introduce measurements and benchmarks, we can bias the model that way as well. And then finally, once we get to our operators and deployment and the way that they provide feedback and the mechanisms that we put in place to have them provide that feedback, there's yet another set of biases that can be introduced in that process. And so the weakness of this approach is that we have to figure out what matters, and that's always going to be subject to bias and argument. The strength is that this is all measurement, and a whole lot of this is under our control and can at least be discussed, quantified, and mitigated.
Next slide. So for policy communities, shifting the lens to the policy community, bias usually means that a system will distribute harm, benefit, or accountabilities in ways that are unfair, unlawful, or operationally illegitimate. So the central question really isn't whether the system works, something that Jane is concerned about, but who bears the consequences when it doesn't. And that's why policy discussions frequently focus on rights, protection, dignity, accountability, and the distribution of risks and harms. Policy communities are often concerned with questions like, are certain individuals or groups exposed to disproportionate risk or discriminatory effects? Does it undermine public trust or mission legitimacy? Does it shift responsibility in ways that are perhaps unclear? This perspective also focuses on governance questions. What levels of risk are acceptable? Who has the authority to approve or challenge or withdraw a system? What evidence is needed before something gets deployed? The challenge for policy is that values do not apply themselves. Concepts like fairness and accountability have to be translated into measurable requirements, testing approaches, and operational controls. And that translation cannot happen with the policy community alone. Determining what should be protected is a policy question. Determining how these protections can be measured, tested, implemented requires both technical and operational expertise. Next slide.
And so we've talked about the pipeline and we've talked about governance and legitimacy. Now we talk about humans who actually get to interact with AI in the context of their mission. Operators encounter bias through mission decisions, not abstract definitions. And so the key phrase here is AI is used in context. So as we look through this, we see mission context. Number one, how does the training data situational awareness affect the biases that AI brings to the process? We then look at system output. What is ultimately presented and how is it presented to the operator? Is uncertainty, for instance, discussed? If you have ever used ChatGPT, right, you know that it sounds very certain about the things that it says and recommends to you, completely regardless of whether they're truthful. Of course, then we get to human interpretation. Have the humans been properly trained on the system, and do they understand how much it should be trusted and how much they should be relying on it? Once the human has the right information, hopefully in the right form and in the way that they understand, then they start making decisions with the system and actions with the system. So here we worry about things like tempo, for instance. How much time does the human have to consider AI recommendations? If that time is very little, they might be too inclined to trust it, for instance. And then finally, again, that feedback loop, the learning and the feedback. Who is monitoring the system once it's deployed? As domain or data shift, whose responsibility is it to estimate the residual risk and potentially take that on, or even know when to turn the system off? Next slide.
So for those of you who were at the informal consultations earlier this week, you heard me argue that we need translation matrices, not just glossaries of terminology. A glossary only helps us agree on words and agree on words that we use amongst ourselves as a single community. A translation matrix helps us understand each other's across the community, what we need, what our terminology are, what our concerns are, what evidence we need, and what kind of tools or responses are at our disposal. So this is a very simplified version of what we're talking about. Across communities, the object of concern is very different. Engineers tend to focus on things like data and outputs, while operators focus on mission performance. Communities rely on different forms of evidence. Engineers are looking at error rates, while policy actors, maybe they're looking at impact assessments. They define success differently. For a policymaker, success may mean that responsibilities are clearly outlined, and for an operator, that might mean that a system supports lawful and effective mission outcomes under realistic conditions, not just in the lab. The challenge is that these assumptions often remain implicit, and translation begins when we make these decisions explicit to each other. Next slide. So one way that we can do that is pairing principles with directly into assurance questions. So many governments have made commitments to some variation of these sorts of AI principles. High-level commitments and principles are important. They tell us what we value and the outcomes that we are trying to achieve. The challenge is that principles don't always guide us in practical ways towards operationalization. So one way to help start thinking about that is to generate assurance questions that help translate principles into evidence, responsibilities, thresholds, monitoring, and oversight. The assurance process is what helps us turn intangible commitments into technical and operational requirements. And if you want a quick refresher on AI assurance, Jane spoke about AI assurance at last year's conference, and the recording is available online. Next slide.
So as an example, here's what happens when the engineering, policy, and the operator community encounter the same scenario. Imagine an AI-based visual reconnaissance systems that helps identify whether a particular individual is a candidate, object of interest, or a civilian, for instance. So you have a system that produces detection and assigns a risk score to that person. Maybe, if you're lucky, gives you a confidence estimate or a prioritization for further review. So what would an engineer see here in terms of technical questions? I would worry about, am I still observing this person in a geography on which my model was trained, or has there been domain shift? Is there any camouflage or class imbalance that could affect this particular detection or my confidence in it? Do I have an acceptable false positive rate or a false negative rate across the relevant conditions? If we go to a policymaker, they might have a very different set of questions and concerns about bias. Things like misidentification, accountability, civilian harm. So the question is not just how well does the system detect an object, but could it contribute to unlawful or individual or even unacceptable outcomes? Who is responsible for those outcomes, and who decides if the system is okay to use, and who owns that risk? An operator might ask a different set of questions entirely. They might ask, what does it look like when all of the evidence converges? What else do I know? How else can I enrich this particular observation? Are there a pattern of abnormalities potentially that I should be looking at? Or what is my escalation path? And so you can see here that this particular risk score is both the promise and the danger of AI. The promise is that it could potentially fuse a lot of intelligence and present it to an operator very quickly, prioritizing their attention potentially and reducing operator burden. At the same time, the risk score could very quickly become over authoritative and miss a lot of important uncertainty that's associated with that outcome. So each community here has a role, and the key lesson is really to evaluate bias across these different dimensions and figure out what evidence all of those stakeholders are responsible for bringing. Next slide, please.
Well, I know that we're going to wrap up. We're going to leave you with some solutions in just one moment. I think the key question to take away from this before we get to solutions is you want to get more nuanced in how we talk about bias. Right? The goal isn't to come up with a definition. The goal is shared understanding. Next slide. So, how do we get from shared words to shared work? A couple things that you can do in this room. First, for policymakers, if you want to move from principles to action, we have to get more precise. The point I just made. Too often, bias is that catch-all term, and it obscures more than it reveals. Never say just bias. Is it a sampling problem? Is it an automation bias? What risks are you concerned about? Second, watch out for the trap of false fluency. When someone else says bias, don't assume shared understanding. Ask what they mean, what evidence they're relying on, and what risks they're trying to manage. Third, bring technical, policy, and operational experts together early. Way to go, UNIDIR. Occasional multi-stakeholder meetings are valuable, but they're not the same thing as sustained translation exercises. We have to exercise our translation muscle more frequently. Embed technical advisors in policy teams and embed policy advisors in technical programs. You can do cross-functional design reviews and build that into your system and your processes. You can do joint red teaming and evaluation exercises or shared case studies. You can have policy observers at your test and evaluation events.
The next step The next step for the technical teams is connect metrics to harms, really start understanding what each metric protects and what trade-off it actually creates. Keep testing the systems in context. We've seen many systems that perform perfectly well in a laboratory setting and completely break down in operations. Bring shared accountability mechanisms, right? Independent assessments, documentations, traceability, and importantly, rollback paths for our systems that are actually fielded. And most importantly, and something that we forget all the time, train the human side of the system. An operator cannot use the system responsibly and frankly effectively if they're not aware of how the system was trained, tested, developed, and especially if they're not aware of its shortcomings. Next slide.
That's it. That's it. Taken together,
Fantastic.
these are the sorts of steps that move us from shared work to from our shared words, our common lexicon, to shared action. Hopefully next time somebody says bias, you'll be a little bit less lost in translation, and your immediate response will be, which one?
It's
Over
not
to
a
you.
term that we define once and then move on. It's really a set of risks that we need to keep defining, keep translating, keep testing, governing, and mitigating and use.
Thank you, Kirsten. Thank you, Jane, for this great presentation again. There are a couple of very interesting questions on Slido that unfortunately we can answer directly live here on stage, but they're very good, and I would like you to perhaps, with the help of some of the team off stage, to perhaps reflect on them. We can answer them in writing directly on the platform. So if you have asked those questions, they will be answered off stage in writing, but they will be displayed on the Slido platform as well. So with that, I please ask you to join me in a round of applause for thanking our great speakers for a great presentation. I would like now to move to the next set of speakers. We're going to have in rapid succession 2 lightning talks. And as I introduce the speakers, and please ask them to join me here on stage. Please, you're welcome to join me. I would like to start by introducing and inviting here on stage Ms. Rumeysa Savran from the University of Technology of Nuremberg, and she will be giving a lightning talk on persona-based auditing of geopolitical bias, just to follow exactly the presentation we just heard, in large language models. Please, Rumeysa, you have the floor.
Sure. Hello, can you hear me now? Yeah, okay. So imagine 2 people asking the same question to same AI system about a conflict. So the question is identical, the facts are identical, and we expect to get the same responses for the questions, right? But unfortunately, my research shows that it is often not the case. As large language models become increasingly embedded in information environments, understanding how they adapt responses across users is becoming an important governance and security challenge. Current AI evaluation frameworks focus on issues such as safety, harmful content, factual accuracy, and robustness. Okay, these are important. However, they often overlook another question. How does an AI system change its response depending on who it believes the user is? So in politically sensitive context, this matters because AI systems increasingly shape how people access information, interpret events, and understand the conflicts. To explore this question, I developed a persona-based evaluation framework. I created 18 synthetic personas representing different political, religious, and regional backgrounds. Using controlled conditions and, of course, fresh sessions, I asked the same 6 questions to the multiple large language models. The only variable that changed was the identity described in the prompt. For example, when asked whether solidarity with Israel strengthens peace or prolongs conflicts, response varied substantially depending on the identity provided to the model. For some personas, solidarity was framed as support for security and stability, and for others, it was framed as enabling oppression and prolonging violence. Similarly, responses regarding Iran changed from portraying Iran as a defender of oppressed communities to emphasizing authoritarianism and regional destabilization. These differences were not limited to tone or wording. In many cases, the models emphasize different contextual factors, highlighted different moral considerations, and guided users toward different interpretation of the same issues. At this point, it is important to distinguish identity conditions response adaptation from bias. So bias being just described, and I don't want to go over it because they did it really good. But the difference is that in identity conditioned responses, adaptation describes how an AI changes its framing, reasoning, or conclusion based on who it believes it is speaking to, regardless of whether that change is beneficial or harmful. So my research doesn't primarily evaluate whether these responses are right or wrong. Rather, it examines whether the same question receives different answers based on the user's implied identity. So this creates a unique challenge for evaluation. Traditional audits often assess model outputs one response at a time, yet personalization effects can only be observed through comparison. A single response may appear balanced, reasonable, and factually grounded when viewed in isolation. The divergence only becomes visible when identical questions are tested across multiple user identities. So as a result, it is important patterns of adaptation may remain invisible not only to users, but also to developers, auditors, and regulators unless they are explicitly measured. These findings expose a potential gap in current AI evaluation practices. Most frameworks examine whether a model produces harmful content or factual errors. Far fewer examine whether the same model presents substantially different narratives to different users. As AI systems becoming increasingly integrated into information environments, these raises important questions for governance, oversight, and information integrity. If AI systems personalize responses on politically sensitive topics, then transparency requires more than evaluating individual outputs. It also requires understanding how those outputs vary across audiences. So in conclusion, current evaluation frameworks should assess not only what AI systems say, but also how their outputs change across different users. Persona-based evaluation offers one practical and scalable way to identify these patterns. Because as AI increasingly shapes how people understand conflicts, evaluating outputs alone is no longer enough. We must also evaluate how those outputs change depending on who the system believes it is talking to. Thank you very much.
Thank you. Thank you, Rumeysa, for sharing with us, although very briefly, a very interesting research and your findings, and I'd love to know more during the break. Thank you again. I'll now like to give the floor to Vandana Kaur, who will be giving us a lightning talk on breaking the black box, a standardized lifecycle model for adversarial AI testing. And Vandana, you are with HackWIDR, so you have the floor. Please take us away.
Hi, everyone. Thank you so much for having me here. It is an absolute honor to be here today. I'm Vandana, and I've been working in AI safety and application security formally for the past 2 years or so, but I would best describe myself as a professional curious cat. I'm also 18, and that's relevant here because I am from the generation that will live longest with the decisions that are made in rooms like these about the way that AI is tested and governed and deployed in defense contexts. And I'm saying that because it changes the urgency of a specific technical gap that I want to spend the next 4 or 5 minutes on. AI in defense and security contexts is where cybersecurity was in 1990. We have no discipline yet for discovering and remediating vulnerabilities in these systems before adversaries do. But what we have instead is ad hoc red teaming, which is essentially a fancy way of evaluating AI systems against benchmarks made up of adversarial inputs. We still evaluate AI systems the way that we grade exams, once before deployment and never again. But AI security is not a benchmark problem, it is a life cycle problem. If vulnerabilities emerge before, during, and even after deployment, as we've seen time and time again, adversarial evaluation cannot be a single event. It has to be a continuous process. So what I'm proposing today is a standardized adversarial AI testing lifecycle with 4 stages. Threat modeling before deployment, adversarial evaluation before release, continuous monitoring during deployment, and vulnerability disclosure and remediation after vulnerabilities are discovered. Most evaluations test whether a system works under the conditions that it expects, not whether it still works once an adversary knows what those conditions are. So if evaluation never anticipates how an adversary might actually behave, that is a threat modeling failure. And that gap is precisely what turns the notion of transferable and potentially universal attacks from simply machine learning findings to security problems. Operationally, transferable attack means that an adversary doesn't need access to your system to attack it. A single universal attack suffix built only on open source models has already been shown to succeed against leading commercial AI systems with no knowledge of the target's architectures or weights. Now imagine the defense equivalent here. An adversary with only access to publicly available civilian models may already hold a master key that fits a military decision support system, an intelligence platform, or even an autonomous weapon that they've never touched. And that is precisely why adversarial evaluation can't stop at deployment. Models change, attacker techniques evolve, and deployment environments introduce drift and security issues in themselves. The system that you evaluated on day 1 is not the same as the system running at day 300, which leads me to a harder truth. We cannot red team our way to a safety or security guarantee when it comes to AI systems. Today, formal verification of neural network robustness remains computationally infeasible at production relevant scales. And this is one of the things that I've been exploring in my own research as well. But this is a structural characteristic of machine learning systems operating in such environments and the very nature of the problem that we're dealing with today. And this is precisely why the final stage of the life cycle matters. I've mainly been on the dark side for now, and I've talked a lot in terms of problems. But one of the main sources of optimism that I have in terms of AI and defense particularly is because we have been here before. In 1988, the Morris worm is estimated to have affected 10% of the internet's connected systems. And back then, the solution was not to make software unhackable. I mean, we still haven't been able to do that. The solution was to build institutions and processes around the inevitability of that imperfection itself. So that's why we had coordinated disclosure, continuous patching, and structured penetration testing throughout the development lifecycle. So when researchers discover a new attack technique, that discovery should trigger the same institutional response that a software vulnerability triggers today. That is disclosure, triage, and patching. But there are a couple of differences, like unlike a software patch, an AI fix might not bridge the gap. The same architecture can carry the same weaknesses. So remediation here means patching where you can and re-evaluation where you can't. So we need a security process that continuously improves systems even after deployment rather than pretending that deployment is just the finish line. So threat model, test, monitor, remediate, and repeat. And this is the point where I want to speak directly to all of the people in this room. No matter who you are, what you do, where you come from, you are the ones that are going to, test and evaluate and govern and deploy these systems that may decide in some future conflict whether a human being is seen as a combatant or a civilian. The stakes are high. The group of governmental experts on autonomous weapons has been asking how we maintain meaningful human control. I believe a part of that answer is epistemic. You cannot control what you cannot evaluate, and a black box in a security context is a governance crisis. So without reliable and realistic evaluations throughout the life cycle, we cannot make credible commitments to the safe use of AI in international contexts. Cybersecurity became a discipline when we stopped asking how to build perfect systems and started building processes for imperfect ones. A standardized adversarial lifecycle doesn't promise you perfect security. It doesn't even solve AI security. But what it does is it turns AI security into a discipline instead of a gamble. And in defense context, that is the difference between governance and wishful thinking. I opened today's talk by telling you I am from the generation that will live with the decisions of this room. So we are the people who will spend our careers running this life cycle. So give us a process worth inheriting. Thank you so much.
Thank you, Bandana. Thank you, Rumesa, for joining us on stage for these two inspiring lightning talks. I hope you'll stay with us for the rest of the day. So if there are any questions, please feel free to approach them at the margins. Thank you so much. I would like now to invite here on stage our speaker for our second deep dive of this morning, Ben Fawcett from Advai. Hi, Ben. Welcome. Thank you for joining us. Ben will present Advai's model arena, redefining how defense evaluates and procures AI. So I think everything we heard this morning was the perfect setup for your presentation, Ben. So please take us away.
Couldn't agree more. Thank you, everyone, for the speakers that have come before. And good morning, and thank you for having me back for the second year running. Last year, I spoke of the need for technical validation of AI. And in this brief, I'll reflect on some of the lessons that we've actually learned over the last 15 months as we started to implement some of these kind of technologies that I talked about. I'll frame these lessons around the model arena, a technology developed by Advai with support from the UK government and now in use by the UK Ministry of Defence. And the argument that I want to make is quite simple. AI is moving faster than the processes we currently use to evaluate and govern it. And this creates a problem for most AI stakeholders, from policymakers to developers to those accountable for those systems. Slide, please. Historically, technical decisions have followed a fairly linear path. Define the requirement, assess the market, procure a solution, test it, approve it, deploy it, and then monitor it through periodic review. That process assumes stability. It assumes the thing that we assess at one point in time remains broadly similar to the thing that we later deploy and operate. And it also assumes that we know what good looks like from the start. To riff off the previous brief, we need to understand how to monitor an imperfect system. AI challenges both of these assumptions. AI systems are not static products. They are made up of components that change: models, prompts, data sets, retrieval pipelines, integrations, user workflows, and deployment environments. A small change to any one of those components or conditions can change system behavior fundamentally. And for governance, the question is no longer simply, can we approve the AI system? The harder question is, can we maintain confidence in that system as all of those conditions change? And that is the decision problem that Model Arena has been developed to address. In high tempo or adversarial environments, this becomes especially acute. Capabilities can change weekly, threats can evolve faster than assurance cycles, and a system that works today is almost certainly going to be less effective, less safe, or less secure within months, if not weeks. And many current assurance processes still rely on static evidence, such as documents, review boards, supplier submissions, and point-in-time tests. And these are snapshots, which can be useful, but a snapshot cannot govern a moving target. If the system changes faster than the evidence, then confidence decays. Procurement teams may be choosing between supplier narratives rather than comparable proof. Governance boards may only see risks after important development decisions have already been made. So the challenge is not to replace governance or remove human judgment. It is to create an evidence mechanism that keeps pace with AI. And that is the core proposition. Model Arena enables better AI decisions by making evaluation continuous, comparable, and evidence-based. This is not simply about testing. It is about generating decision-ready evidence for responsible deployment in high-risk, high-tempo, or ethically significant environments. Slide, please. Slide. Sorry. The ethos of Model Arena is captured in one phrase: better evidence, better decisions. In AI, decisions are often made under uncertainty. And what we're seeking to do is reduce that uncertainty by creating a common evidence baseline across 4 moments in the AI lifecycle, which might be familiar: testing, evaluation, monitoring, and promotion. The first is testing. Candidate models, components, or suppliers can be benchmarked against the same requirement. That matters because supplier-led evaluation is often difficult to compare. One supplier may provide accuracy figures, another a demonstration, another a technical report. Those may all be useful, but they're not the same as independent comparative evaluation. And the second is evaluation. This is where evidence is used to understand whether or not a system is ready to progress. Has it met a required threshold? Where is it failing? And can those failures be mitigated? Evaluation should not only produce a pass or fail, it should also produce insights. The third is monitoring. Once an AI system is in development, pre-deployment, or operational use, it still needs to be understood. Performance may drift, costs may change, safety issues may emerge, and security risks may evolve. The overriding premise is that trust should be maintained, not assumed. And the fourth is promotion. Every meaningful change should be capable of being re-evidenced in a relevant time frame. A new model, a new prompt, a new data source, a new user, a new retrieval area, or a new deployment context. Each change can alter the risk profile, so the evidence should be refreshed when that change happens. I use the phrase decision-ready evidence. The purpose of evaluation should not simply be to generate technical metrics. They need to support real decisions and enable any decision maker, especially accountable ones, to ask better questions. Slide, please. I'll now give a short technical overview. And at its core, Model Arena provides a secure, independent evaluation environment. Candidate models, components, or capabilities are brought into that environment via a secure ingestion mechanism. They may come from different suppliers, use different architectures, or be at different levels of maturity, but once inside of the environment, they can be assessed against a common framework. Importantly, evaluation is separate from the supplier's own development process. A separate evaluation dataset and process gives the decision maker an independent perspective. Within a Model Arena, those systems can be evaluated side by side, whilst we can support analytical deep dives that investigate the key security, safety considerations, as well as the operational features that may or may not be important. Decisions can see which systems are genuinely performing against the requirement, whether or not that's two comparative systems or multiple versions of the same system. And feedback can then be provided to submitters so that the development actually improves. The evaluation regime is configurable because not every use case requires the same evaluation burden. Some systems may need intensive safety testing, others require adversarial robustness testing. Some need ethical or bias-related environments, and others may simply need to prove basic performance before deeper testing is justified. And it is essential that this evaluation framework reflects the decision being made, accounting for operational context, risk profile, system maturity, and whether the decision relates to procurement, assurance, or monitoring. Evaluations can also run at different cadences. Some tests may run frequently to provide rapid feedback. Others may run at milestones. Others may be triggered by a change, such as a new Git push, a model version, a new data set, a new prompt, or a new deployment environment. But the point is that the evaluations become repeatable, and they can be run again and again as the system changes. Therefore, instead of waiting until the end of development to discover whether a system is safe or secure, we can track evidence throughout that development. And instead of treating deployment as the end of assurance, we can continue to re-evidence the system as it changes through operation. Slide, please. This leads to one of the most important parts of one of the most important lessons that we found, the necessity to rapidly configure and reconfigure the testing suite. Many current approaches to testing we found are too static. A test is designed, configured, and run, but by the time the operating context, threat, or model changes, that test may no longer be the right test. If the context changes weekly, but the testing approach takes weeks to update, then the evidence base is already behind the system it's meant to assure. There's also a second issue. A single test provides only part of the picture. I'm not technical, but the researchers that I work with are very fond of pointing out that AI is a multidimensional problem, and any individual test only gives us a two-dimensional slice. It may tell you something useful, but it doesn't tell you enough on its own. When you're looking to apply multiple two-dimensional slices, the burden of testing can become quite overpowering. One test may tell you about accuracy, another about robustness, another about safety, security, etc., etc. And in Model Arena, we configure those multiple tests to generate an evaluation data set. That means that it's not simply a one-off test set. We can evolve this as the context evolves. As the threat changes, we can change or update the tests. As a use case becomes clearer, the evaluation metrics can become more specific. And as the model matures, testing can become more realistic and rigorous until it's supporting a model in operation. In sum, a single test gives a slice. A testing suite builds trust and confidence in safety and security. Slide, please. The next question is how we decide what to evaluate. I've just realized these are PDFs, so my animations don't work. One of the most important things we've achieved is the ability to translate the policy, legal, and regulatory requirements into measurable evidence. Policy and regulation often operate at a high level of abstraction. We may say an AI system must be safe, secure, reliable, robust, ethical, and appropriate for the context in which it is used. And these statements are absolutely necessary, but they do not, on their own, tell a procurement team which supplier to choose. They don't tell an assurance team whether a system is ready. They don't tell a technical team what needs to improve. And they don't give a governance board enough evidence to make a confident decision. So high-level obligations need to be translated into testable requirements. That process begins with the use case, and I'm not going to go through every question, but, for example, what is the system intended to do? Who will use it? What are the potential failure modes? Who is impacted by this system? The questions do vary, but for the most part, we've found that the knowledge is not instinctive. Multiple workshops are required to really extract this level of detail. From there, we define what the system needs to demonstrate, and therefore what we need to evidence. Does it need to detect an object at a defined distance in a defined operational context? Does it produce consistent outputs? When we have good enough answers, we define the tests and validate our testing approach with legal, policy, and operational stakeholders. The specific test will vary, but the principle is consistent. I also oversimplify what is an intensive process to establish a representative set of testing statements. In this sense, Model Arena acts as a bridge. It allows policy, governance, and assurance expectations to be reflected in an evaluation framework that can be run. It reduces the translation burden on the development teams, albeit it doesn't reduce their accountability, but it does give them thresholds to achieve and technical insights to consider. Developers should not be expected to interpret every legal policy and regulatory expectation from scratch. But equally, policymakers and regulators cannot simply write high-level principles and assume that they will automatically become engineering practice. In high-risk environments, broad claims of responsibility or compliance are not enough. Decision makers can now be told what was tested, why it was tested, what threshold was applied, what evidence was produced, what risks remain, and when that evidence will be refreshed. Slide, please. Now, procurement is one of the most immediate and powerful use cases for Model Arena. AI procurement is difficult because suppliers are often very hard to compare. They may use different metrics, different databases, different assumptions, and different demonstrations. They also may perform well in controlled environments, but fail in operational ones. And they may not expose the failure modes that matter most to a buyer. This creates a risk that procurement decisions become claim-based rather than evidence-based. For instance, a supplier may sound convincing, they usually are. A demonstration may look impressive, it usually is. A written submission may be strong, but the decision maker still has to ask, how do we know that this system performs against our requirements, is better than the alternatives, is safe enough, secure enough, and suitable for our environment? Model Arena enables these candidate systems to be evaluated against this common evidence standard. Multiple suppliers can be compared on a like-for-like basis. Our record currently is 9 simultaneously within 45 minutes. The questions change from which supplier looks most convincing to which solution performs best against our requirements. That's a fundamentally better procurement question. It allows decision makers to assess not just headline performance, but broader suitability across robustness, reliability, safety, security, cost, operational fit, and the ability to improve over time. We also enable a more dynamic procurement. Instead of choosing a supplier based on a static submission as part of a contractual tender, buyers can run competitive evaluation events, invite multiple suppliers to submit models, test them against a codified use case, maintain a live leaderboard if required, provide feedback, observe improvement, and down select based on evidence. And this is particularly valuable where the buyer does not yet know which technical approach is best, i.e. they don't know what good looks like. So rather than making an early bet, we've found that we can enable decision makers to compare approaches before committing, thus reducing procurement risk and improving market intelligence. And decision makers can see what the market can actually deliver and where systems fail under security or safety evaluation. For suppliers, this can also be constructive. Crucially, evaluation can't just be punitive. If structured well, it becomes a feedback mechanism, and suppliers can learn where their systems are failing in order to improve, resubmit, and demonstrate progress. That is evidence-driven procurement, and for high-risk AI, it's a stronger basis for responsible acquisition. Slide, please. The same mechanism that supports procurement also enables evaluation-driven design. Traditionally, development is described as design, build, test, and that works when the system is predictable. But AI systems are not always predictable from design documentation alone. A model may behave differently from expectation. A prompt may produce unexpected results. A retrieval system may introduce hallucinations, and a model may perform well on average, but fail badly in edge cases. A system may meet a performance metric, but still fail a critical safety requirement. If evaluation happens late, feedback arrives late, and late feedback is expensive. Worst case, there's no money left, and an expectation of delivery has already been established. Evaluation-driven design changes this sequence. Instead of treating evaluation as the final gate, evaluation becomes a continuous source of feedback. The pattern becomes design, evaluate, improve, evaluate again, and improve again. Evaluation, therefore, becomes a steering mechanism. It does not simply tell you whether the system passed at the end. It tells you how the system is developing, whether or not it's moving towards the desired threshold, where the failure modes are, and whether the latest change improved performance or created new risk. Development decisions become evidence-informed. Technical teams get faster feedback. Suppliers get clearer targets. Assurance teams get earlier visibilities, and decision makers can see whether or not the system is feasible much earlier in the development cycle in order to make effective investment decisions. This is especially important in high-risk or ethically sensitive systems. Safety and security can't be bolted on at the end. They have to be integrated in how the system is designed and improved. Evaluation-driven development helps make that possible, so ethical requirements can be considered alongside operational suitability. But the goal is not to slow innovation. The goal is to make it faster, safer, and more evidence-based. So when evaluation is automated, it can accelerate delivery. Teams can learn earlier, stop investing in approaches that may not be working, and can generate evidence as they go to arrive at decision points with a stronger basis of approval. In practical terms, this means that we can structure model development through stages. We can start with performance, move through reliability and robustness and into security, and actually make increased investments as we move through discovery alpha beta, based on the actual evidence that the system's going to perform in the way that you need it to. Slide, please. The next point is integrated governance, and this is where we move beyond procurement and development and start to change how oversight operates. In many organizations, we've found that governance is concentrated into a small number of major review points, and those review points do matter. They provide accountability, allow senior decision makers to assess risk and create formal approval moments. But they're often too late to influence the most important development decisions. If safety issues are only identified at the review board, then the system may already have moved too far in the wrong direction. If ethical concerns emerge after procurement, then options may be limited. Evidence can be generated during supply evaluation, development sprints, and pre-deployment assurance, as well as whenever a system changes, in order to make these decision mechanisms much more better informed. The data scientist sees evidence earlier, the supplier receives feedback earlier, the assurance team sees whether or not thresholds are being met, and the governance board sees a clear history of performance risk and change. Continuous evidence lets risks surface at the lowest practical level, whilst giving senior forums a stronger evidence base for approval decisions. Therefore, governance becomes integrated, not just concentrated at major milestones, and every sprint can become an oversight opportunity. The answer is not to remove the existing controls, but it's to supplement them by an evidence mechanism that shows how the system actually behaves. And that creates a better basis for accountability, proportionate intervention, and delegation. Because not every issue, therefore, needs to go straight to the most senior board. Some can be handled by development teams, some by project leads, some require assurance review, and some require senior decision making. This is particularly important in operational environments where speed matters. If every AI-related safety and security decision has to return to the most senior governance forum, then the organization will move too quickly. But if delegation happens without evidence, the organization takes on unmanaged risk. Continuous evidence gives us a middle path. It allows senior leaders to define boundaries, thresholds, and conditions under which delegation is appropriate. It gives operators and delivery teams clear permissions to act within those boundaries and provides an evidence trail showing when those boundaries are being respected, approached, or breached. Model Arena enables governance to become more distributed without becoming less accountable. This brings us to safety and security in operation. Safety and security are not static properties. A system that is safe in one context, slide please, may be unsafe in another. And a system that is secure against one threat may be vulnerable to another. A model that performs well under one data set may behave differently when the data changes. So therefore, safety and security can't be reduced to a single approval decision. They have to be understood over time. At any stage of the life cycle, continuous evidence makes emerging threats and risks visible earlier to give decision makers the ability to see whether or not system remains within acceptable boundaries. And when it does not, they have a clearer basis for deciding what to do next, whether or not that's to pause development, pause deployment, return to development, run further evaluations, add controls, change the operating envelope, or accept residual risk with a clearer understanding of the evidence behind it. Slide, please. Let me conclude by returning to the central challenge. AI systems are changing faster than traditional procurement, governance, and assurance processes. Point-in-time assessments can still be useful, but they're not enough to govern a moving target. Static documentation is not enough. Supplier claims are not enough. One-off testing is not enough. Periodic governance alone is not enough. Decision makers need a new way to generate evidence that is secure, repeatable, comparable, and continuous. And these are lessons that we've identified whilst developing Model Arena and what it seeks to resolve. It creates an evidence infrastructure for AI. In procurement, it allows candidate systems to be selected based on evidence rather than assertion. In development, it allows evidence to guide improvement. In validation, its evidence is specific legal, policy, and regulatory requirements. And for governance, it refreshes evidence throughout development and operational. Ultimately, safe and secure AI is not achieved through occasional assessment. It is achieved through continuous evidence and continuous oversight. Thank you very much.
Thank you, Ben. I have a couple of questions directly to you, and I'm going to read them one after the other, and then perhaps you can give a combined answer if you can, mindful of time. So the first one reads, automated model evaluation is a fascinating and promising approach to speeding up development. However, connecting from the first deep dive on bias, how do you create automated, robust evaluations for both socio-technical and socio-cognitive perspective in both designer and operator? That was the first question one. Sorry, it took me a minute. The second question is the following. How much blame for regulatory latency regarding AI should be attributed to tech illiteracy of the average policy or lawmaker, and how can this problem be resolved?
So to answer the first question, for us, this comes down to defining the test statements and actually understanding and bounding what the system is, what's required from the system. And I think whether or not there is a strong requirement to kind of measure those social and ethical considerations, because every system is unique, every context is unique. We can't, and I think it's impossible, both from a computational and human perspective, to test absolutely everything. They need to be prioritized and scaled based on other conditions. Automated testing is absolutely fascinating, I agree. What we are basically seeking to do is reduce the human in the loop as much as possible when it comes to that, but do it in a way where we can assure the confidence of what we're doing. And at the moment, the majority of our human input is in defining those testing statements in order to understand what is required. And this directly links into the second question. I don't think it's about attribution of blame. I think it's about education, because this is a completely new domain, let's face it, with new considerations and new requirements, where those in those leadership positions simply haven't had the experience yet. I think it's important to make sure they're brought up to speed, but it's also important to make sure that they don't have to be told and they don't have to learn everything. They have to learn what is required for their decisions. A 20-hour education framework is not required for a senior decision maker who frankly doesn't have that much time in their diary, but they need to know within an hour, I would presume, of the right questions to ask in order to inform the right decisions.
Thank you. I have another question for you, which reads as follows. If governance is supposed to be driven by continuous evidence across procurement, development, validation, and deployment, who decides what counts as sufficient evidence at each stage? And what is worth measuring in the first place? And on what basis do those measurements become binding authorization? Many elements in the question, feel free to pick.
Yeah, so really good question. I think what we're finding is every organization has different decision workflows. There's no real need to disrupt those. What we're seeking to do is augment them through a technological solution. What we do find, I want to avoid basically just making the same statement about testing requirements to bound things, but what we are finding is the decisions evolve from what is it we need to develop, buy, or procure, to are we confident that this will achieve the task that we want it to, you know, how will the situation change and how is that going to affect the AI system? They are very different decisions. The first ones are at the beginning of discovery. The latter ones are as you're looking to deploy and then monitor that capability. The evidence required to support those also changes. And we are finding that there's no real need for security tests at the very beginning when you're really looking to measure baseline performance. You kind of want to make sure that a system is feasible, as in it's probably going to do the job you want it to do, just through relatively basic performance testing before you do kind of in-depth security stress testing. And that it's a good practice, I think, is to slowly add on the test as you go through deployment and development. And I think part of that governance process needs to define, you know, what is the evidence that your stakeholder, your accountable person needs to see and wants to see. And that links back into the education bit, right? You know, it's you provide recommendations, you provide advice, you suggest an agenda, and then you provide the evidence for that.
Perfect. Thank you very much, Ben. I don't know if we have time, maybe 1 more minute for one last question, which I hadn't had the chance to publish yet, but here we go. Do you have a similar tool that could cover the convergence of AI with other emerging tech, such as AI and bio, but can be AI and anything else? How do you see this model potentially working with convergence of different technologies?
Short answer, yes. You know, it's agnostic. It's agnostic across AI domains. It's agnostic across industry. Advise secondary industries, financial services. We do a lot of work with the UK Financial Conduct Authority, so there is that generalizability. A key thing to make sure that we integrate with technology and emerging technology it's basically lumped into the system requirements of a model. You know, I didn't go too much into it, but a trained model doesn't sit in isolation. It needs to be defined within the context of the overall system that you're operating it in. And that's where you link in significant kind of cyber considerations. But it's also where you can represent those considerations in the testing mechanism. For example, you know, represent different types of compute architecture in order to see how they'll fare, in order to do cross-validation, and, you know, represent maybe different kind of compute architectures, emerging ones like, say, quantum, even though I don't fully understand it, in order to make sure that kind of the AI ultimately is performing as required on those mechanisms. We've designed things to be modular, so we can evolve with that as the time comes.
Thank you, Ben, both for the presentation and for taking the time to answer the many interesting questions we had. Please join me in a round of applause and thanks, Ben, for your participation. Okay, we will be resetting the stage very quickly. We managed to be on time, great. And we will be resetting the stage to lead us into the second executive level fireside chat of the day between our Director Robin Geis and Mr. Rafael Grossi, the Director General of the International Atomic Energy Agency. I'm informed he's just about to enter the building, so please stay where you are. Don't leave the room as we reset the stage to take us through this very interesting fireside chat. In the meantime, I see Robin is already here, so we'll be waiting a couple of minutes, but please just stay in the room. Thank you.
So, Excellencies, distinguished delegates, ladies and gentlemen, we're very honored to have the Director General of the IAEA, Rafael Grossi, with us today. We will engage in an informal fireside conversation. Director General is very happy to take questions from the floor, so please be active in using the Slido system. And the first question, Director General, I mean, AI is all the talk now. Is all the talk in Geneva, was a lot of talk in Evian, is all over the news. It's clearly the transformative technology of the 21st century. And there's huge opportunities, but also significant risks. And I think a good portion of uncertainty where exactly things will land. And so to kick us off, if you can give us your general take on the state of play, AI in international affairs, please.
Well, thank you very much. Good morning, everybody. It's great to be here, to be back here with you, with UNIDIR, and in Geneva, a place which is very close to my heart. I served here for a long time, at a time where we were actually negotiating disarmament agreements. Believe it or not, this happened, and I was there. So great to see you. I don't know why we have a gavel here for a fire. This is the first fireside chat that I have with a gavel. I don't know. Maybe you can use it as well. As this is informal, we can share it. All right. But anyway, so great to see you, delegates. I understand that this is an audience where we have national delegations. I see nameplates, but I also see academia and civil society. So I think it's very nice that we can have an informal conversation. And in this kind of formats, as you were saying, Robin, the best part is the exchange, where we can hear from you and we can give you some points. You said it when you expressed that, of course, currently everybody is talking about artificial intelligence. We have a particular perspective on it from the IEA perspective, which is the one I perhaps can share and add something useful to the conversation. And I like to say, when we refer to AI, that for the IEA and for nuclear science and technology, let's use a big umbrella here. For that, we are present at the head and tail ends of the discussion. And I use the head and tail analogy in the sense that there is use of AI in nuclear, and AI needs nuclear. So it is in this sense, and I will try to explain what we mean by that. From the perspective of how we integrate AI in our activities, I think the same could be said for every other walk of life. AI is already, whether we like it or not, is already pretty much present in everything we do, in our smartphones, in our banking, in the transportation systems that we use, in the traffic light systems that are, governing the traffic out there, in everything. So this idea that AI is something new that is going to be, creating a revolution, it's a bit exaggerated, in the sense that AI has been there already for a long time and is going to continue to be there. What we are looking at is more in terms of trends and perhaps some parameters for the activity, to the extent that can be applied. So, to tell you or to explain a bit how IEA is integrated in what we do, I have to refer to a mandate of an agency that is technical, of course, but that has a wide spectrum in terms of what we do. We are on the headlines, and in particular these days, on issues that have to do with non-proliferation of nuclear weapons and how we perform this activity, which is a highly technical activity, which also benefits from AI. But I think it is here, important to stop for a second, because on occasion, some observers say that, or are afraid that we are going to be using artificial intelligence to, have reports and assessments on whether country A, B, or C are developing nuclear weapons or are engaging in activities that are, of course, at variance with their non-proliferation commitments. And of course, this is totally absurd, right? I say it very, very clearly because there have even been stories in the press about us having certain companies helping us do this or that. Of course, this is absolutely science fiction, and it doesn't happen. But of course, AI is very, very important in helping us, our inspectors, our analysts, to sift through hundreds of thousands of pieces of information, images, test results, and things that can be subject to an analytical ordering and systematization with AI tools, just as a bank would do, or a sports club would do with the contributions of its members. It's a matter of using the information. And for us, this is critical as well, because we, as everybody else, and especially in the UN system writ large, we have an ever-growing portfolio of activities without reduced or reducing amount of resources, money. Which in the case of nuclear is not necessarily linked to the current trends and reductions in funding that you can see here or there. It may be, but not necessarily in every case. For us, it has to do, for example, with the growth of nuclear activity, civil nuclear activity in the world. We are in a world where, as you know, nuclear energy has captured again a lot of interest everywhere. And so there are not only plans, but more nuclear facilities are there. And of course, the whole building, the whole edifice of nuclear non-proliferation rests on our ability to tell everybody that it's fine. If you are going to have more nuclear reactors, it's fine. If you are going to have small modular reactors, another talk of the town, the global town, then our inspectors are going to be able to be on top of it. So here, I would say there is a very clear point in AI supporting our human experts go through information and be better prepared to exercise their judgment on what is happening out there. So in the case of nuclear safeguards, I think there is no doubt that this is an important case. And for those who are interested, a rendezvous in Vienna in November. We have our Safeguards Symposium. This is one of the most, for those who like these things, one of the most fascinating meetings that are held on these issues. And we are going to be devoting a good chunk of those discussions I'm with my chief inspector, who will not allow me to lie here on the first row. Max Aparo from Italy, a great expert, and the world is safer because we have guys like him. So, by the way, so we are going to be having this discussion. So maybe for those who like or would like to explore deeper into how nuclear verification and safeguards is conducted, and to what extent AI is permissible or is used. This is one. But the same applies to nuclear safety. As you know, nuclear power plants are extremely complex operations, and there are myriad functions that use AI for their safe operation, and we also use it for analysis. It is also interesting that we also use this in the other side of our business, which has to do with nuclear applications, which are so important, especially for developing countries. As you know, the IEA does oncology, nuclear medicine, radiotherapy, medical imaging. All of that is nuclear, and all of that the IEA does. Transfer of technology, capacity building in developing countries, and this is also a tool that helps us enormously. We do a lot with the axis AI and food security. You know that through isotopic tracing techniques, we help countries not only check on the security of the food chain, but also developing drought-resistant seeds, or seeds that offer higher yields in parts of the world where there is very scarce water. So all of these are things that I wanted to mention here, because frankly, for me, it's always important to take these high-level discussions and bring them down to how they affect us in our daily lives. So this is the part of when AI is helping us in a decisive way carry on with our mandate. This is a very important part. So if you want the head or the tail, but one of the two sides that I chose in the beginning of the conversation. But the second, which is very important, and this has financial, economical, and also technical dimensions, is the fact that AI desperately, I use the word, needs nuclear energy. Why is this so? As you know, AI is based on data centers. Data centers have become essential for economies. So don't think immediately a data center is for banks or for financial gain. Data centers are fundamental for every economy. And when I travel the world, and when I'm in Africa or in parts of Latin America, data centers are so important for them to manage their economies, to bring the infrastructure they need, and so on. And these facilities are tremendously energy hungry. They consume enormous amounts of energy. So those who are developing data centers immediately are looking at the grid and seeing whether they have the kilowatts and the kilowatts that are necessary to do this. So what we see is that companies all over the world, all the big names, Google, Meta, Microsoft, and by the way, again, last December, so still you could not be there, but the proceedings are there. We organized a conference in Vienna on AI nuclear, the specific nexus, nuclear energy and AI. And we had, as I always like to do, I brought those doing it, not us, but people from all these companies. And of course, this is what they're doing. And as you can see, if you follow these issues, contracts are being signed by companies with companies that are new in the business as well, that never built a reactor, but now are running to license new designs because, of course, this is profitable, but at the same time, it is needed. So as you can see, when it comes to this part of this conversation, in nuclear science, technology, applications, you have this on both sides. Then the other thing, which is so important, but perhaps we can leave, Robin, this one for the conversation, is the issue of the verification, the issue of controls, the issue, some use the word governance, and how, in our experience, this can or cannot be done, especially since some have said, why not an IEA for AI? ... Yes or no? We can discuss about it. Thank you very much.
Well, thank you, first of all, for drilling down on this reciprocal relationship between AI and the nuclear dimension in so many, so concrete ways. We have lots of questions coming in. I think, I mean, the convening here is very much about governance of AI, of course, and a lot of questions go in that direction. What role for the UN generally, and I'm summing up some of the questions because we got so many, what role of the UN generally in the governance of AI? And since you're here with us today, what do you think of this analogy that has been making the rounds of the IAEA for AI? Which goes back to thinking about what type of institution and model, CERN, IAEA, others probably that could help mitigate some risks. So what do you think of that analogy and the role of the UN, please?
Well, I think, of course, there's a lot of discussion and there has been some work already carried out. The Secretary General convened the panel. There have been people. There is a unit which is reporting to the SG, working on this. So I would not regurgitate what they have been doing. But I think in very general terms that when it comes to artificial intelligence, an ambition of a world governance on it is not realistic. I will be very clear on this. This is not realistic. And the worst thing that you can have when it comes to inspecting, safeguarding, checking on things is to have the illusion that you're doing it when you are really not doing it. And this is a marker that I would put to your consideration. It's very important to be sure that when you design or you believe that you are designing a mechanism for accountability and control, you are sure that you can see all the variables, that you can see all the design developments that are active out there. So my general approach, and it's not my responsibility now, is that one should have some circumspection about this. Again, because we do not want to be creating structures that are perhaps very happy with what they do, but they are not doing what is required, if this is understandable. And I would like to bring an example of my disarmament days on this. I've been doing this for 40 years plus. And I remember the discussions we used to have on the possibility of having verification of the biological weapons convention. I was during those discussions, and around the room, I'm sure that some of you have been familiar with those discussions. We have the BWT convention, and especially I negotiated on behalf of my country, of course, was one young negotiator of the Chemical Weapons Convention. And I went on to work for the OPCW as chief of staff for some time. So there was, at the time where we were negotiating things here at the CD, the CWC included. So in the aftermath of that negotiation, or in parallel with that negotiation, there was a lot of enthusiasm that we had the CWC. There was a huge verification annex, and we set up an inspectorate, and an international organization saw the light. Curiously, the headquarters of the OPCW is a half cycle like this. So people were saying, well, you have to complete it with the biological OPPW. And of course, that effort led to nothing. There was a lot of frustration at that time. And of course, now we have very good work carried out by our colleagues in the ISU, and it's very important that that is done. But one of the elements that were considered at that time as frustrating the effort, in which many countries and delegations were invested, is that the overall conviction in the end was that we could have a system, but it would be a system that would never be able to catch everything that you had to, or that you must, in order to be sure that you have some system that is going to give you the assurances that you're looking for. So instead of a verification system, the illusion of having a verification system. And whilst the comparison might not be perfectly alignable, I think it gives us a bit of food for thought. Someone said, I remember, half-jokingly, well, we are not going to be able to catch every small refrigerator in every lab in some faraway place, while pretending to be verifying the official level 4 biolabs in some very respectable institution in a country. So again, the algorithmic space is a space which is different from the space of nuclear material, where you have facilities, where you have activities. Of course, there are intangibles as well. And I'm sorry if I'm getting a bit abstract here, but we have to, in order to understand what we are talking about, because we can get easily be carried away with this idea that, okay, this is this activity, we are going to check it. We are going to govern it. So, a lot of caution, I think, is necessary so that we do not run after, chimeras in terms of verification. So this is why when people say, may sound very flattering for us and for my chief inspector here, well, we need an IEA for AI. Well, as we say in Italian, piano piano, slow. Take it slow, and go into the the details of that. Where the analogy is valid is that we were able to establish an organization that is able to deal with a highly sophisticated technical matter, set out objective criteria, build an international inspectorate, which is impeccable and very, very, I would say, uncompromising, and deal with something that is very complex. In this sense, you can think, because I don't think there is a comparison with what the IEA is able to do in this regard. In this sense, I think I accept and I take the flattery of the comparison, but maybe I stop very quickly after that. Yeah, that'll be my long answer.
No, thank you very much. There's lots of questions about this analogy and also, the governance models that could work for AI. So I think you spoke to many of them. There's also lots of questions about verification and IEA experiences, of course, in inspection situations in high profile zones and what analogies can be drawn there. But then another set of questions is more general to what are the most salient challenges and priorities that you see when it comes to peace, security, and artificial intelligence. And then more specifically within that question, if you allow, so lots of questions about US-China dialogues, Track 2 dialogues, whether the UN could have a role in also hosting similar types of dialogues, and whether the 2024 US-China agreement on the non-use of AI in nuclear decision-making that was agreed in 2024 is something that could be built on today.
Well, I think these types of agreements are always very important because they set out parameters which may be seen as very general, but at the end of the day, it boils down to that. You can have a technical, more sophisticated expression of this, but what we really need as a human community, I believe, what we really need is an assurance that the principle of the human in the loop will always be there, that there will not be instances where systems kick in a way that circumvent human decision-making. So when you see two nuclear powers and two of the mightiest nations in the world agreeing to that, I applaud. I think it's okay that they agree on this basic principle. When it comes to a role for the UN, I think the same principle applies to this as to a peace negotiation or trade negotiations. It depends on the ability, the political, of course, willingness of states to engage with us, with the multilateral institution, and also on the ability of the multilateral institution to be at the table with realistic approaches that are in line with what the basic underlying trends are there. If we come to a table with a top-down approach, well, maybe you'll not get very far. One has to recognize that every agreement is the result of the political will of countries, including the UN Charter. Let's never forget. All right. So I think this is political, but it's a very basic principle that we have to bear in mind.
Thank you. Not only do I receive many questions, people here can also vote for their favorite questions. So we'll choose those because we have so many. Here's one, Director General. For you, coming from Argentina and leading a global institution like the IAEA, what has most shaped your perspective on cooperation between global North and global South countries in global security governance? What has most shaped your perspectives and experiences in cooperation between the global North?
Well, what I've seen for 40 years, there is no viable norm when it comes to issues of global interest where you don't have this kind of cooperation. So every time that this conversation has taken place, you had outcomes. And when this was not there, you didn't have them. Let's go for examples. Otherwise, this is all up in the clouds. When the NPT, since you are UNIDIR, let's stay in this. We can talk about other type of agreements. When the NPT was drafted, and first thing, and it relates to the previous question, is because the big ones said, okay, let's do something about this, all right? It was not something coming from outside. So we have to recognize this. But at the same time, there was a useful interaction, I will use contemporary words, with the Global South. Those days, we didn't call it the Global South. But the original, for those who know, the original norm didn't have anything related to peaceful uses of nuclear energy and the inalienable right, and so on and so forth. All of these things that are dearer to the heart of developing countries. Those things were not part of the conversation at all. It was more Article 1, Article 2, sort of Article 3 model for the NPT. You don't have nuclear weapons, you don't develop nuclear weapons, you don't transfer nuclear weapons. Okay, that was the deal. all right? But then it is through this dialogue and this cooperation that was taking place 500 meters from here that countries like Brazil and others, Egypt at that time, because it was not the CD as we know it now, it was the conference of the Committee on Disarmament. It was 18 nations at that time only, but some of them representing a little bit of the views of the South. So then there was a discussion where it became clear, thanks to these exchanges that were taking place, that for the norm, if the norm was to be global, there had to be some listening as well. And this is why we end up with an instrument that, warps and all is there, is one of the few, certainties in a world of uncertainty. So, yeah, that would be my answer.
Here, the most favorite currently in the room question is, if nuclear governance were designed from scratch today, in the age of AI and emerging technologies, what is the one thing that you would build differently? If it was nuclear governance designed today from scratch, with all the technologies that we have available now, what would be the one thing you would do differently?
Nothing. Because we have to recognize that the instruments give us the flexibility to deal with AI. Nothing, and I would even include in this the charter, the UN Charter. If we are going to be redefining our international instruments every time that there is, and we hope, and I am a big fan of technology and science, and I believe not in indefinite, but in constant improvement and refinement of technology and science. If we are about, redefining things and putting some word here and there, the timeless value of some instruments in international law is what makes them legitimate and valid even today. I would put the question, back to you in an inverted way. What is it that we cannot do because of some limitation in, I don't know, any telecommunication agreement or the charter or the NPT or the CWC or trade agreements? I don't see any limitation.
There's another batch of questions that goes to proliferation and non-proliferation challenges, obviously, since we have you with us today. There's lots of proliferation pressures out there. So could you speak also to the impact AI will have in the realm of nuclear proliferation?
Well, again, some pretty obvious, but I think this is going to be helping also the bad guys. And we have to be aware of that. It's not new because we are in a world where access to information has been there for quite a long time. So it is obvious that for potential proliferators that still exist and will continue to exist, the same tools that we have for good do exist, which means that we have, and we do have some elements to determine algorithmic developments and designs that can help our inspectors to see where something is coming from. So yes, the bad guys are getting stronger, but the good guys as well, thanks to AI.
Thank you very much. We're coming to the end of this fireside chat, but if you could leave us with an outlook and if ever possible with a recommendation to this audience that is for the next 2 days considering governance of AI in peace, security, conflict context.
Well, no, the first thing I would say is thank you. I think we need this type of conversation. I think it's very, very important. And this is why I was mentioning what we were doing and was extending a general invitation also to join us when, from the nuclear perspective, we are trying to have these discussions. the recommendations I could have stem from what I have been saying now, Robin. I think it's very important to have a feet on the ground approach, because when we design norms, we want norms that are really applicable and really global. We need everybody on board. This is very important. We also need norms that do not stifle research and development, because in any case, this is going to happen. So again, be ambitious in goals, but circumspect in approaches. And I think that is perhaps not a bad combination for this, and why not for life.
Director General, thank you so much for taking time today, for being with us, for sharing your reflections. That only now leaves one thing to do. If the audience will please join me in a round of applause to the Director General. Thank you.
Thank you very much, Director General, for these insightful fireside chat, and for everyone for your engaging questions. I now have the pleasure of seeing the rest of the morning until the lunch break. My name is Dr. Yasmina Fina from UNIDIR, and now I have the pleasure of welcoming Major General Dr. Pawan Anand to the stage for a deep dive on the governance of dual-use responsible AI systems. Thank you very much. Major General, we have 30 minutes. The floor is yours now. Thank you.
Yeah. Thank you, Yasmin. Excellencies, ladies and gentlemen, it's an absolute honor to be here, to be able to speak to you on dual-use AI and its governance. I am General Anand. I am from the United Service Institution of India and a mentor at the National Defense College, besides advising a few companies. Let's go to the next slide, please. So let me start with a situation which I pose to all of you here today. You see a bunch of people gathered at the end of a range forest, maybe for a particular purpose. What's the context? Is it evacuation, HADR? Is it a hostage situation? Or are there hostiles gathering for an assault? It's the context that really matters. Next. So if you have a drone in the air and you were to be observing them, and your AI would be selecting a specific bunch of people whom you would be targeting, either for evacuation or as hostiles, you have a fixed amount of time to decide what you would have to do. And that exactly is the issue which the man on the ground would face. Would you pull the trigger to deploy the projectile? Should the machine select, or should it be the human? And how much power with each of them? That debate is what matters. Next slide. So today I plan to firstly bring about the definition of dual-use modern AI, the dilemmas that we face in governing it, and how these systems slip through our governance mechanisms, and then the governance response in terms of identifying military potential in AI systems across the life cycle, a chain of responsibility, and then is there a possibility for some form of binding governance? Next slide, please. In the past few years, there's been a very sharp reversal in the kind of or in the format in which we approach AI and systems, scientific systems. They initially used to be military systems, which were very high-end, and then they would go towards civilian evolution. The reversal has begun lately, and AI has actually brought it about. Commercial AI today is the primary R&D military pipeline. And this reversal definitely shatters our governance models. Governance which is designed for spin-off cannot be used for spin-on. And therefore, transfers which occur by download or API calls happening in hours invisibly are going to be very difficult to govern. Next. So where exactly does dual use AI come in? Between the intersection of these two sets, you have the intersection set. That looks rather small though, but if you notice the ambiguous zone around it is much larger. And I would say it is that ambiguous zone which really makes it difficult for us to govern. You first have to identify it, you have to understand it, and then you have to apply governance on it. So there is a jurisdictional ambiguity. There is an ethical framework which diverges between civil and military. There's an accountability void. Verification is impossible. There's nothing physical here. It's all software. It travels easily. And the transfer speed is much faster than our speed of governance. Next slide, please. So how does a system become dual use? It's usually a very general purpose model which carries out tasks in the military which were never anticipated for it to be done. The open weights are the same. Public APIs and cloud compute is used. You just have to alter them a little bit. It's very diffused and it's easily accessible. The cost of repurposing it, fine-tuning it, prompting it with modest modification is very easy. Of course, as you move along, more capabilities emerge and attribution becomes even more difficult. So the crossover happens at certain defining points of the life cycle, and that perhaps is the place where we need to focus. So from a self-driving car algorithm, we could go to a rescue drone, which could easily, when you change the data sets and use the same model weights, you could turn it into an autonomous attack system. Next, please. Where do these life cycles diverge? So you see between civilian and military and the various life cycle requirements which I've given out over here. Much of it happens in the later part of the model. The first part of the model, in any case, cannot be identified as military if it's moving from civilian to military. But in the latter part, there is a high chance of discovery. When you've discovered it, you have to go back into the life cycle once again. So that's what makes it even more time-consuming and difficult, and you have to keep up with it. And let's not forget the decommissioning stage. Whereas in the civilian side, it's only data deletion. In the case of the military, it is sanitization, it is transfer of training data, and then it is also ensuring that there is no adversarial recovery of that data. They are separate, and agentic autonomy makes it even more difficult to govern it. Next, please. So why is it so difficult for us to draw this line? There are no technical fingerprints. The AI system continues to evolve in runtime, so your governance system cannot run at the same pace. There is a definitional vacuum. We've been talking about it for the last 3 days in the UNIDIR conference as well. There is no physical inspection which is possible, and I refer back to what was being discussed just a few minutes ago with the DG IAEA. And of course, most AI models are made for market optimization, and then they are mutated into military AI. And there's the example for you. It's probably one of those rare examples which I'm going to name during my presentation. Google and Amazon signed with the Israeli state the use of their cloud for higher efficiency. Where did it turn into arms control instrument? In fact, the compliance was for corporate service. So at one point, definitely, there has to be a change in the contract as well. So you have to govern it not just by the design, but the design intent at the mutation stage. How it adapts when there is transfer of learning and fine-tuning. There is no change of architecture. There is no export event. So how do you identify it? And finally, when it's deployed, again, there is no transfer event. So commercial models, clouds, and data pipelines can easily enter military use. They have done so. Next. So largely, an ungoverned surface is sought to be governed. The resolution of the UN affirms that the law applies across the life cycle, but that those governance issues would be only stopping at the factory gates, if I may say so. The Secretary General's report now addresses the other area of autonomous weapons. So we are definitely identified with the problem. The condition where we work is control, intent, it's invisible and irreversible. Certification is difficult, and it fails when it comes to capability and mutation. So can we come up with some concrete steps? Very difficult, but we'll attempt to do so. Next slide, please. So what are the dilemmas that we face and how does dual use slip through this governance mechanism which we work out for ourselves? How does it work from the boardroom to the operations room? Next slide. Well, I'm going to pick one example here, and that's right at the top. In September 23, Elon Musk personally restricted connectivity in Crimea. A private CEO taking a military command decision. Where do you have a governing framework for that? And then you see it across the spectrum. There are many places where identification algorithms get converted into surveillance and targeting algorithms. But I would say that the Starlink decision just a few years ago, 2 or 3 years ago, is a paradigm case. The military now depends on commercial infrastructure, which it cannot fully control. And the civilian platforms affects the military situation, which it cannot govern. Next slide, please. Now let's take a look at some of these tracks where we find it difficult to actually identify and move back and forth. And one of the most important ones is the influence of geopolitics. I may say that China and the US lead the pack when it comes to AI. They also lead the pack when it comes to talk about governance of AI. They do follow certain different paths, but they lead the whole pack. Then you have the middle paths, and I would place Europe, Japan, South Korea, maybe even India amongst the middle paths who have some aspirations to use. And invariably and inevitably, AI tends to move into the military field in all of these countries. And because of the use of AI there, with systems moving into the global south would also aspire for such systems. So while China has a very dense binding domestic regulation system, it institutionalizes military-civil fusion. There is a diffusion which could occur here. As far as the US is concerned, President Biden's executive order was reversed by President Trump, and now it is unbridled innovation which comes into play. I think the UNGGE especially is where the maximum inclusivity comes in, and yet it gets blocked obviously by consensus. So the environment is such that geopolitics defines contestation, weaponization across many domains. We must also remember that the pace of evolution outstrips speed of government. The strategic competition definitely incentivizes a rapid deployment over careful oversight. It's a race to the bottom. Next slide, please. We've been all talking about human accountability for the last 3-4 days. Human in the loop, human on the loop. Obviously, one of them is faster, one of them is slower in taking decisions. Oversight is what makes all the difference. So where is the human in all this? And how much time does the human have to take that decision? That is what defines it. So is this the fastest way? Is it acceptable? But meaningful human control must not be bypassed. But how does it work? Next slide, please. If you have only 20 seconds to review a target, is it sufficient time for you to satisfy the IHL requirements of distinction, proportionality, etc.? Accountability then diffuses. You pass on the responsibility onto an algorithm, but you put a human in the loop to say that he also took a decision. And as that decision time compresses, it becomes more and more difficult to fix responsibility. Is it exercising control, or are you laundering a machine's decision? Predictable psychology clearly says that the latter would happen. Governance must be then engineered to counter this as well. Next slide, please. Then there's cognitive warfare. How do you work across the entire spectrum? You see those 4 boxes which I have made over there. They run for defensive and offensive applications. They not only hit privacy of individuals, they soil reputations, but they also build narratives in the minds of your own people and in the minds of your adversaries' population. The main domain changes, the technology remains the same, whether it is social media or whether it is PsyOps. Next slide, please. How do you govern private security companies? Private security companies are designed for denial. States hire them, but don't name them. There is no IHL standing which governs them. Obviously, therefore, there is a vacuum of jurisdiction, and they use commercially off-the-shelf AI systems which are invisibly supplied to them. There is no signature, there is no record. So how do we make sure that we can identify, engage, review whoever operates it? How do we ensure that there is oversight of the autonomous capabilities of AI systems? Can we create a body for that? But how do you also look at organizations that get nationalized, such PSCs which actually get legitimacy through nationalization and get national protection as well? So once again, a very diffuse state. Next slide, please. So what's the governance response? Go ahead. These are the realities we must contend with. Intent-based control collapses because we are never very sure when it moves from civil into military. Consensus cannot be more important than proliferations. So somewhere we'll have to get together in groups and start deciding what we want to do. And national security carve-outs will obviously create loopholes. So if the EU Act does cover commercial activity, but makes a big exclusion for national security AI or defense-related AI, you've already created a niche which is separate. So obviously accountability dissolves across the vendor to the operator chain, and certification is difficult to keep up with the runtime drift which continues in the AI. So where's the answer? We need to do verification all along. And without verification, why would states sign? Why would they not? Why would they allow their forces to be exposed to verification? These are questions which we would need to answer. And there are limits that we will have to put to this. Verification without exposure definitely is a precondition for any agreement at all. So somewhere or the other, we need to come to some conclusions on verification. I think that's where the bottom line lies. Next slide, please. So let's start with step 1. How do we identify military potential? How do we classify whether an AI algorithm is going to be used for military as a weapon system? 5 dimensions. You got to look at the capability. You see how data suddenly crosses over. You remove one data, you put another set of data. There is the use of the API, which actually converts the original model into a different application altogether. There is a threshold where transfer learning takes place, and that is a seam which can be looked at. And then there is, of course, the physical domain interface, which hopefully would come at the last stage. So these are the dimensions that we need to work on and issues that we need to actually identify to see that a military system has been created. Next. So we go through this little model which keeps telling us how each algorithm, how each system would be used in a dual use format. and move from civilian to military at a given stage. Identify those seams, govern the seams, keep verification and certification at the seams. Next slide, please. Then there is this screening which would have to be done at various levels. It could be done at the national level with disclosures or internationally by inspection regimes. Very difficult for the latter, but at the national level certainly can be done and governments held accountable. So there is these 5 dimensions which are mentioned on the left column and what they would test. If you have a score of 3 out of 5, well, there should be some mandatory dual-use impact assessment. If it's 4 out of 5, there should be enhanced monitoring, nationally and internationally perhaps. And if it is 5 out of 5, I think Article 36, Geneva Conventions, review before deployment is, or something similar to that, needs to be brought in. Next slide. Then step 2 is governance across the life cycle. And as you see, I have 3 main issues in which I say safeguards and oversight need to be kept in mind. And at every stage of the life cycle, I have not shown here the ideation or the R&D stage, but definitely kept the design and framing stage. Various safeguards that will have to be kept, and oversight bodies may have to be created. The regulations that you make will have to be adaptive. So they too will have to grow, and models will have to be created between states, amongst nationally, as well as between states. Next slide, please. And the third step is concurrent chains of responsibility, visually accountability. So there has to be accountability at the vendor layer. We have to make sure that end user licenses cannot disclaim IHL accountability. I gave it for a civilian use, but it's turned into military use. I didn't do it. Well, that cannot be acceptable. Operational command will have to be exercised at a higher level. Higher authorities in the military will have to ensure that explainable dashboards are available. And they too would have criminal liability if this needs to be taken forward. Then procurement and certification. Cross-domain validation needs to be made mandatory. And there are certain thresholds which need to be specified before authorization is given for use of such weapons. And then, of course, there's the field operator, the man in the field who takes the decision. And we heard a lot about biases in the morning. Automation bias is not a legal defense. Next step, please. Can we go into binding governance? Can we go from voluntary pledges to legal mandates? Well, it's a difficult call, but if we don't do it now, then we've got to listen to the young lady who had come up in the morning to say, leave us a legacy. Next slide, please. There are certain existing levers which could be extended to dual-use AI, and you see them in blue. There is no doubt that IHL would be the binding flaw. Frontier model licensing is perhaps something we should be coming up with. We've just seen the US put certain restrictions on Anthropic, Fable 5, Claude 5. Whether that is a national prerogative or whether it's done from a humanity, from protection of humanity point of view, maybe both. I hope that's the case. But then you see the others which are in black. Can we have two-tiered laws treaty? Prohibit autonomous human targeting. That would be the ultimate goal. But would you be able to do it in a hostile situation? So maybe what you see at the end on the right-hand side, hard red lines on high-risk users. If not ban, at least find a form of restricting autonomous human targeting. And also nuclear command and control by AI. So I will not dwell on the nuclear aspects. We had the respected Director General IAEA who was here, but obviously controls of AI over nuclear assets would definitely be a very difficult proposition for all of us. Next slide, please. So the principles that we would have to use when we are moving from soft laws to binding regulations. So just to remind you, we're trying to see how we can make them more binding. We must first be aware, we must acknowledge the ambiguity of dual-use systems. We have to base the governance on context and on capability, not on the system or the platform itself. We must then reassess every time there is a context change, for which we must be able to identify where the context changes. Of course, there should be legal reviews, and human control is imperative. Next slide. And then these adaptive regulatory mechanisms could be brought into place with a reasonable level of consensus. Look at regulatory sandboxes. Supervised real-world testing would have to be done. Compute capabilities, whenever they cross a certain level, may be a trigger for reviews to be done. But then we have to be more open about where we go into higher computes. Licensing and registration would definitely make it more binding. Mandatory reporting of incidents, I think that's an easier one to go with. And finally, co-regulation and soft law, which is voluntary, must finally escalate to binding law. It's a high aim, but it's an aim worth having. Next slide. So what did Resolution 80 of 58 ask for? It asked for verification readiness in the work stream. And that's what I tried to address today. It talked about shared risk screening mechanisms. So I think if we can hold our focus with the resolution and with the Secretary General's report, build around what I thought I could bring out to you, maybe we will spend the next century not needing to verify physical weapons, but also verifying AI-based weapon systems, where we must verify capability that we cannot see. So if in a missile you had to cut a part of the nose cone of the missile and it could be seen through satellites, that was physical verification. In AI, there is no verification. The verification has to be within the digital domain, followed by physical capability and deployment. So with this, ladies and gentlemen, I rest my case.
Thank you very much, Major General. We do have some questions on the Slido. We do have 5 minutes, so I'll just ask the top questions that have been asked on the platform, and you can choose which ones you want to answer. But the first question that we have is, how does an actor's defense infrastructure reconcile the borderlessness of AI and associate tools with the concept of subjective territoriality? And then the other question that we have is, how does the multi-layer and multi-stakeholder nature of AI governance as in national, regional, and international further complicate the discussions on managing dual use? We have 5 minutes, please, Major General. Thank you.
Yeah, I think much of it was actually covered in what I spoke. So it is borderless. AI can travel easily across borders. There are no verification systems. You could put export controls onto physical systems. How do you put an export control onto something that can slip through digitally? So these are issues which will have to be identified at where I said the transfer takes place, and those transfer points will have to be monitored. Now, these will also have to be monitored digitally, and my sense is that there has to be a whole new field which works on this to see how mutations takes place. Right? Did that kind of get the question? What is the second question, please?
The second question is, how does the multi-layered nature of AI governance, so international, regional, and national, and multi-stakeholder nature of AI governance complexify the governance of AI in the context of dual use?
Yeah, again, it was partially there in my presentation, but yeah, this is something very interesting. It is multi-layered. I think the approach has to be both bottom to top and top to bottom. We have to keep talking about it at the international level. We have to work out at our national level. The technical layer has to be monitored at all times. The intent and capabilities have to be declared. Your transfer from one point to the other, as I mentioned, will have to be disclosed, and all across the layers, a series of checks would have to be identified for different kinds of systems. There would be different kinds of checks that would have to be brought in. And finally, I think it's the intent of most nations to come together and come to certain decisions. Most of the military powers today are using AI, and they will continue to bring more and more AI into their systems. I think all of them would use it responsibly. All of them would be creating governance systems within their national structures. There are institutional structures, and then there are like laws and legal aspects which are being built in. How each of them can discuss with the other, maybe we could come in with multilateral formats in forums such as this, but they could also be smaller groupings where some kind of coming together of ideas and some commonality of legal aspects could be brought in. So I think it has to be a multi-pronged approach. There cannot be one approach, and it has to cross layers whenever possible.
Thank you very much, Major General. We do have time for one final question. The question that I see on the screen is, all adaptive mechanisms assume good faith state actors. What happens to binding governance when the regulator itself is a threat vector?
Yeah, interesting question. You can't have a regulator who doesn't have the right intent. And if the intent of the regulator is to protect own systems or some particular systems, I think it's a very difficult situation for all of us to meet. So quite clearly, we'll have to approach it a little more multilateral. We'll have to make it more grouped. We'll have to make it across nations. And we'll definitely have to see where like-minded people come together.
Thank you very much, Major General. That takes us to the end of our deep dive. Thank you very much, and please join me in giving a round of applause.
Thank you.
I will now call to the stage our next speakers for the next thematic deep dive by Daniel Ross from Dynamo AI and Honorable Harjit Singh Sajjan, former Minister of Defense of Canada, for a thematic deep dive, making AI governance enforceable, scalable assurance for high-stakes systems in government and the private sector. While we wait for our speakers to settle, we have some issues with this PowerPoints that we're trying to solve at the moment. So we will be making a start already with the deep dive while we solve the slides issue. Please, Dan and Harjit, you have the floor. Thank you.
Perfect. All right. Well, thank you all for having us. Really excited to spend some time today talking a little bit about underlying technical controls that are effectively being deployed across the public and private sector to enforce AI control from a security, compliance, and safety perspective. And I want to thank, of course, UNIDIR for putting this together, as well as the UN for hosting us. I think it's really conversations like these, a mixture of private, public sector, folks from the diplomatic realm, to really keep these conversations going and understand a little bit of the art of the possible. So we'll get into it. Next slide, please. Just a little bit of background on myself. My name is Dan Ross, head of AI compliance strategy at Dynamo AI. Dynamo AI is focused on the development of technical risk controls, which I'll get into today, across sectors of defense and financial services. But really, my love and passion is the intersection of risk management and the control space. I'll pass it on to Harjit.
Great, thank you very much, Dan. It's a pleasure to be here. a conference that's very important in my opinion. I've served as a police officer and also as a soldier, and I want to echo what Major General Nund has mentioned, and I think a lot of the points that he raised is extremely important. I think it'll highlight some of the things that I'll be also raising. And when I became Minister of Defense for Canada back in 2015, and I served there for 6 years as a Minister of Defense, it'll give me a pretty good opportunity to understand what the threats are. And those of you who don't know, a lot of our responsibility in this role is to look at future threats. And when we were looking at future threats, one of the things that we looked at was artificial intelligence. And but there wasn't a lot of information at that time. There was a lot of excitement about what artificial intelligence can do. It hadn't fully developed. But at the same time, it was our responsibility to take a look at what we needed to kind of, how do we move forward? And an AI expert actually approached me and mentioned to me, and he goes, and he was actually a friend of mine, he said, Harjeet, he goes, right now for nuclear weapons, you have laws and regulations in place for the safety of humanity. And whether we agree or disagree, mutual annihilation policy does seem to work. But right now with artificial intelligence, given where it can go with the algorithms, the data, and quantum being built, we don't have regulations in place, and there's very little discussions that is taking place, even though artificial intelligence can lead us to the same, almost the same type of demise. So we started a conversation very early on with some of our allies on AI security. And at that time, Prime Minister Trudeau started the conversation within the G7, and I believe that this conversation has now continued, even at the most recent G7 that just took place this week. And a lot of that discussion obviously was led into, from a military perspective, was we talked a lot about human in the loop, having the right control measures, and ultimately some of the things that we were talking about is having a kill switch. So when we now look at conflict. We know that conflict is increasing the pace of AI dominance, and this is outpacing our societies and government's ability to fully comprehend the opportunity and that the threat of AI poses. So what do we need to do to move forward? So now, say that we agree on the control that controls are required, and the governments agree on the government controls and the framework itself. Just say that takes place. How do we put the technical controls in place? How do we know that these controls are actually working? And this is where I think industry will play a very pivotal role, and the private sector will play a very pivotal role, and which Dan will talk about next. Thanks, Dan.
Great, thank you. Keep it on, thank you. So just setting the stage, we're going to focus on a couple of elements around AI governance, specifically enforceable controls. So think about controls that are automated, those that are runtime, so that they can effectively be deployed at scale. And the second component of this is really thinking about what are the control considerations that are going into deciding how these controls are built. And I think that's maybe an underappreciated discussion that's happening, and it's certainly happening in the private sector and moving to the public sector. But these elements that really build the foundations of what an effective control is and those trade-offs are something that I think we all collectively need to discuss, especially as best practices merge. So if you go to the next slide, we'll spend a little bit just on, Harjeet kind of summarized what we call the problem in his perspective. I'll talk a little bit about control design, and then I'm going to dive into 3 examples that really the research team at Dynamo is focused on, and that we see deployed at scale across defense and financial services, and then finally some closing points. So if you can skip a few slides to slide 10. There we go. Perfect. So I want to spend a few minutes thinking about control design. And I understand we have a broad audience. So I'm going to take a little bit of a step back and talk about really what its control is and how it's implemented. But it's important to understand that as we start to talk at a policy level, discussions around what I call the foundation of the house, so the actual technical controls or the people, process, and technology operations are being designed and deployed today. And we're going to give you a number of examples of those. But the way those are designed really will set the stage for what we call the art of the possible from a control perspective. Next slide, please. From a design perspective, and for those folks listening in a room, we're very familiar with the concept on the left, but I just want to articulate it. For those in the risk management and control space, we tend to think about a PRC process. And you can think about this in the context of AI usage, where you have key processes being designed. These could be AI chatbots that we're starting to see pop up on our phone. They could see autonomous AI on drones and tanks that are getting deployed. As a result of that, and a look back, organizations start to think about the risks. And risks are broad. Folks familiar with risk taxonomy tend to think about things like technical risk, security risk, legal compliance risks, reputational risks, certainly across the board, and then define effective controls. Taking us out of the context of AI, you can see on the right side, we're probably all familiar with, but not necessarily thinking about the controls deployed as we're driving our auto to work or school. You can think about the things like the stop sign and how large it is, or where it appears in the middle of the road, the yellow line's driving, or the brake and where that's positioned. All of these, though, are very well-balanced controls, and those concepts and that design, that process is occurring very much now in both sectors around control design. Next slide, please. So if we look at something AI aligned, specifically an example use case around military operational planning assistant, you could think about an engagement model where staff are engaging with models. But risks, for example, may appear, in this example, we're seeing a risk around the model being slightly coercive or demanding in nature as it's engaging, which may lead to an undesirable outcome. And so we start to think about the controls. One of the controls we're going to talk about today is runtime guardrails. But think about the design and considerations of that runtime guardrail. Can that be designed by non-technical leaders, folks that understand the rules? When does it occur? What are the outputs from an audit perspective? Is it an independent control, meaning that it effectively can be detested? Can it be jailbroken? Et cetera, et cetera. Next slide, please. So before we get it from a control perspective, there's a number of considerations that I want you, as you start to look at some of the focus we have, talk about some of these trade-offs. One, of course, is around cost, cost of usage. Another is ease of usage. A number of folks previously this morning spoke about the third point, the concept of ground truth. So essentially being able to define your viewpoint of what you effectively believe is the truth in the outcome of the rule, accuracy and effectiveness of the control, adaptability and scaling, transparency to the act control, independence, and finally scalability. Perfect. So if we go to the next slide. Oh, you had it, perfect. There, oh, the one right before it, perfect. So we're going to talk about three controls. Oh. One is going to be focused on what we call automated red teaming and stress testing. So that's automated risk evaluations. Another is going to be what we call runtime guardrails. So these are post-production guardrails that essentially moderate models. And finally, we're going to talk about observability from an agentic perspective. On the slide here, you can see the first control we're going to talk about. That is automated evaluations that are being deployed. So look at this in the pre-production context, where organizations are looking to identify risk, essentially programmatic risk, across the different models that they use. And this is essentially models that are either embedded. You could think about third-party applications, so embedded AI, models that are being integrated across defense sectors or large organizations, or various forms of that. essentially establishing a consistent and independent valuation. So our research team really focuses on technical controls that run these automated validations across 3 core component areas. One is around safety and security risk. So red teaming and stress testing models independently in automated fashion to identify vulnerabilities in that model. Is the model harmful? What are the toxicity concerns? Can it be adversarially attacked? Another element of this red teaming and stress testing is compliance risk. You could think about this in the context of models you may engage with through customer service. Is a model prone to make legal advice? And under what context? And what material impact would that have, identifying that risk? And then finally, around privacy risk. So identifying privacy concerns and the risk of vulnerability sharing. Next slide, please. This is ultimately, though, an issue of scale from a control design perspective, hence the move to automated evaluations. And you can see the example on the screen. Most of the organizations that we're speaking with in the public and private sector know they cannot hire up or identify enough individuals to effectively red team a model and produce the type of auditing that regulators expect. They also know that they need a wide variety of example data sets that are really aligned to the risks that they're focusing on. Hence the reason of focusing on really automated evaluations. Next slide, please. And from a design perspective, there's a couple of core elements we're focused on in this control. One is ensuring that the risk output is given in a very non-technical way. I remember like some of the earlier discussions we had with regulators, and the feedback was really clear to us. It was there's individuals in the government and private sector that are making decisions about the risk and usage of AI. Those folks better understand the output of the model and red teaming stress testing that's going on. And hence, a really critical control element is non-technical design. Another is the use of AI within red teaming abilities. We call this, in one example, just of risk identifications multi-turn, essentially the ability to continue to probe models to identify risk of vulnerability. And finally, I'd say on this control design perspective, really critical that this aligns with best practices that are beginning to shape in global discussion. Next slide, please. The next control we're going to speak a little bit about is what we call runtime guardrails. So you could think about this as a post-production control where you're looking to implement automated monitoring of the input and the output of a model, extremely critical. Think about it as a wrapper around any form of AI from a research perspective. And of course, you're looking at moderating the risk of harmful information being shared, the adversarial attack, but more importantly, how do you align your model to rules, laws, and regulations in an automated fashion as you deploy at scale? And you can see one of the examples, a military example on the right side, that's really critical for deploying. Next slide, please. So we talked a little bit about the risks that this control considers. Reputational risk is actually a very interesting one. That's true for government sectors and defense as well as the private sector, where models are responding in real time and organizations have laws around the language of the model, what it says and does in relation to an individual or a specific circumstance. And so the ability to deploy these runtime guardrails is critical to both align and block or flag that type of element information. But of course, there's other risks that are considered across from a runtime perspective, including compliance risks, data protection risks. One example we're always focused on from both sides of the house is, for example, ensuring that concepts of trade secrets, a really nebulous concept that every organization would define uniquely, can be both identified and flagged or blocked as the model. And then finally, security risks from a vulnerability security perspective. Next slide, please. So we'll talk a little bit actually about the components of this control. And there's 4 areas I'm going to dig into really quickly. One is For this runtime control, it's critical that organizations have the ability in natural language to define their ground truth. And this is something I think I heard from a number of speakers earlier, the ability for especially a non-technical leader. So I'd say in the defense sector, we're often dealing with those that understand security parameters. I think about our financial services world, this will be lawyers, risk managers, compliance leaders that understand the rules, that can go through a process to define their ground truth. What is their example? Big example would be like if you want to ensure the model doesn't provide a sort of legal advice, but your organization has a very specific tailored advice. So creating that and allowing the runtime control to develop that. That's steps 1 and 2 here. The other concept we think about is the use of synthetic data for realizing context. So synthetic data plays an important component of this control. So you think about the concept of not providing certain types of information in a security context. That often matters from a use case perspective. What is the use case and under what conditions? And as we all know, there's infinite ways to probe a model. So how do you draw that line between what's acceptable and what's not acceptable? We've found from a research perspective that using synthetic data in the concept of guardrail rules is a really critical element for displaying all of the varying permutations and having that type of evidence. Next slide. Finally, 2 elements all matter. The runtime guardrails that we're focused on, we found that the development of small language models for uses really does the best in terms of semantic ability to understand intent of what can go in and out of the model, which is why we're very focused on fine-tuning and training those specifically for guardrail controls. And then we often talk as our environment around comprehensive observability and evidence. What are the audit points? What types of inputs and outputs? What types of documentation do you have? And essentially, when organizations start to think about this control, they're essentially monitoring all of the inputs and outputs of models. They need the timestamp, the evidence, is it compliance with their rules and suites, to be able to document that and share that with their internal leadership, with external parties. All of those component considerations go into the control design. Next slide, please. Great. And finally, before I go, and I'll turn it over to Harjeet, talk a little bit about agentic oversight. So I want to spend a little time on observability. I think the previous speaker spoke a little bit about the agentic risk consideration. This is, folks are aware of the fastest risk management space that we're all dealing with. And so I wanted to spend a few minutes talking about the oversight perspective of agentic use cases. The example on the screen is really one risk. We call it the lethal trifecta comment. So folks are familiar where an agentic agent may be deployed. You're looking at not only decision points, what an agent should do, but what data sets can it access, should it access, and how it should transfer information. But if you have a situation where you have both the ability to provide what we call untrusted input, the agent also has both private data access and the ability to externally communicate. You're essentially in a risk parameter where the agent has the ability to take extremely sensitive information and share that outside scope of concern. Next slide. So from a control perspective, we tend to look, the researchers at Dynamo tend to think about what is the contract, the requirements. If you think about the policy, what should be allowed from an action and intent perspective, and applying controls in runtime to both monitor that. And you can think about that occurring across the agent activity, so the guy on the screen, as well as its interactions with the different data access points. Could be MCP servers or other internal databases that it may have access to, and then enforcing that on internal usage. So really, the question is, what is that policy contract? Next slide. But back to the key control consideration, defining that and executing that is not is a scalability concern. And you can see a couple of the considerations on the right here. All of the types of decision points for each individual action that an organization may need to imply. as you start to apply these hooks, these technical controls to monitor it. What is the risk? What type of control? When do you apply the activity? What should the intervention be and what level? With all of the relative audit reporting. Next slide. So this is actually an example of that control perspective where you're looking at, for example, those types of decisions scaled across all of the different MCP servers. And so this is another control plane that offers a level of technical runtime control, a level of automated reporting, and the ability, and we're focused on the ability to scale across usage to give security leaders, folks in risk, compliance, legal, essentially a level of effective control on different agentic use cases that we're seeing here. Next slide. Perfect. I know I said a mouthful. So,
no, thanks, Dan. At the end of the day, as now Dan has kind of alluded to, say if we were, as I mentioned, some of the questions that I was posing, and we need to verify in a non-physical domain that things are working. A company using artificial intelligence will lose reputational risk all of a sudden very quickly if all of a sudden the AI doesn't function properly. And for a government, there's so many aspects from everything from security, making sure that privacy is met for their citizens. So how do we make sure that the AI that model that you're using is actually working properly? That's going to be absolutely critical. I think this is where industry, and Dynamo is just one of the companies that is working on this, is going to be absolutely essential. So as we look at defining what the guardrails and control measures are going to be, we need to make sure that we have systems in place that's going to allow us to make this happen. And final closing note that I'll say is we need to make sure that the artificial intelligence that we use, we use to maximize power for society, but at the same time, making sure that we do have controls and guardrails in place to limit its threat to society as well. Thank you.
Great. If you go to the next slide, please. So just some leaving points, just summarizing some of considerations for you all. And you can see some of them there. I think, in Harjeet, you and I were talking about a couple of the critical components here. One is really just facilities and the ability to test out controls in a public and private partnership. I think earlier I heard one of the speakers talk about the concept of sandbox environments. You see that popping up from a sector perspective. That's really critical. I think actually there's an ability to share that information cross-sector. The learnings, for example, you may get in the healthcare environment, financial services is helpful for the defense sector as well. Secondly, too, I'll also note organizations and governments are tending to think about either accredited tester programs or rigorous standards that they can validate both controls and advisory firms on this. And I think that's really healthy as well. Because as policy begins to shape, we also want to share the level of control efficacy is development there. And I think we're seeing a lot of strong coordination around that as well, so helpful. And then finally, I think, I mentioned forums like these, especially with training and showing the art of the possible from a control perspective really helps move the discussion forward. So if you go finally to 2 more slides, just our questions on the next slide. These are just questions for debate as folks think about our control baselines, right? So art of the possible, and do we want minimal control baselines? Do we want examples across sectors? I mentioned the concept of ground truth, focusing on the ability for organizations to define what their specific rule is and how does that get applied, embedding that as a control example. And I think point 3 we're starting to see as well, where we've seen a lot of strong policy and framework guidance, but now excitingly there's discussion of best practice controls. And then finally, considerations of independence. So the ability for control framework, something of course in the financial services side we have very heavily, is ensuring that there's incentivized independence for validation and control across the board. So I think that wraps up our discussion. And we appreciate everybody's time. It's really nice to be here.
Thank you very much, Dan and Harjit, for this presentation. We do have some time for a few questions from the floor, if you don't mind, that we've received via the Slido. So I'll be reading a few in the interest of time. We have 5 minutes. So we have a question on when you talk about automated evaluation and testing, is this being done with another AI, and who evaluates the evaluators? Another question that I had is most AI governance frameworks are still advisory. What does it actually take to make them operationally enforceable at scale, especially when the AI system outpaces the regulatory cycle? I'll leave you with these two questions for now. Thank you.
Yeah, I think the first question was around the evaluation and the use of AI. And I think that's certainly a component. I think there's the AI is a critical tool to ongoingly and effectively battle test other AI systems. Not the only tool, but it's a component. I think there's two really critical control considerations. One is transparency of design and benchmarking. So folks are familiar with, from an evaluation perspective, taking pride in sharing effective benchmark and validation results in performance, critical in terms of design. Another I would add, though, critically, is independent evaluation. And having been a former, regulatory and risk manager in my past life, the ability for organizations to feel comfortable with independent evaluators validating it. And so both of those things, we really look at from a critical evaluation perspective to be able to assess the efficacy of the control. The other thing I'll say on this is, evaluations are quickly becoming really essentially enough scenario testing is critical. Evaluations are really becoming focused on output of models from a risk perspective rather than design. There's a big discussion in the US specifically around model risk management guidance in the banking sector, where typically historically it was focused on, okay, design of a model, can you understand explainability, where discussions are now drifting towards, do you understand all the various outputs that that model may have, and what controls do you have in place? And so the other thing I think from a control perspective on the evaluation suite is the ability to run it through enough comprehensive tests where you start to feel comfortable of the nature of how a model may respond under duress or certain context. I think that was the first question. If you could repeat them.
And then the second question was about, so far, evaluations being advisory, so to speak. So how do you scale that when it comes to their nature basically being voluntary? So to speak?
So the scaling part's a component. So we actually focus just on technical controls, which tends to apply to the manual application. Because we know, so essentially automated evaluations that get executed and run. Because we know organizations can't scale up enough talent or assess and test enough scenarios to be able to get an effective risk to deploy any sort of AI at scale. And this is essentially an AI governance problem. You hear about organizations that have mirrored and backlog of AI use cases. How do they test before those use cases then get approved by the right risk stakeholders? And so it really comes down to both the ability to run technical controls and then the right to scale the right types of analysts and support to review the output and make a risk decision.
Thank you very much. We have time for one final question from the floor. Your framework seems to be designed to verify compliance at scale, but how does it address the issue of unswearability? In other words, after a specific high-stakes AI-assisted decision is made, how can one explain why this outcome was chosen rather than a plausible alternative?
It's a great question, and definitely one I think a lot of us in the industry are looking at. From an explainability perspective, and I think that was the question. So we're really focused on output of models and aligning to your compliant expectations. In terms of explainability, there's one way we think about it from we call it an on-topic perspective. So from a risk perspective, we're really focused on ensuring the model stays in line with expected response topics. So you could think about the ability for a guardrail to ensure a model doesn't talk about topics that are really outside the focus of area, which really reduces a level of explainability risk. And then on the evaluation suite side, essentially identifying a parameter of outputs to be able to essentially identify where a model is more at risk of providing a response that may be non-factual or not aligned to your risk tolerance. I think both those data points and controls really help to facilitate explainability, but explainability, in the way that we're probably used to it from a model risk management perspective, when you have non-deterministic models, and oftentimes isn't something that's achieved the same way.
Thank you. I said there was the last question, but actually one question just came from the floor that is super interesting and a nice way of wrapping up our discussion. What kinds of skills and competencies do you feel are required for a future of responsibly curated AI in high-risk contexts?
For here, I think every nation is going to have to kind of design and select their expertise. And I believe that, Dan, I think Singapore is doing something quite well in this frame. You can talk about that afterwards. Having the right center of excellence, having the right experts to verify that a government's policy can actually be delivered. I think that's very important. And to the original question that first came out is, how do you, since you're using AI to verify AI, how do you know that your original AI is working? And it's a very difficult question. At the end of the day, this is where we're going to have to rely on not only our expertise within our own nations, is how do we come together and identify who can actually verify this type of work. But ultimately, every nation will have to select their own governance process with the right control measures and moving forward. And I believe that Singapore has started on a good pathway forward. Dan, if you want to kind of talk about that.
Yeah, I think, Harjit, you're right. It takes international cooperation in an environment where you can both set up effective sandboxes, identify talent profiles, and share that with other countries as well. And so, we've seen this, as Harjit mentioned, in Singapore really effectively, and a lot of leading the way in terms of publishing policy standards, security outputs, and testing. Seen this, of course, in the UK, and a lot of sharing information there as well. And I'm really hopeful that this starts to spread to other nations as well, as testing matures, as control output matures, and definitely to our university system. I don't think we've spent a little bit of time talking about that, but especially as the next generation of leaders are going to live in this world, they're going to have to be familiar with control efficacy, design, and output. And I think that's another opportunity where that type of environment can really shape future leaders.
Thank you very much. Please join me in giving a round of applause for our speakers. And now I will invite on the stage the speakers of all 4 lightning talks that will come until we reach lunchtime. So I will ask, please, Dr. Vadim Kozyulin from the Russian Diplomatic Academy, Asim Khawaja from the UK Civil Service, speaking in his personal capacity, Ulysse Richard from UNODA, and Yagmur Seren Atay, independent AI security researcher, to join us on stage for their lightning talks. All right. So while our speaker gets settled, I just want to remind you that there is a Slido that is always open for throughout the conference. So everyone who is following the conference, both in person and online, have the chance to ask a question to our speakers. Unfortunately, for the lightning talks, due to their nature, it will be difficult to squeeze in questions, but please, our speakers will be around for the 2 days, so do ask them questions during lunchtime. They will come after the lightning talks. Now I will give the floor to Dr. Vadim Kozyulin from the Russian Diplomatic Academy for his lightning talk on artificial intelligence and international humanitarian law and whether machine analysis can reduce civilian harm. Vadim, please, you have the floor for 5 minutes. Thank you.
Thank you. When we talk about military artificial intelligence, we often hear a simple picture. There is a bad technology and we need good regulation to limit it. In reality, the question is more complex. There is IHL, International Humanitarian Law. What we are really discussing is whether AI can help us apply existing humanitarian law better, not replace it with something entirely new. Military AI still is poorly understood field. In discussion about it, regulation, there is often a lot of emotion, but yet not enough knowledge. Let me give a simple example. Precision weapons, they became a breakthrough military technology at the end of 20th century. Initially, it seemed that the more precise a weapon is, and the smarter the guidance system, the safer it should be for civilians. But history shows that the opposite can happen. When a state believes in the cleanliness of a strike, it becomes psychologically easier to decide to use force. So precision weapons did not reduce the number of limited operations. In fact, they made such operations more politically acceptable. So the same could happen to AI. If decision makers believe that an algorithm always sees everything and always makes the right distinction, the threshold for using force may quietly decrease. In that case, better sensors and better models will not make war more humane. They will simply change how risks are calculated. So we still do not fully understand how AI affects deterrence, escalation, and political decision-making. Relevant databases has not been shaped yet, so not enough information available. If we introduce strict new rules too early, we may lock in practices that we have not yet properly studied. There is also a risk that the debate on the regulation of military AI distract us from a simple fact. In all conflicts and at all times, humanity has repeatedly violated IHL. There was no a single conflict without IHL violation, and it's violated not by AI, but by humans. So even without use of AI. We usually think of military AI as a tool for planning operation and selecting targets. But the same method, pattern recognition and large-scale data analysis, can also be used after a conflict. They can help investigate strikes, assess civilian harm, and reconstruct events. Some states and international organizations already use machine analysis to document damage, verify satellite data, and compare open sources with official statements. In theory, if these approaches are further developed and institutionalized, they could strengthen accountability. It would become harder to hide systematic violations and easier to show when repeated errors go beyond reasonable limits. This creates an interesting paradox. States that actively use AI in military planning also create a digital trace of their actions, system logs, targeting patterns, risk assessment profiles. If handled properly, this data could be used not only to improve operational efficiency, but also for legal evaluation, including international settings. This is not a guarantee of justice, but it creates a stronger basis for discussing compliance with IHL. Finally, a few words about law and new technologies. 10 years ago, the international community expressed concern about the lethal autonomous weapon systems, and the group of governmental agents or experts, was created under the CCW. Since then, military technologies have continued to evolve rapidly, creating new areas of risks like generative AI, large language models, AI agents, and so on. Sometimes we hear the idea, let us create a new treaty especially for autonomous systems, then perhaps another one for decision making, for decision support systems, then another one for AI agents in cyberspace, and so on. But new technologies will continue to appear, and we cannot predict what will emerge in 5 or 10 years. If we create a separate micro treaty for each new technology, we risk sending a signal that existing humanitarian law is not longer universal or technology neutral. It would fragment into many specialized regimes, and common foundation would become weaker. Perhaps a better approach is not to place AI in a separate category, but to test the strength of existing norms against it. If we can apply current IHL law to the most complex systems like autonomous platforms, decision support tools, and agents operating in the information space, then the problem is not that the law is outdated. The real decision is whether we are ready to invest our knowledge and efforts in its practical implementation, procedures, training, and technical and organizational safeguards. Thank you for your attention.
Thank you very much, Vadim. We'll now move to Azim Khwaja from UK Civil Service, who will be talking about governing agentic AI in cyber defense, practical observations for public framework. To note that the speaker is here participating in his personal capacity. Azim, please, you have the floor.
Thank you very much for the invite today, and to reiterate, all conversations are in personal capacity and published information assessments. As I was preparing for today's 5 minutes, it reminded me of Winston Churchill's famous quote of, sorry, I didn't have time, hence I'm writing you a longer letter. I wish I had written you a shorter letter if I had more time. There's so much to talk about here on a topic that I'm deeply passionate about. But I'll start off with some lines that came out from the recent joint guidance on the agentic AI from national cybersecurity agencies. They wrote that until practices and standards mature, organizations should assume that agentic AI systems may behave unexpectedly. So coming from the security authorities, we would like to think that we'll take it as an operational instruction. Next slide, please. So for most of the AI governance conversations, the question that we often hear is, can the model be wrong? In cyber defense, it has already moved. Can a delegated system take the wrong action? Under whose identity, with what permissions, and what evidence afterwards? An agent in a SOC is not a smart chat box. It is a non-human operational actor. It calls tools. It carries memories, it holds permissions, and a blast radius when it goes wrong. So for these moments and beyond, it is reading tickets, querying sensors, your operational technology, calling security tools, and changing something in production lines. So it has joined your control plane. So govern it like a part of that control plane. So governance is on the action, not just the output, when we talk about agents. So the encouraging part is we don't need the new rule book for this. Next slide, please. Over the last years, public frameworks from very different places point at the same pattern. A lot of you would have been assessing, I've been assessing that myself. Cyber agencies are focusing on privilege and accountability. NIST frameworks are observing the cyber AI life cycle. OWASP names the agentic failure modes: goal hijack, tool misuse, privilege abuse. memory poisoning, cascading failures. Cloud Security Alliance has put identity at the center. And the EU AI Act, we're in scope. And the ISO management oversight, traceability, lifecycle discipline, and all of that. What I've got on the slide here are sort of the 5 controls convergence from my perspective, where there is different jurisdictions, different communities, but there is a one pattern that we're observing. What is the distinct agent identity? Not a borrowed credential. Least privilege. What is the scope tools? Short-lived credentials. Bounded autonomy, where we know what the impact is, and is there reversibility? And human approval for material hard to do undo actions. And what is the action level evidence? What was called, under what authority, and with what results? So basically, when frameworks from different jurisdictions and communities point to the same controls, the convergence itself, in my point of view, is the finding. Not long ago, so I still remember, so there was an accountability. So General Assembly Resolution 79239, I believe that was, which was on AI in the military domain, which calls for AI that there has to be human-centric and accountability. So following on from that theme, I truly believe that the accountability problem stands before the technology problem. And identity is the precondition for accountability. In cyber defense, the governance question is not about models giving the right answer. It's whether the autonomous system is allowed to take the right action under the right identity, the right limits, the right evidence, and clear accountability. And for once, the frameworks are saying that the gap is not the rule book, the gap is implementation. Thank you.
Thank you very much, Azim. We'll now move to Uly's presentation, who will be, and Uly's will be covering who is in the loop when the loop keeps moving, when static governance meets agentic decision support that remembers, reprioritizes, and reaches. Uly's, please, you have the floor.
Thank you, Yasmin, and thank you to the team at UNIDIR for the opportunity. Just like my previous colleague, I'm speaking in my personal capacity as well. And I should note that this work was conducted with Carissa Tippertree during a fellowship at INHR. Next slide, please. So picture this. You're sitting in a command center a few years from now on, and your team is running an operation using an AI agentic decision support system, which helps you fuse intelligence, rank targets, generate courses of action. And during an operation, it recommends striking a mobile air defense unit. But as you look into it, the situation shifts, the unit moves, and a civilian convoy comes in. So your system replans and offers a low collateral option, which you authorize. But that recommendation turns out to be wrong, and the target was a decoy. So you didn't necessarily make a mistake here. So what went wrong is the question. And it could have gone a lot worse. Next slide, please. And the likely answer is that nothing has failed. The system did exactly what it was designed to do. But the problem is that the properties that make a system like this useful are also the same ones that make it dangerous. And to explain how, I'll focus on how 3 specific agentic properties led to that result. Next slide, please. The first is persistent memory. So the system carries context and learned preferences across sessions and missions, so that the staff doesn't have to start from scratch every time. And that's genuinely valuable. But that memory can also be poison. Anything written into it stays, including an adversarial input. And you don't need privileged access to write it. You can do it as an ordinary user through normal interaction. You just need to feed the system with a corrupted entry. It stores it as a learned preference, and then it acts on it from then on. So persistent memory. Next slide, please. A second property is objective flexibility. So when the situation changes, the system reprioritizes and replans. And in our scenario, this is the target is about to relocate, and the civilian convoy appears, which forces new courses of action to be generated on the spot. And that adaptability is genuinely useful as well. But there's also an adversarial side to this story. And if the system derives its plan from the situation that it observes, then whoever shapes its inputs can also shape its objective. And you can embed an instruction in the data that steers the plan without ever touching the system. That's indirect prompt injection. And you don't even need an adversary to do that. A system learns its goals from its training conditions, and in the field, these conditions are going to differ. And so it can end up confidently pursuing the wrong objective, which is the objective that it learned during training, not the objective that the commander intended. That's called goal misgeneralization. And it's the idea that you might catch a drift in the prediction, but it's much harder to catch a drift in a goal. And it can stay invisible for much, much longer. So persistent memory, objective flexibility. Next slide, please. And the third property is affordances, which is essentially the scope of what the system can reach into and act through. So the system uses many sources upstream, but downstream it can also task sensors and push recommendations across the force. And again, that reach is very useful if you're a small team, especially running a large force. But every connected systems then become parts of the attack surface, and we've heard from that this morning before me. And we have already documented incidents of agents executing destructive actions via tool invocation without an approval steps because the action was within their permitted scope already. And the reason I opened with that strike is that none of these properties acted alone. So let's go back and follow how a system was corrupted throughout the life cycle. First, the vulnerability probably have been introduced early, probably during data poisoning during training. It then sat dormant as a latent trigger. It passed pre-deployment testing and evaluation. And then once in operation, this vulnerability was written into memory, which fed into planning. And then the new course of action was built on that corrupted state. And because the system acted through its connected tools, the error propagated across domain. And by the time it reaches you, the commander, it arrives fast, it arrives confident and well-sourced. And the human sitting at the end of the pipeline is the least able to detect what went wrong. So the outcome is a wrong strike. Next slide, please. So quickly, 3 governance lessons. One, as we've heard, I think earlier today, testing and evaluation expires. The system you certify is not the system that you are operating 6 months later. And so assurance has to run continuously throughout the life cycle, not just at a single gate. And we've heard interesting proposals before this presentation. 2, a human in the loop is not the same as meaningful human control. If the operator sits downstream and approves a confident recommendation that they cannot realistically verify, that control is mostly symbolic. And so we should be measuring how much real oversight remains, not just whether a human authorized a decision. And 3, we need to separate autonomy failures from agency failures. Our accountability frameworks assume someone either ordered the strike or failed to prevent it. But here we have an agentic objective that was shifting on its own and no one detected it. So that failure mode also needs to its own track. So in closing, these systems are coming, and depending on your side of the world, they're probably already fielded and deployed. And these are the real reasons to want them. But I think if we govern them as static tools that we're used to, we risk to certify the risk away on paper, but never see the risk come in real life. Thank you.
Thank you very much, Ulysse. And now our final speaker before we move to the lunch break, Yagmur Seren Attai, who will be talking about when AI agents become the attacker's best assets. Seren, please, you have the floor.
University. I'm a graduate from Georgetown University and currently an independent AI security researcher specializing in cybersecurity. Today I'll talk about agentic AI governance gaps and my proposed solutions. And with all the doom and gloom in today's topics, I'll say that I'm a cautious optimist. And I'll start by saying AI offers immense opportunities and the most advanced capabilities we ever had access to, and we need them more than ever before, and more so for defensive purposes. Against AI-powered offense, AI-powered defense is no longer optional, it is mandatory. But our governance frameworks were not designed for this. Traditional defense doctrines assume that security failures are visible, bounded, and easy to respond to, and slow enough to respond to. And a tool is usually static, single role, meaning it is a defender or an attacker. When it fails, it goes offline. The defense goes to zero. It doesn't suddenly start attacking you. But those assumptions no longer hold for agentic systems. First, hidden compromise, which is what I call defender compromise paradox in my research. An AI security tool or just an AI tool might be compromised, yet continue to function their normal tasks normally without any visible failures, meanwhile continuously serving the attacker interests. So this is beyond dual use. It can simultaneously function in different roles at the same time. So it can prevent 99% of your adversaries while simultaneously leaking your credentials. And this is not just about security or defense concepts. It can do alignment, it can be a chatbot, it can do multiple things at the same time. So this is beyond dual use. In this case, for the first time, defense no longer goes to zero, it goes negative, meaning your defensive tool, your AI tool, becomes an active attack multiplier. And second, unpredictability. In traditional defense doctrines, the tools were usually deterministic, meaning same input produces same output. And the failures were bounded, more expected, more predictable, easier to model. Again, agentic AI systems break those assumptions. Those models are increasingly, especially for autonomous systems, they are stochastic with nonlinear cascades that makes it extremely difficult to predict and model and respond to. And while this is this flexibility is a strength, it makes the consequences and compromise harder to predict and harder to respond to. And third, cascading trust failures. AI systems are so embedded and interconnected into our pipelines and supply chains, and usually without visible attack surfaces. Sometimes they're invisible, we don't see them. And when one part of the supply chain gets compromised, a tiny bit of compromise can propagate across the entire supply chain without needing direct connection. And that means none of us are immune to these attacks because they don't recognize jurisdiction, borders, or any other attribution whatsoever. And that means the blast radius is no longer determined by the breach, but the blast radius determined by the trust architecture surrounding these systems itself. So it's not just about the model, it's not just about its alignment, it's the entire architecture and infrastructure surrounding it, especially the trust layer. And fourth, speed immersion. Historically, defenders had time to investigate, triage, coordinate, and respond to attacks. But right now, the attacks and the decisions occur in milliseconds, meaning that we no longer have that flexibility to respond in longer durations. And our governance, authorization, and oversight mechanisms still operate at human speed. Now, if you combine all of this, it looks like a compromised agent that still appears trustworthy, that behaves in unpredictable ways, that is and cannot be fully anticipated, and that can spread through every system, every trust layer that connects to it, that trusts it without actually needing the direct connection, and with the addition of invisible attack surfaces, and finally at machine speed. Now, that is the weaponization of the trust itself and the entire infrastructure that we are building the systems into. And recent incidents demonstrate that this is no longer theoretical anymore. In February this year, AI coding environments were compromised by sandware mode, and the developers continued using their tools without any visible failures. Meanwhile, they were exfiltrating their credentials. And later in March, again with Trivi and the Light LLM attacks, and later in April, Minishai Hulud incidents, it just propagated further down into the supply chain and impacting more and more users, millions of users. And across the jurisdictions, governments, banks, enterprises, again, it doesn't recognize where you live, where you operate, or your governance procedures. And no one is immune to these attacks, and they will only increase in severity and frequency. And what matters is not the individual name of these attacks. What matters is the pattern. And the pattern is that the attackers are increasingly compromising the architecture and the infrastructure, especially the trust layer surrounding these models and systems. And it is just easier for them to do that without actually targeting whatever they're targeting actually directly and individually. And 3 proposed governance mechanisms for that at the moment. First, continuous and mandatory adversarial authorization testing. And this is not a single red teaming practice or just pen testing, just you do it once before deployment and then you're good to go. It should be continuous. And it's not just that, it should be adversarial mandatory testing, which means you need to properly test how those systems act and behave under adversarial conditions, and not just act, but how they degrade. Do you have mechanism? Do you have redundancy? Do you have plans in case things go wrong? You need to test how these systems behave and degrade and propagate across the entire infrastructure. And second, dynamic trust authorization, meaning trust cannot be just a one-time event that you just do once before deployment. Trust should be continuously earned, continuously revalidated, and continuously recalibrated to the scope, context, and risk. And finally, you need to test the blast radius, means do you know actually how far deep your supply chain goes? Do you know the consequences in case of a compromise? Do you know your vendors? Do you know your vendors' vendors? Do you actually know what they use? Do your vendors know what they use? So these are all connected, and right now most systems are operating blindly without actually knowing where that trust goes. And without knowing where your trust goes, you cannot govern how the systems will get compromised and what you do when that happens. And finally, this is what I base my research on as well. At a certain threshold, you cannot meaningfully reduce risk. So instead of shying away from risk, we should design our architecture that actually benefits from risks. Thank you very much.
Thank you very much to our excellent speakers. Again, once more, I'm so sorry that we don't have the time for Q&A, but please do approach our speakers during lunchtime. Now lunch is served with a limited amount of sandwiches in front of the door. We do have a demo booth. Please do engage with them with the AI military integration database, as well as a collective intelligence exercise that we're running in partnership with IBM Consulting. And I'll see you at 2 p.m. here in this room. Thank you very much.
Ladies and gentlemen, we are about to start. If I can please ask you to take your seats. Thank you. All right, I think we're ready to make a start. Welcome back. I hope you had a short but nice lunch break. Thank you so much for participating in such high numbers, both this morning and the afternoon session as well. Before we start, a couple of housekeeping remarks. If you go on the program, you'll see that unfortunately the last speaker on the program wasn't able to reach us in Geneva today, so the conference this afternoon will be cut a little bit shorter. But because we don't want to send you home too soon, we will take advantage of that moment to take a group picture at the end of the day. So please, after the last intervention, whoever is going to be here emceeing will invite you to join us for a group picture. Do not disappear before then. Also, because you are all very welcome to join us to the reception that will be held here on the 8th floor at the end of today. So for those of you that are here in Geneva, unfortunately not those online, but we'll be very happy to welcome you to a reception later today. Okay, with that, I think we're ready to start the afternoon with a demonstration, a very interesting demonstration. I'm very happy to introduce here on stage Michael Adams from Palantir Technologies, who will quickly or shortly connect to his laptop and give us a demonstration. Please, Adam, over to you.
Okay, thank you. The hardest part of these presentations is always figuring out how to share your screen. So it's great to meet everybody. My name is Mikey Adams, and I work on Palantir's Privacy and Civil Liberties Engineering team. Our work focuses on building privacy-protective, responsible AI, and other rights-oriented software features into Palantir's products. I wanted to start by thanking UNIDIR for hosting us today. It's truly encouraging to see such widespread engagement from across sectors at this event. AI in the intersection of defense and technology is a topic that demands substantive dialogue from all corners of the public commons. Civil society, technologists, governments, militaries, industry, academia, all have very important roles to play as we define the future of the space. And this event is a promising step. We're truly excited to be here. As a quick background, Palantir is a software company that focuses on the responsible development of technology as we help the world's essential institutions tackle their most pressing challenges. Our customers operate in highly consequential domains: defense, civil government, healthcare, and they are subject to the highest standards of privacy safeguards, of regulatory frameworks, extending now into AI governance, which is what we'll focus on today. There's no silver bullet for creating effective, accountable AI systems. Rather, it is the combination of everything from privacy fundamentals, data governance best practices, and AI governance techniques that create accountable systems that can be reliably used on consequential problems, especially those that exist in sensitive domains like defense and insecurity. The principles underpinning these approaches are represented in the wider presentations today at the event, in addition to emerging regulatory frameworks like the EUI Act that apply in an aim to define high-risk AI systems. So today, I want to show you Palantir's approach to AI governance, how we help our customers build an enterprise-wide understanding of how and where AI is used within their operations. This is built on top of effective data integration with configurability and oversight on everything from granular privacy controls to testing and evaluation of large language models. We will show you how we help our customers, some of the most complex and important institutions in the world, implement AI systems that they can rely upon and use in production. So we'll do this in the context of a notional company, Onyx, that is leveraging AI and workflows across its global operations. As they grow, so do the complexity of their processes and automations being built within the platform. And modern organizations, whether they exist in the government space or in commercial, are constantly facing this complex challenge of balancing innovation while holding a high bar for governance and observability at scale. And what we're showcasing today is born out of our experience in defense. It's built alongside customers in that space. And while everything that we're showing is notional, the features that we're showing today are leveraged by commercial customers as well as government institutions, including those in the security space. Just as with commercial organizations, defense and governments have AI governance process. These may be regulatory obligations, best practices from civil society, or even organization-specific processes. And in all those cases, our focus at Palantir is on how we can use software to operationalize those best practices and bridge the gap between technical and policy experts. So 2 final notes before I get into the actual demo. For the purposes of this demo, we'll be occupying the role of different hypothetical users at a potential commercial customer of Palantir's, handling the development and deployment of AI-assisted use cases. The views and the data that we're seeing are notional, but reflect what a customer of ours in the commercial space, in the government space, in the defense space, could see in their instance of our software. To be clear, when a customer uses our software, each customer uses an isolated individual use of our platform. So we're going to be taking a look at how Onyx, our notional company that I mentioned, might use our platform for AI governance workflows. And second point, importantly, we are a software company. We are not a data processor, we are a data processor, not a data owner. Very important distinction. So in the context of our demo today, the notional data represents information that Onyx, this notional company, might already have and generates throughout their governance process. Our role is to provide the software platform that lets them put this data into operations, in this case for AI governance. Sorry, long intro, but now let's get into the demo. So I mentioned the complexity of their operations. This is something that we're frequently finding with our customers. They exist across highly regulated domains. They might have operations on a global scale. And what they're trying to do is both understand the reality of their data and then ideally be able to leverage large language models or other forms of AI on top of that data. But importantly, to do that, you actually have to understand what the AI is doing in context. How is feeding into that decision, that workflow, that use case? And it's only through that trust that you can actually have the explainability and the confidence to use it on any consequential problem. And so that's why Onyx is choosing to use AI Use Case Manager, or UCM. And what we're starting with here is more of a landing page. This is the single pane of glass that an organization would have for all the different AI use cases across their operations. As we go through these different features, I'm going to kind of highlight what the counterfactual would be. So in this case, without this single pane of glass, what we often see is that organizations are trying to manage their AI and how it's deployed in context in a very fractured environment. Inevitably, you lose context in that system or in that environment. It's very difficult to understand how a certain use case got to production, to perform different model testing and evaluation over time. And so we want to start with this first. How can you just understand the global operations of this organization and help them understand where and how AI is being deployed? We're now going to actually create a potential use case, take it through to the stage of actually understanding what we would need to do to get this to production, and then examine how we can both include policy, risk, other assessments, as well as actual testing and evaluation suites, all in the same tool. So we're going to name this one product recall classification. And essentially, this could be an organization choosing to use some form of large language model to help them predict when supply chains might be breaking down. This is easy to understand in a commercial context. This is also a very frequent challenge of government and other organizations who have very large supply chains, and being able to have this more predictive maintenance is a very helpful feature. So we'll name the use case here. If only I could spell classification. We could do things like add a description to this. And then we also see this date initiated. This forms as a log to understand when we actually created this use case. And then we have the selection for permissions. Right now, we just have a binary public or private. Again, everything that we're showing today is configurable, so you could have it match existing privacy settings within your organization and your processes. But importantly, different AI use cases will have different sensitivity. And so some might be leveraging things like PII, PHI, and so you want the ability to classify those as inherently private, select just who within your organization should be able to see those use cases. And so having this configurability that will extend to the underlying data of that use case is really essential. And we'll show what those privacy controls look like as well later in the platform. As we create this use case, we see the option to select an inventory. So we have a number of different ones here. Effectively, an inventory is a categorization of like use cases. So this is a good way of organizing, say, all of your use cases across your supply chain. You can then map those to existing personnel within your organization, which we'll do here. Once we've selected that inventory, it comes bootstrapped with a modeling lifecycle, as well as a number of different requirements that would have to be completed across each stage of this modeling lifecycle before we could actually get it to production. We'll show what those tasks look like later in the demo, but you can see what is, again, this is notional, this is configurable, a pretty normal 6-stage development lifecycle to get this use case to actual production. Everything from defining the problem, what could be more risk assessments, as well as actual model testing and evaluation that we can conduct all in the same tool. So for now, I'll select that we're at the definition stage, and then I can go ahead and assign different roles to different members of my organization. Again, the counterfactual here, when you have different users operating in different systems, say the governance officials doing their work in an entirely different system for you actually create model use cases or do testing and evaluation, you'll lose that essential context that you need, both to actually get something to production, but also have the auditability to understand when decisions were made in retrospect. So for now, I'm just going to select myself as all of these, which again, you would probably have more people within an organization. And now I can select different AI use cases that we've built in the platform and tie those to this use case. In this instance, we have, say, a model function or a piece of logic that we've said this will be how we actually classify the potential breakdowns in product to assign when we might need to recall those. We can add that to this use case, and we'll see how we can then perform testing and evaluation down the line. Once we've done that, I'll have completed this use case setup, and now I have this kind of landing page for our specific use case. I can see a few things right off the bat. One, my team, again, reflected here, so everybody who will be iterating on this in order to get it to production. I can see a quick overview of where this falls kind of with those different logic functions that we mentioned, and then I can see that lifecycle represented here on the right. And what I'll do next is actually just update some of the metadata around this use case and tie it to different artifacts, different underlying data that I have in the platform. This is where it gets really interesting, at least to me. And so I'll go ahead and I'll select a pre-built workflow that we have, as well as the data lineage that we want tied to this use case. When I click submit, we'll see this new lineage tab that has popped up here. And this is where data integration is so essential to actually getting AI into a production environment where you can reliably trust what it is using as its actual underlying data sources, where it is pulling decisions from, and then have that auditability as well as those privacy controls on the underlying data itself. Again, and how we think about this at Palantir is that if you are not solving for privacy governance at the moment that data is ingested into the platform, these have to be fundamental to how the platform is constructed. Inevitably, it will be a tacked on feature at the end, and you'll lose what is essential in that you need to be able to govern exactly what happens to a piece of data the moment it enters your platform, and then know that whether if that data is transformed, used down the line, those privacy controls will remain the exact same as you determine them to be. So I'll expand a few things here. This is a tool that we have called data lineage, or Monocle, but it really reflects our data lineage. And this is really what we have been building for the last 20 years. It is the ability going from left to right to ingest data from different source systems, transform that data, as you can kind of see going along the chain here, and then represent that data as objects that make sense in the context of your organization. So instead of seeing these 10 maybe different underlying data sets that would reflect aspects of, in this case, a product that you have in your organization, you see it reflected as a product or a customer, and then you can pull all the relevant data from those underlying data sets, again, knowing that those granular privacy controls will apply. You can see this extending all the way so that way that these objects interact with the front-end application that we were just in. But I'd be happy to talk about this further. This is really what we've been building as a company for the last 20 years, and it's what powers everything in terms of trusting the outputs of AI systems that you then layer on top of this underlying picture of your organization. And it's really essential to getting these things to production. So moving now, we'll go into the requirements that we have and show how we could actually operationalize a few of these directly, again, in the same platform. So you're not having to go to a different source system to do your risk assessment or your testing and evaluation. You can do that all in the same tool, leveraging and allowing your users, who are those subject matter experts, to perform their functions, benefiting from that very robust common operating picture. So we'll do two of these very quickly. We'll open a potential risk assessment and see how we could populate that right here in the platform. Just as a quick note, importantly, this is all notional. This is a pretty bare bones risk assessment that we created. It reflects a number of different things that are pretty understandable best practice in terms of model oversight, data governance, underlying privacy controls. So you can see a few of these reflected here. They could be things like, is there a human in the loop? Is there PHI or PAI that feeds into this use case? Again, and you know that because of the underlying data that we just examined. But what I really want to emphasize here is that this should reflect the organization and their internal processes, the regulatory environment in which they exist, and the different checks that they'll need to go through in order to actually productionize an AI use case. So this is a really great space in which civil society with kind of the wider outside world and industry can collaborate in defining what these benchmarks should be. And so that's something that we've contributed to quite a bit from our external policy efforts. This is something that I'd be really eager to talk about as well. So I could go through this here. I could populate different answers, ultimately click submit. And then we would have that completed. We could move on to other tasks in this development lifecycle. But for now, I'm going to switch to another use case that is a little bit further along in the development cycle and show how we can both generate testing and evaluation plans and execute them in the platform to understand how this model function might perform on different benchmarks and testing that we know it will need to pass in order for this to be a viable use case that we could leverage in our actual operations. So I've opened this different use case here. I could quickly understand by selecting knowledge base, the different underlying data, the decisions that have been made, kind of what has happened so far to get this from where it started to where it is now in the development life cycle. Again, the single pane of glass, allowing different users across your organization to quickly get up to speed is very essential especially if you're working across a number of these different use cases simultaneously. When we move to the requirements, I'm going to do two things here that are in the testing and evaluation stage. So first, I want to examine or generate a testing and evaluation plan for that model logic that we're going to be using. So I've opened this here, and I can see a number of different test use cases that we've generated. And so these would be things where we know what the answer should be. They reflect how this model should return different answers against these relative benchmarks. So what are the input values? What should it return? Should it say that a certain, in this case, product should be recalled? Should it not? And this, again, is best practice in testing and evaluation. But instead of doing this in a different system, you're doing it all here in the same tool. And then very importantly, we want to take that from just a policy framework to something that you are operationalizing and getting into an actual understanding of how this performs and conducting those technical benchmarks right in the same platform. So now I'm opening this eval suite. And what we see right here is called AI-FDE. This is one of the tools that we have in our platform. Effectively, it is a container for allowing agents leveraging a model that our customers will choose to perform certain actions within the platform. So importantly, Palantir is not a model developer. We are a model integrator. And so what you're seeing here is really LLMs as a commodity being leveraged against a certain use case. Quickly walking through what we have, you can see the prompt here. You can see, again, that testing and evaluation actual benchmark that we want it to perform. You can see what we want in terms of the prompt. You can see that it's asking for this specific approval to take an action in the platform. Again, this type of granular governance on actions is really essential. We could select different capabilities that we want this model to be able to perform. We could also do things like swap out which model we want it to use for this action. We work in a number of different domains where certain model types might not be available, or versions rather, whether it's for geo restrictions or other reasons. And so you really need that configurability as you're leveraging a large language model to perform this task. I'm going to save time by just going to the one that I've already run. And here you can see a few different things. So you can see the different prompts, how it's actually reasoned its chain of thought, how it's come to this ultimate thing that it's spat out, which is our performance relative to that testing and evaluation plan. You can do a couple things here. You can see the overview, how did this perform relative to those 14 tests that we ran? Which specifically did it fail? Why did it fail those? And then dig into the further metrics that you would need in order to attach that to this use case, and then have that live with this use case wherever it may go. I think very importantly, testing and evaluation isn't something that you just do at a single point of time. It needs to be a continuous process that you are constantly re-examining as the use case evolves, as the underlying data evolves, as what models or what actions you're choosing to take evolve. And so having both this in the same platform, the auditability of previous results, as well as the ability to run it again and again, is really important to having this holistic view of how is this actually performing within our operations. So I'll stop there. I'm hoping that this has helped you understand a general grasp of how we leverage AI UCM and how it becomes a really valuable asset for these different organizations who are trying to manage the complexities of AI governance and also provide a centralized platform for tracking, managing, and ensuring compliance with AI regulation. Importantly, and I'll say this again, there is no single answer for creating responsible AI systems. Privacy, data governance, AI governance, all of these must coalesce into a cohesive platform that takes into account not only the context of the organization and their technology, but also the specific risks of that domain. Only with this complementary, layered approach are we able to create systems that we actually trust enough to use on consequential problems, including those challenges that exist in the security and defense space. Thank you.
Thank you, Mikey. As you can expect, I have a lot of questions for you. I'm going to try to combine some. If you want to stand there or come here, whatever you're more comfortable. So I think there is a cluster of questions that point to the kind of the apparent disconnect between what some of the processes that you have presented and how our customers or users, whether it's corporate or state, how they're using the technology that you are providing. And while if we take the example of international humanitarian law, and it's states who are expected to comply with that, there is a number of questions around how do you reconcile what you're doing with the ability of your customers or the intent that your customers have to comply with international humanitarian law, international human rights law, etc. So how do these processes kind of connect with the use that your customers do of your technologies?
Yeah, I'm going to break that. I'm going to break that down into a few different responses because I think there's a lot there. So first, maybe to give an overview of how we actually analyze the risk and kind of come to these holistic assessments of who we'll work with and where. And Palantir is very opinionated on where we'll work. This is something that we've spoken about for a number of years, really going back to our inception as a company. We do not offer our products in every market. We do not offer them to every customer. And then even within our customers, and really what I mean is that we've been very vocal about working with the US and Western allies over our 20+ years. Then further within our actual customers and their use of our products, this is another layered risk assessment that we take to understand what is that customer, what are they, if there's anything more holistic reputationally about working with them, as well as in my case, because I work on the deployment side, what are they actually trying to use this platform for? Because I think there's this discrepancy with kind of how we define high-risk customers, acknowledging, of course, that reputationally there's always a tie to the customer that you choose to work with. But that doesn't mean that every single use case with a potentially high-risk customer carries that same level of risk. To give an example, we've worked in defense for a very long time. I would say that the majority of our work in defense is what you would describe, or at least a significant portion, is what you would describe as more back office work. So things like I just showed, how do you manage your resources? How do you manage your inventory? In those cases, the most sensitive data that you might be handling is PII. And of course, that should be treated with the utmost care. It's why we have these privacy safeguards so fundamental to what we do. But that might actually have a very different risk profile compared to, say, a commercial customer using this on insurance, where any mistake in how they deploy this AI system could result in denial of care or very serious financial or regulatory implications. So we try to take this, what we describe as to be a layered approach, kind of going down from the big picture, who is this customer, what are they going to use this for, all the way down to how do you actually construct the platform in the context of that use case, what data is feeding into that, and how do you come to a solution that we feel we can tolerate from a risk perspective. And I would say that I recognize that there is a lot of stories and churn around us, and I would say that we on particular themes, I'd be happy to talk about this further. This is a space where we do publish not only extensive platform documentation. You can go on our website and read how every single function within our platform actually works, as well as really extensive documentation on where we work, responses to different claims about work that we've been doing. And then kind of extending into the last piece, particularly on the intersection of defense. And I know we didn't go in today to like our views on decision support systems, but this is again a theme that we've contributed to significantly in the public policy space. We've published demos, we've written about how we view the intersection of IHL and the design and use of decision support systems. And so it's a space that I would encourage, if you do have questions on this, to make yourselves or make available those public resources. But I can give a quick answer to it in that we really do view our responsibility as operationalizing different components of existing standards like IHL in our platform. So what does it look like to have distinction, proportionality reflected in the way that you design a software platform? This is everything from building a very robust common operating picture, understanding exactly what might be a civilian entity versus an actual or legitimate target, and having that all integrated into a single platform is something that we've been working on for a number of years. We partner with a number of different organizations on this, and we also talk about it publicly, as well as our views on autonomous weapon systems. We have a wide body of literature there. So I would say, if you do have questions on this, we're absolutely not shying away from the scrutiny. I would welcome you to ask us those. It's also a number of themes that we are very vocal about, and I'd encourage you to read those as well. Yeah, thank you for the question. I hope that covered it. It was a few different points.
Yeah, there is a potential, like a follow-up to this, and then we have to wrap up. But Mikey is here, so if you have submitted a questions, you're here in the room, and either I didn't represent it properly or you have more, please go to Mikey directly. But kind of following up on what you just said, there is, and to the extent that you can share, if you know, sorry, the question just skipped. So 1 sec, I am finding it again. But there is something around what happens if the customer is violating, is not acting in compliance with IHL, with international human rights law. Are there, what is the process, the escalation process internally, or what is the process that you take into account to decide whether or not to continue servicing that client?
Yeah, so I think at some point I will remember to do that. Thank you. There's a number of different things there. So I think there's this broader theme that I would like to distinguish, which is just because you are leveraging technology in these spaces doesn't mean that the existing regulatory standards and oversight mechanisms go away. And so the spaces in where we work, these customers, especially those that operate in more high-risk domains, I spend a significant amount of time with them, including in the defense space. They are acutely aware of and highly respectful of their obligations to existing law, process, and all I've really seen is a dedication to following that and seeing how they can, again, configure our platform to comply, because it always does come down to what is the actual use, what is the what is your real operational environment, what regulation, internal standards apply there. On top of that, there are more formal mechanisms that we have. If we do feel like there's a genuine breach of contract, of trust, of law, to report those. We operate in spaces where, again, we are required to report any violations with respect to use of our products, as well as, we have contractual provisions as well that are publicly available in our terms of use. So there's kind of those two pieces, but I think there's a final piece that's really interesting to me, which is there is always going to be this inherent tension in the spaces that we work where we are not able to monitor and surveil customers as they use our products for a number of legal, ethical, and other reasons. Interestingly, you see this playing out in the sovereignty debate, where simultaneously there's a request to kind of have absolute control for those government entities in this case to be able to ensure that they're using the platform the way that they want without, in this case, an American company kind of having oversight. And then at the same time, a request to monitor and ensure that no violations or no misuses of the product are occurring. And I'm not hand-waving away that there's absolutely a very complex discussion to be had there. But it does reflect, I think, what we recognize to be kind of the crux of the tension in which we operate. And that's where we really view our responsibility is not only do we have to understand, to the best degree possible, and we license our software for particular terms and scopes. So we do have, I would say, a very solid understanding of how it's being used, but then also make the software configurable to comply with the highest standard of regulatory privacy and other obligations that our customers have. And it will always live in that space, but it certainly is something that we don't shy away from. Well, thank you so much. I appreciate it.
Thank you, Mikey, for the demo. Please join me in a round of applause to thanks Mike for the presentation. Thank you. I would like now to, even if we're a couple of minutes behind, but thank you so much to all of you for asking all of these questions. As I said, Mike is around, so please do approach. I would like now to invite to join me here on stage Dr. Andrew Reddy from UC Berkeley for a thematic deep dive. I love the title, Function, Not Fiction, Rethinking AI Military Integration. So, Andrew, you want to sit here?
Sure.
Okay, perfect.
Amazing. Here we go. Mic's on. Perfect. Over to me? Yeah. We're amazing. First of all, thank you to all of you being in the room for these important conversations. It's been a really nice week. Thank you, Robin, Giacomo, Yasmin, UNIDIR team for hosting. It's been a pleasure to be here. I'm delighted to follow Mikey because he's using a lot of the same language that I do, particularly around use cases. But I'll be kind of approaching use cases a little bit from a strategic level as we look at how militaries around the world, with the support of other governments, are actually deploying these tools, at least sitting here in June of 2026. So very much focused on the here and now. And so that's what we're here to chat about. Obviously, there's a lot of things going on in the news that make this a hot topic. It's probably the reason that you're all here. Mikey just got to it during the Q&A, but obviously one of the things that makes this space very different is the role of the private sector, and kind of happy to cycle back to that in the Q&A as it's interesting. But really the crux of this presentation, which is based on an article that's just been submitted for publication, is trying to really focus in on the dangers that are posed by how AI tools are deployed in militaries today, and a little bit less on the kind of fantastical AGI, ASI conversations that tend to happen, at least where I'm from in Silicon Valley. You can't go get a coffee without hearing about AGI, not least because it's good for OpenAI's potential stock price if AGI has come. And so really, in terms of actual implementation, that's what AI actually looks like in the modal ways in which the military is deploying it. And this isn't to say that it's not worrisome and dangerous. Indeed, the ways the militaries around the world are deploying AI tools today is enough to keep me up at night. And I'm sure it's enough to keep a lot of you up at night as well. And indeed, on the left here is an example of one of those private sector, public sector partnerships that are bringing some of these frontier capabilities into military contexts in real time. And so this is a little bit of a review for all of you, so I'll get through it as quickly as possible. But really, the reasons in which you use AI are the same reasons that all of my students now use them to write essays, which is to say, right, they allow you to do things faster, you find efficiencies. This will become really clear when I talk through some of the intelligence, surveillance, and reconnaissance capabilities. So now we're able to munch together data sources that used to be kept entirely separate. So your image intelligence, your signals intelligence, your human intelligence, you can get efficiencies. And indeed, at this point, there's so many different sensors and delivery platforms that are producing data that a human operator can no longer actually parse the data sets that are being produced. And so AI tools really help you there. And then the final thing that those in the military, at least I'll speak for the US side, got really excited about in the context of AlphaGo, if you'll all recall DeepMind's tool, is the potential that these tools would actually provide you with insights that wouldn't be produced by humans. And so if you'll remember with AlphaGo, you actually saw strategy sets that we hadn't seen over millennia of human play. And the response from generals was to their strategists, what are you missing that these tools can give me? Now, of course, one of the ways to explain what was happening with AlphaGo was that it's not playing a game like a human. And this goes back to really foundational debate about what we're trying to do with AI. Are we trying to build tools that approximate humans and can pass the Turing test? Or are you trying to build tools that are trying to achieve some sort of optimality? I don't know how many of you have younger siblings. I do. When I play games against her, I want to squish her. I want to win 99-1. I assume that a lot of you, because you're all very successful sitting in this room, play games exactly the same way. That's not what DeepMind was training AlphaGo to do. It was effectively trying to win 51-49. Therefore, don't be surprised that it behaves differently than humans. All to say, that emergent properties piece is a little bit of a question mark. But I think we can all agree that those first two are very much the reasons the militaries are really excited to deploy these tools. One last thing, because I think it was useful in one of the side events yesterday that Redo hosted, is that there's lots of ways to disaggregate or disambiguate the AI. The AI is such a massive category of things that we've kind of squished together. In my head, there are clear distinctions to be drawn between kind of rules-based, more machine learning type architectures that have been here for 7 decades versus generative systems, which are the LLMs that are in the heads of a lot of policymakers and journalists. When you talk to them about AI, like usually they'll think about the ChatGPT window or the Claude window or what have you. And then the other one that's coming down the pipe rapidly here is the agentic AI systems. And so that's my shorthand. I like 3. You'll see that I use that quite a lot in the presentation. There's probably other ways to cut up the field, but I think that's useful. That's a useful way of thinking about it. And so this presentation really focuses on those first 2, doesn't really get into the agentic risks, but they're coming, and they're coming quite quickly. So this is ultimately how I think about the decision support space. Moving from left to right, you've got intelligence, surveillance, and reconnaissance, and everything up until that green line is more or less accepted. We've been doing ISR with ML for 70, 80 years. 10 years ago, when I hosted our first workshop at Lawrence Livermore National Lab on AI, a whole bunch of our 70-year-old labbies were saying, Andrew, this isn't new. What are we doing here? We've been doing this for a long time. And of course, using those tools, data analysis for sense making, and then up to predictive logistics, predictive maintenance. What all the use cases to the left side of the green bar have in common is that the failure modes are relatively innocuous. If I send material and personnel to a particular military base thousands of miles away and they miss each other by 4 days, I'll get yelled at by my boss, but nobody dies, okay? And so this is kind of deemed acceptable, and we've been doing it for a very long time. On the predictive maintenance and logistics piece, that's really since the early 2000s that we've been deploying these tools, again, for the same reasons, right? Speed, efficiency, et cetera. Where things get a little bit interesting is actually where a lot of people call the down selection of decision support, where you're thinking about using these teams for training, wargaming, which is something that's near and dear to my heart, where we see all sorts of AI implementations happening in the present moment, COA generation, courses of action, strategy formation, doctrinal formation. And then, of course, we've got this conversation about target selection now that have really been driven by some of the tools that I'll talk about here shortly. And that kind of, from the green into the yellow, this is where a lot of our conversations lie about what's appropriate, what's inappropriate, but you'll see various examples of AI implementations in the military domain in that space across a large number of militaries across the globe. Where we see a little bit less, indeed, some would argue in a singular case, is to the right-hand side of that yellow bar, where actually we're moving towards kinetic applications of force. Primarily focused on conventional, but also in the context of dead hand systems, arguably also nuclear. And so what I want to do is very quickly, in 15 minutes, run through this space and point to some of the risks that kind of concern me as we look across these spaces. And so what's really happening in the ISR side is both the kind of data fusion across sensors and different types of delivery platforms that are providing much better insight over what's happening on the ground, which you can imagine that militaries are very excited about, but also the use of AI tools to actually parse new forms of data that are very difficult for human analysts to deal with. I don't know how many of you have spent time looking at synthetic aperture radar images, which are the ones on the right here. They are very difficult for humans to get to grips with because they don't look like images that we're used to using our own optics, which are, of course, our eyes. And so one of the things that we work on in my lab at Berkeley is actually trying to build algorithms to point out, using SAR imagery, the various different objects that are inside of these images. And of course, the advantage of SAR from a military perspective is it's not blocked by it being night or cloud cover or smoke cover. And so you can imagine why that might be useful and might be important to be able to do that type of characterization. Of course, one of the risks here is that models are incredibly data hungry. And once you actually put them all together, you can no longer disaggregate where your insights are coming from. So if you are to put together the image intelligence, the signals intelligence, the human intelligence, you can no longer unpick that and say, okay, to what degree is this coming from a human intelligence source, a signals intelligence source, et cetera. That matters because any of you that have worked with policymakers will know that policymakers have proclivities towards different types of intelligence based on who they are. I worked with a number of principals who really detest, for example, human intelligence. They're like, this is all hearsay. They like to see images. All right, they like the satellite imagery. And indeed, right now, at the present moment, journalists really seem to like the image intelligence side of things as well. But of course, you can actually tell people where the insight comes from once you do this data fusion exercise. And so there's lots of conversations about trying to have separate systems with which you would try to derive insight. So in the nuclear lane, you have dual phenomenology where you want entirely separate systems pointing towards particular conclusions. But of course, right, models will perform better when you actually integrate that data together. And so there are bureaucratic and institutional reasons why you might want to do that data fusion piece. Decision support side of things is where we're also paying a lot of attention and we do a lot of deployment. This is also one of the places where we worry a little bit about adversarial applications because a lot of the algorithms that are used are relatively out there and have been for a long time. I think one of the things that I'm following closely because I'm a war game designer is a lot of the AI versus AI type play Some of you might have caught Ken Payne's recent article. I do worry a little bit about the overemphasis on AI versus AI play. It doesn't actually provide you a lot of insight about what crises would actually look like. In my experience, crises are human endeavors. And so I'm much more excited about using AI tools to augment how we do traditional games, where you're using them for scenario generation, you're using them to do white cell adjudication, and you're using them to actually create agents that we'd be playing against a human player with a particular type of characteristic. So one of the major limiting factors for any war game is the fact that I have to get as many of you in the room as possible. So I have to pay for all of you to come to California. And so one of the things you can do to scale that is to, instead of having all of you, I can have a few of you and actually have you play AI agents that have particular characteristics, right? Sec-def, sec-state, what have you. And so that's a kind of a live piece of the debate as well. Targeting has made the news quite a bit. One of the things we were talking about, some of the wargaming findings yesterday, so I won't belabor them, but in some of the wargaming that we were doing around the proliferation of AI tools in military contexts, before Gospel and Lavender, there was a lot of support for the idea that you'd be able to use some of these algorithms to decrease civilian casualties, and therefore a lot of excitement about the use of AI tools in targeting applications. That really shifted after Gospel and Lavender, although of course you can make an argument about whether that actually is an AI-ness problem or a definitional challenge about what constitutes a target that's appropriate one way or the other. And so, of course, this has led to all sorts of debates. Most recently, we've been talking about it in the context of Iran and the layering of various different AI systems together, whether they're the targeting algorithms or the chatbots that now are layered on top of those. And so I'm sure a lot of you have been reading about the cloud instantiation on top of Maven Smart System and some of the pathologies that might come along with that as the number of targets getting served from a targeting officer increases by an order of magnitude, right? So journalistic accounts have it on the order of a 10x increase in the number of targets that a particular targeting officer can actually push through in a day. So one of our researchers at the lab, Sarah Shoker, who was here for the Monday through Friday sessions, is actively looking at that, right? And what that actually means for members of the military that are having to liaise and engage with those types of systems, and whether it actually changes fundamentally what the targeting exercise ends up looking like. On the kinetic application side, we've got some, interesting definitional challenges. And so, of course, in this audience, you'll know it well, given laws. But right now, we've got this distinction that's drawn between autonomous systems that countries like the United States do not have, and semi-autonomous systems, which they do. So assets like CWIS, which, quite frankly, wouldn't work with a human in the loop. There's no way that a human targeter could move fast enough in order to engage the targets that an asset like this would be able to attack. It's semi-autonomous by virtue of the fact that it has an off switch and an on switch, and it has a human officer that's relatively close to it. But if that's the definition of semi-autonomy, right, then that's meaningful. That means something. And of course, missile defense assets operate in the same way. And so kind of these are the types of challenges that we face as we think about implementation. And of course, we actually are seeing some of these tools used in very specific contexts. And this kind of leads to a more general question as to whether the way in which we think about some of these rules in peacetime travel when you're actually finding yourself in wartime. And so you've seen examples in Ukraine of autonomous systems, whether they be unmanned surface vehicles or UAVs deployed to operate autonomously. And indeed, the argument goes that they wouldn't be able to engage those targets if they were not operating autonomously as well. In kind of the non-Ukraine context, you've also got conversations about left of launch, where effectively you're thinking about some of the ISR applications and then marrying them to the kinetic applications. And so if you were to see, right, an ICBM on a pad, at what point would you think about actually deploying a system to deal with it if you believed it's an imminent threat? So again, a lot of very thorny concerns. And then of course, you've got the nuclear applications piece. To some extent, Reto asked yesterday kind of what's overblown. I think we spend way too much energy on this problem versus some of the other ones. But dead hand systems are kind of rearing their heads again in the nuclear context. And again, worrisome insofar as every system that humans have ever built fails with some probability. And this is the type of system that you absolutely would not want to fail. So, you know, there you have it. In terms of what's concerning from my side, certainly there's a perception on the kind of sense-making side that we're getting so good at it that some of the concepts that underpin international peace and security might need to be revisited. I'm not a particularly big fan of the oceans becoming transparent argument, but you can see an argument for, in particular, geographies, right, seeing some degree of transparency that might be problematic around very particular choke points as you start to marry together sensor architectures and the ability to kind of parse large amounts of data at scale. And indeed, this is something that you can see if you actually look at military programs across the globe. And of course, this to some extent drives a race to the bottom with regards to militaries looking at one another and their types of deployment. And of course, that also yields the risk that you end up with false positives and false negatives. In the nuclear lane, of course, the example that we always point to is the Petrov incident. But ultimately, again, there's varying degrees to which false positives and false negatives are acceptable. Again, in the conventional context, maybe they're acceptable on the margin. In the nuclear context, they're absolutely unacceptable. And that's problematic. And again, when you're pulling together lots of different data sources that each inside of them have a degree of uncertainty that are subsequently getting multiplied together, and then you can't actually engage with the model to say, okay, what is the uncertainty bar on this? This is a really big problem in that context. There's also a potential desire on the part of adversaries to actually go and look at what an adversary is deploying and then seek to try to manipulate it, either on the input side or actually getting inside of the model and then looking at the outputs. I'm sure a lot of you have seen the study where we're manipulating stop signs with pieces of tape, and all of a sudden your self-driving car wasn't able to pick it up. And really the theory of the case is relatively similar in the ISR case as well. And you might think that in that situation, and indeed the wargaming bears this out, where when faced with this scenario, policymakers just freeze and they decide to do nothing. Deciding to do nothing is actually a policy choice. That's just as dangerous as the decision to do something. And so this is a pathology that could potentially be quite a big problem. In the nuclear side of things, obviously early warning is a place where we've used these tools for a very long time. On the command side, there's significant automation bias concerns, and I'll talk about that more here shortly. And then on the control side, as you start to take away the veto players, as you move from the ISR asset, whether it's a radar system or a space-based system, to decision maker, and then decision maker back down to submariner, missileer, et cetera. Obviously, the fastest way through that network doesn't involve any interstitial layers. But if you take those layers away, you're losing the ability to actually get yourself a Petrov incident, right, as some sort of fail-safe against the system not actually picking up what the reality ultimately looks like. And so that brings me to kind of the last piece. I don't know how many of you have watched the artificial escalation video from the Future of Life Institute. If you haven't watched it, I would suggest that you give it a look. It's kind of the best example of what automation bias would look like in practice. So inside of that video, for those of you that haven't seen it, you've got officers that are provided with a window that's not so dissimilar from Mikey's, right? Slightly different, I guess, in some ways. But effectively, there's a ticking time on a bar that says, "Do you want to do this particular military mission? Yes, no, 5, 4, 3, 2." And the idea is, right, you as the military officer are going to push the button every single time. And so that's the automation bias that we're kind of concerned about, where even if you've got a human in the loop, they're basically saying yes. And indeed, one of the pathologies there that we don't pay enough attention to in the context of meaningful human control is if your boss buys you a very expensive system, maybe from right? Palantir maybe from somebody else, you're incentivized to use it. And so you've been given a hammer and you're going to go and find nails. And so that's something that it needs to be thought about really hard on the design side as you think about implementing some of these things. There's also the challenge of that in reality, if you were in the military and you wanted to deploy the decision support tools at the higher rungs on the escalation ladder, we have zero data of relevance. In my world, right, I'm a political scientist, IR scholar, we've got some data sets like the correlates of war and the militarized interstate dispute data set. Some of you are nodding your heads, right? You were in grad school too. You'll know that that data is very messy, primarily coded by graduate students, and almost all of it is below the threshold of meaningful conflict between even peer competitors. And so ultimately, if you don't have training data of relevance, you're not going to get any sort of output of relevance. One of the ways to fix that, and you heard some of this earlier, is to generate synthetic data. I have to say, as a war game designer that generates synthetic data for a living, I'm very uncomfortable with the idea that that data would subsequently be used to make decisions about higher rungs on the escalation ladder conventionally or on the nuclear side. And so I think we really need to think hard about that GIGO problem, right? Garbage in, garbage out, and what the appropriate data sets actually would be if you were to use some of these things to actually make military decisions that are going to yield kinetic consequences. And then finally, I think this is something that I struggle with quite a lot as an academic and an analyst in this space, is that ultimately I get a piece published on the basis of a p-value of 0.05 and less, right? And so like the theory of victory for me is probabilistic. Policymakers are operating deterministically. And so there's something of a gap there in terms of how we talk to each other about the kind of the analysis side, and then ultimately what policymakers are going to do with it. And I'm sure Jane, among others, saw that in practice, actually when engaging with policymakers. So these are all the things, right, that are currently happening in militaries around the world today that keep me up at night. And, you know, AGI is going to come, and that's going to be something to worry about as well. But there's plenty of work for us to do from my perspective here. And I'm hoping I left time for questions, but I'm not sure I did. So.
Yes, you did. Not much.
Okay, perfect. Good.
Not much, but there is some. Okay, so a couple of questions. Well, there are quite a few questions in the chat. Again, I do invite you to reach out to Andrew. So one is about AGI and the race for AGI. The question reads, the race for AGI, some would say, is a convenient framing for companies that want to cut corners, oversight bodies that want to look the other way, industry-backed politicians, etc. Do you agree that there is a winner? The victory might last about a month, if that. So that is one question on AGI. And then there is another one that is quite recent, but I think it points to a good, it does a little bit of a pushback, or it challenges one of your assumptions, if I can find it, which is the idea that mistakes within AI applications in ISR are lower risk. This is a reference to your first graph that you showed. If Intel is what underpins any of all targeting decisions, should it be considered, be pushed to the right, basically, on that graph? Shouldn't we reconsider what safe integration of AI in ISR looks like, and how we might mitigate some safety issues there?
Yeah. So on the second one first, I think because the answer is it's lower risk, is that we've been dealing with the problem for far longer. So we've had 8 decades of trying to make sure that we're parsing that data correctly. Now, you could make the argument that the scale of the data coming in from those new sensors and new delivery platforms is such that it's creating entirely new categories of problems, and I can get on board with that argument and move it to the right. But in terms of the ISR feeds that you have from radar systems, space-based architectures, et cetera, we've effectively gone through all of the failures such that, right, you've built remediations to those over the course of 80 years. But yes, if you're deploying, so the SAR example is actually relatively informative here of one that you might want to push right, because if you're building a generative model to actually do object detection, it's going to take a lot of convincing on the part of military operators that that particular model is appropriately tested, evaluated. And actually, one of the things that we find in a lot of the wargaming work that we do is that members of the military are actually far more reticent to deploy these tools than perhaps you might think. They want it to be tested and evaluated to the hilt. And the question that they'll ask me is, has it been deployed before? And that's reductive, right? Because at some point you actually have to deploy the system in order to actually be able to answer that question in the future. And so I think there are some parts of the ISR puzzle that are worth moving to the right, but there's others that are just, again, the failure modes are relatively well understood. AGI, I struggle with it because I mean, what are we talking about? If we're talking about models that approximate PhD students, we're here, right? AGI's happened. And some of the firms want AGI to have happened because it actually implicates how they deal with other companies. So specifically in that case, OpenAI and Microsoft. OpenAI stands to gain significant amounts of dollars if AGI is here. And so there's no question. I mean, I tend to be quite cynical. Like there absolutely is a part of the relationship between states and firms such that for firms it's advantageous to point to AGI to make sure that there's no regulation, AI pause, treaty, right, et cetera. And so it is a useful cudgel in that regard. But in reality, I think rather than kind of settling what it is when we mean by AGI, I think one of the things that I'd much rather see is countries really thinking hard about what regulation and legislation actually looks like for the use cases that are deemed to be high consequence enough that you want to have some degree of oversight.
Thank you. One last question before I let you go. It's a quick yes or no answer, basically. Do you believe that we are on, this is actually the highest voted question. Do you believe we're on track to remove human involvement completely from the battlefield, and that we will eventually reach a stage where AI-enabled technologies and automation or autonomous systems will be fighting with little to no human input? Kind of guess what you're going to say. If you don't want to do yes or no, you want to give maybe more of a time scale, that would be useful.
That really is driven by where do we think agentic systems are going and how fast do we think they're going to be deployed. The secret sauce of an agentic system is that the human is not in the loop. You're giving it a goal function and it's off to the races, right? Unfortunately, I don't think that means, so one of my students at the start of my AI course said, wouldn't it be great if the AIs could just fight the other AIs and we could have no humans get killed in conflict? Unfortunately, as I think everybody in this room recognizes, war is a human endeavor. Indeed, one of the things that was really interesting about one of the recent episodes in Ukraine was that for the very first time, you had a non-human asset taking and holding territory. Previously, the theory suggested that that wasn't something that you could do. But I think that, I still go to conferences that are 3 days long, where one day is on meaningful, one day is on human, and one day is on control, or backwards. And I think that to some extent, the technology may overtake us. So that's well worth thinking really hard about.
Thank you very much, Andrew, for your presentation and for your answers to the questions. Please join me in thanking Andrew with a round of applause. Thank you. It is now my pleasure to invite here on stage Dr. Jingjie He from the Chinese Academy of Social Sciences for another thematic deep dive with the title, The Emerging AI Battlespace, Counter AI Threats to AI-Powered Satellite Remote Sensing Analysis. A very complicated title. I hope you can make it simple for us. Please. Slides?
Yeah.
Slides?
Yeah.
We're just loading them.
Thank you very much for the introduction. And it's always a pleasure to come back to UNIDIR as a member of RISE. Today, I'm going to talk about remote sensing, satellite remote sensing. So remote sensing is a data collection techniques that enables the detection and monitoring of physical characteristics of targeted objects
or areas. It is achieved by measuring reflected and emitted radiation from targets using various types of sensors, for example, optical, radar, thermal, LiDAR, etc. That's the previous slide. Remote sensing can be deployed on different platforms, for example, satellites, UAVs, aircraft. So we're going to talk about satellite remote sensing, but at the end of the day, some of the conclusion also applies to other platforms. The required data is generally visualized as imageries from an overhead perspective. So today we are witnessing the growing integration of AI in satellite remote sensing. At the same time, this technology advancement is making these systems increasingly vulnerable to a range of counter-AI threats. So how might counter-AI techniques and tactics affect satellite remote sensing analysis? This is our topic today. Next slide, please. So first of all, I'm going to talk about the background, how remote sensing is applied in international security, and then the trends of AI-driven satellite remote sensing. Then I'm going to introduce you 4 types of threat scenarios and their characteristics. I'm going to bring you through some of the models. Lastly, I'm going to talk about some defense frameworks. Next, please. So first of all, satellite remote sensing in international security. Next. In international security, satellite remote sensing is a critical geospatial intelligence tools that can help us first identify objects, for example, facility identification and monitoring, and second, identifying changes, for example, facility construction and deconstructions, and thirdly, identifying movements, for example, wartime maneuvering and delivery system tracking. Next. On the screen, you can see a very high-resolution satellite imagery shows a truck loaded with 18 containers in front of the South Tunnel entrance at the Isfahan underground complex in Iran on June 9, 2025. The visual and technical analysis based on this image suggests that Iran has been transferring a large portion, probably all of its stockpile of highly enriched uranium of 60% to Isfahan on that day. If the conclusion is accurate, this analysis would mean that the enriched uranium material at the other Iranian nuclear facilities were probably empty before the June strikes last year. So in other words, this raised the question as to whether there is any enriched uranium at facilities that Trump administration claimed to have obliterated in June. So this is the value of, this is an example of remote sensing, satellite remote sensing in international security. Next. So in the past decades, we see an increasing number of satellites, especially since 2020. So from 20 to 23, we see the active satellites nearly tripled. From 23 to 26, the active satellite number actually doubled again. So overall, the active satellite population has grown by approximately 500 to 600% since 2018 due to mega constellations such as Starlink. Next. So advances in satellite remote sensing and the development of satellite constellation has enabled near persistent Earth observations with significant application in international security. However, challenges remains in processing and analyzing this vast volume of data, primarily due to reliance on manual analysis by highly trained specialists. So manual analysis faces 3 limitations. First, organizations often lack the manpower to provide comprehensive analysis coverage of remote sensing data. Analyzing satellite imagery requires technical expertise and practical experience. So based on key indicators, as we see in the previous Iranian examples, researchers reached the conclusion based on a number of indications. For example, the volume, the product features, the quality, the the weight, the package, etc. So it's very complicated. So in real time, this makes real-time analysis nearly impossible with all those big, large amount of data. Second, human specialists may struggle to identify subtle patterns or anomalies, especially in low-resolution data. For high-resolution imageries, cognitive bias and target insensitivities may also result in overlooking critical data, informations. Lastly, remote sensing analysis can be coincidence-based. Oftentimes, analysts review imagery without a clear sense of what to look for. So they might miss some important details, but at the same time, many valuable discoveries are found based on coincidence. Next. So to address those limitations, researchers have turned to artificial intelligence and machine learning to analyze satellite imageries at scales. These technologies enable figure granularity, greater accuracy, higher efficiency, and better coverage. So here we are next. Here we are really talking about computer vision. So which is computer vision is using AI to acquire, process, analyze, and understand digital images, videos, and other type of visual inputs. Next. This is a use case for applying AI in satellite remote sensing. And this was done by Oak Ridge National Laboratory. They use AI to dehaze imagery. So on the left side, you have an original photo on image. On the right side, it's dehazed. Next. Another use case is a collaboration done by Orbital Insight, Janes, and Stanford CSAC, and Black Sky. Black Sky is providing the imagery, and Orbital Insight is providing AI assistance. So what they did is that those 4 teams collaborated to find a number of Iranian nuclear facilities. Next. So with all these, does this mean the end of the hide-and-seeker game? Of course, the answer is no, because the development of technology and countermeasures is a very dynamic process. Next. So now I'm going to introduce you 4 counter-AI threat scenarios. The first one, as we just mentioned in the previous presentation, is data poisoning or contaminating attacks. So data poisoning attacks aim to contaminate AI models during their training phases by injecting adversarial artifacts into the training data. Next. What do I mean by data poisoning? Next, please. This is an example. It's not a data poisoning attack, but it shows the function of data poisoning. This is researchers use those photos, the skin lesion photos, to train the models to understand which one is malignant skin lesions. After the training, they realized that the system is not really identifying skin lesions, but identifying something else in those 4 photos. I will encourage you to take a guess. So, what? The light? Not the light. No. So we see something in common is that there's rulers right next to the skin lesions. So the rulers is embedded to indicate the lesion size. It's a practical medical way to indicate the size of the lesions. But then the models, the skin lesion detection model is actually identify the rulers instead of the lesion. So imagine if developers rely on openly accessed online photos for trainings, many of which may have been manipulated by malicious actors to include artifacts like the rulers here in this example, then the model's accuracy in identifying targeted objects will be degraded. So in real-world attack scenarios, such injected artifacts may consist of geometric patterns blended perfectly into the original image, or carefully designed pixel-level modifications that cannot be identified by human eyes. Next. The second threat is model evasion. Model evasion attacks alters the data and pixel of input data in the post-training stage, and therefore confuse and evade the model. Next. So what do I mean by model evasion? This is an example. On the left hand, you have left side, you have a picture of a panda. So the model is 57.7 confidence that it is a panda. But then if I add a perturbation and reach the photo, image on the right side, for us, it's still a panda. But for the model, it's 99% confidence that it's a gibbon. Next. So in this study, researchers placed adversarial patches on the vehicle, as shown on the photos on the left, and then another off and around the and another patches off and around the vehicles, as shown on the right side. So they find that both patches can confuse automatic object classification system. So I want to show a short demo now.
Really testing the technology here. Here we go.
Yeah.
Which one is it? Physical. Is it physical?
Yeah, I think so.
Not projecting on the screen. We'll get there.
I have a plan B. Would you like me to go for plan B?
I think plan B is safer, but
It's okay. We have.
It doesn't look like the tech is cooperating.
Good, because I have a plan B. So we can go to the next slide. So this is actually the video I want to show to you, but I took a few pictures to demonstrate it.
We'll give you this time back.
Okay.
Nope. We've broken everything. We're asking for a technical.
We're discussing high-tech issue, and then now we are stuck at the low-tech problem.
Do you mind if we come back to the visual example as soon as we manage to fix this? And in the meantime, you can continue with your brief. Hopefully, it won't take more than a couple of minutes.
Okay, but it's always images.
Can we please have the technical assistance here on stage, please? Thank you.
Okay, we're back.
Okay, we're back.
Okay, this is actually what's in the videos, the demos that I want to share with you. So on the left side, you have a car. On top of it, you have some adversarial patches. And in the middle is the machine learning results, the classifications results, where there's no patches. So you see the machine is able to identify the cars. But on the right side, there's a car with patches. And then the machine was unable to identify that. Next. This is the second examples. So on the left side, you see the patches is around the cars. So it's basically creating something like a safe zone, security zone. In the middle, you have a photo, for within the video that in the video is this is like without when the car is outside of those adversarial patches. But when the car is driven inside of the patches, the machine was unable to classify it as a car. And then in the video, the car was driven outside of the patches, the secured zone, without from the different directions. And then the machine was able to identify the car again. Next. The third type of threat is data inference, or sometimes it's also called model evasion. It involves attempts to unveil and steal the training data used by machine learning models in the post-training stage. Next. So this is an example. On the right side, you have the original training data, and then you train the data with a number of photos, and then you provide and then when analysts don't have access to those models, they were able to produce the data, reverse engineer the data on the left side. So it's very similar. It's a very good result. When it comes to international security, so it can lead to leak of sensitive and even classified informations. So lastly, the model extraction attacks aim at duplicating the functionality of a victim data. So in this type of attack, the malicious actors seeks to infer the architecture and parameters of the victim model, and then trains a surrogate models using the data set comprised of inputs and outputs obtained from repeated queries to the victim models. So model extraction attacks are able to target black box machine learning models accessible through APIs or non-device sandbox apps. Next. So this is an example. Researchers have already found that model extraction can steal different types of models. For example, image classification models, image-to-image translation models for style transfer, and resolution improvement models. So this example is a photo-to-eminent models. So on the left side, you have the original pictures. So in the middle, you have the victim model. So it's basically transfer the image from the left to the middle. And on the right side is the result of the surrogate models. So we see that the results are pretty similar to the original models. So imagine if malicious actors were to duplicate classified satellite imagery analysis models, so it can enable more targeted and effective models for concealing proliferation related activities. So now I'm going to introduce you briefly on the defense side. So first of all, we need data and model access and quality controls. For example, monitoring the entire life cycle of data and metadata, assessing the quality of raw data, understand the development history of the models, their characteristics, their limitations, and access controls. And second, we need to build robust frameworks. This can be done through immunity trainings, but then we need a comprehensive, up-to-date perturbation database. This is the most difficult part. And also we can build introspection mechanism with human in the loop. Thirdly, we need systems where we can we should enhance the monitoring capability of the systems. So in addition to white hat hackers and AI red teams that we mentioned earlier today, real-time anomaly detection and meta-analysis, which is system analyzing systems, are important. Fourth, humans. We need knowledge sharing on machine learning models. As we mentioned, the development history, their limitations, etc. And also we need to cultivate a sense of AI skepticism. AI is less magic than we imagined. Also, we need psychologically be prepared for both risks and uncertainties. Risk is like the things that we understand and we know that it exists, but uncertainty means that the kind of things that we don't know that it exists, so it will surprise us. And be ready for that because it's very likely to be coming. And lastly, we need management. We need agile management approach to enhance adaptability, and also we need contingency plan and low-tech options to enhance resilience. This is the end of my presentation, but last but not least, I want to send you a core message, which is AI function not only as a force multiplier, but as a threat multiplier as well. The increasing integration of AI transforming arms control, non-proliferation, and peacekeeping missions into increasingly dynamic hider-seeker games. So for AI in military domains, it means that we will be facing an emerging AI-centric battle space. This is why we need a platform as we are today. So thank you very much for listening, and this is my contact and a QR code for my article where you can find more details, detailed explanation on this topic. Thank you.
Thank you. Can I ask we have a few questions from the floor. Are you okay?
Okay, yeah.
Yes. So thank you so much for those of you who shared with us your questions. And again, apologies for the technical glitches. It looks like we have resolved them. So thank you so much also for your patience. So the first question reads as follows: given the risks of counter AI threats, how can we ensure that AI-powered satellite analysis remains reliable and it isn't easily manipulated to create false alerts? I'm going to read also a second one, so you can have additional time to think this through. You mentioned the use of images found on the internet to train recognition algorithms. In that specific case was about lesions. But what are the ethical reconciliations with training LLMs or other AI tools on publicly accessible information without express permission of the data subject? So more on the privacy side. And then this one is interesting as well. It focuses on the militants or armed groups creating inflatable decoys of military vehicles and other infrastructure to thwart AI targeting technology. So this really points to the question of, if you believe that armed actors will continue to always stay ahead of the curve in a way, there is always this competition between measures and countermeasure, if you want. So how do you see this continuous competition playing along?
So the first question, how do we ensure reliability of the satellite remote sensing systems? So we cannot ensure the security of that because, as I mentioned, it's always a dynamic process where you have technological advancement and counter-technical measures. So it goes both ways. So you have technology, you have countermeasures, and you have better technologies to counter those countermeasures. So that's why I'm saying that you always be prepared for risk and uncertainties, and because this is coming. Second question about the ethics and privacies of AI models, including not only the the computer vision, but also the LLM. I think first of all, for ethics and privacies, this is very specifically owned by the data owners. So this is something that we need to consider. You cannot steal data. But in the end of the day, I think you need collective actions to decide which data can be shared in public or used in training models. But this is very difficult because of the politicization of the international, politics. So I give you an example. During the COVID, there's countries saying that, hey, let's have a declaration saying that you cannot attack the data from hospitals. And then there are two big powers. Both propose such a proposal, and none of them get approved universally. And it took such a long time to do that. But for our common sense, it's something that we were supposed to do. Don't attack hospital data during COVID. But politicization makes things very difficult. So to sum up, the data, we need to consider the data owner, but also for others, security consideration, we need a collective efforts. Third question is about whether armed actors will stay ahead of the competition. Nobody stay ahead of the competition in this game. So there's always the dynamics. So one side initiates a new technologies, tactics, the others figured how to solve it. Imagine you in real battlefield scenarios, when one side has an advanced weapon or systems, the other side usually can find a very good way to, reduce its accuracies and countermeasure it, probably within a week. So this is also the same for AI battle space. So I'm pretty optimistic because we're gonna face threats and we will prepare ourselves psychologically. But when we are having those threats, we have all those defense framework and systems that help us solve the problems as soon as possible and prevent the next problems. And this will goes on and on. It's a continuous game. Thank you.
Thank you. One last question for you. If you can try to give a quick answer. I know there are no such thing as quick answers, but I'm going to try anyway. If this is the level, so if your presentation is the level where AI can fail due to model evasion or data interference, why are states working on adding AI in early warning systems? I'll stop there. The question has another part, but in the interest of time, I just wanted to focus on this part, if you can.
I can take a guess because I think, first of all, politicians, the top political decision makers are not fully aware of those risks. This is why I'm here and we are here today. And also, there's a huge gap between the technical community that understand the technology and the problem of those models and the politicians and decision makers. So I'll give you an example. I was in IEA for an AI consultation meeting. So we are deciding with all those big tech companies together in one room, deciding what kind of, how do we design the models, for example, using say like remote sensing to improve non-proliferation missions. And nobody talking about the threats of remote sensing. People are just talking about say like remote sensing, and when AI can empowering it, then it will be like, a huge improvement, but nobody take into consideration of the risks. And another example is when I work in the AI industry. So I was in Israel working in a company that deal with transferring military technology to civilian technology. So in Israeli military, they have psychologists deciding which position you are best fits for your characteristics and etc. So the civilian application is AI interviews. So you can imagine it's a very complex model with visuals and textual analysis. And what we did when we, trying to, if this is a very famous model, like if you have an interview with Air Canada, you are using this model for your first round of interviews. And then we want to do it for, do a Chinese version for our customer. And then my boss was just like using like Google Translate instead of, training the model in the Chinese context. So I asked my boss, do you think the Chinese partner knows about it? And he was like, Ginger, let's try to keep under their radars. So, there's a huge forces in the industry that we don't want our, investors or governments to understand the problem of our systems. So this is the problem that we need to work on.
Thank you also for taking the time to answer all of the questions. We're run out of time for your segment, but please join me in a round of applause to thanks, Jinjia. Thank you. Okay, I'm now ready to leave the floor to my colleague, Joanna Pushkas, who will be emceeing the rest of the afternoon, and she will be introducing the next series of lightning talks. Joanna, please, over to you.
Thank you very much, Giacomo. Good afternoon, everyone. I'm very happy and pleased to be here with you for the rest of the day. And we will start with the remaining lightning talks and the thematic deep dives. So I'm very pleased to now welcome on stage the first speakers for the first three lightning talks. First, we will be joined by Maysem Alagami from the American University in Cairo, who will speak on her talk will be on the clock is already running, how quantum breaks the security promises underneath AI governance, followed by Barack Ogada from University of Nairobi, whose talk is titled Sovereignty Under Code, AI Infrastructure Dependence and the Reconfiguration of Security Decision-Making in Africa. And the third in line for the time being is Tasnime Elmir from Keystone Group, whose the presentation is titled Governing the Unlabeled, How Weak Classification and Labeling Destroys Our Trust in AI. So I'm very pleased now to give the floor first to Maysem for her very short but enlightening lightning talk. Please.
Thank you so much. Okay. Every AI governance framework adopted in the last 5 years, the AU AI Act, the Hiroshima Process, national AI strategies contain a silent assumption that that assumption is that the layer underneath the AI is trustworthy. However, this assumption is already being exploited. My name is Maysem Al-Agami. I'm a cryptography researcher in the American University in Cairo. I'm working on a cryptography algorithm called Tiny Jumbo. It's a symmetric key algorithm, and it works in very low power environments like IoT devices. I'm trying to make it post-quantum algorithm. This is what we're going to talk about today. And I have a 5 minutes to explain why the clock is already running and what should we do. Okay, let me explain something first. Does everyone know what is cryptography? Okay, basically cryptography is a way that we transform the normal text into a cipher text, so only authenticated users can use it or transform in it or have access to it. And all cryptography algorithms must achieve three main things: CIA, confidentiality, integrity, and authentication. And cryptography algorithms fall under two main subgroups: public key and private key algorithms. And by the way, like in many use cases, they use both together. For example, in the WhatsApp encryption. So when people write about AI governments, they mandate transparency, safety, accountability, and fairness. They have the right to do so, but every one of those priorities rests on an assumption that they did not write down, that data pipelines feeding AI are authenticated, that AI communication is confidential, and that model outputs can be verified. So this means that they achieve the full CIA. These guarantees are delivered entirely by a public key cryptography, like, for example, RSA or elliptic curve encryption. However, not one major AI governance instrument, not the EU AI Act, not the Hiroshima Declaration, not any national AI strategy that I have reviewed names these foundations. It just assumes it. And here we can find that there is a gap between technology and governance. Next. Now we're going to talk about the attacks. A normal computer, only the output has either a 0 or a 1. However, the quantum computer is very different. It falls under the idea of qubit. The qubit can be a 0 and a 1 both at the same time, which makes it have a very large computational power and can break any cipher text very easily. So today, we do not need quantum computers. They need storage and patience. They are collecting encrypted outputs from AI systems right now: defense, logistics, healthcare, diagnostics, critical infrastructure control, agent-to-agent communication, and autonomous systems. Okay. So basically, the quantum computers are working on this assumption. It's called harvest now, decrypt later, which means that when quantum computers start to work, they can easily break any cryptography algorithm that we are working with right now. Next. So here we have a governance gap. The NIST, National Institute for Standards and Technology, has standardized some post-quantum cryptography algorithms. However, in its framework for the governance, it did not mention it at all. Which makes the gap between the technology and the governance. Okay, so what should we do? Any AI governance instrument covering sensitive, long-term, or security-adjacent data should include post-quantum cryptographic compliance as a baseline criteria, the same way we mandate privacy and safety. Secondly, post-quantum readiness should become a component of AI system conformity evaluation, not an optional annex, but it is a required audit dimension. The UN is the appropriate venue for a working group to develop post-quantum compliance standards for AI systems across member states. The window to do this before large-scale quantum computers exist in the years, not in decades. Next. So this is my final talk. Thank you so much for listening to this. The main idea behind it that quantum computers are coming very soon, and we should be ready for it because it's going to break all the cryptography algorithms underneath our AI systems. Thank you.
Thank you very much, Maisem, for your thoughtful remarks. Thank you. We're moving now to Barak. Please go ahead. Barak, you have the floor.
Distinguished scholars, policymakers, diplomats, ladies and gentlemen, I am honored to be in front of you today to share with you my thoughts on a topic I call sovereignty under code, AI infrastructure dependence, and the reconfiguration of security decision-making in Africa. Today, sovereignty is no longer determined by territory or military power. It is increasingly controlled through code. Across Africa, governments are rapidly adopting artificial intelligence for policing, surveillance, biometric identification, border control, cybersecurity, and counterterrorism. These systems promise efficiency, security, and modernizations. However, this promise lies geopolitical transformation. Many of these AI systems are not designed, owned, or governed within Africa. They are imported. The cloud infrastructure is foreign, the surveillance architecture is foreign, the algorithms are foreign, the standards are foreign, and the logic of security itself is becoming foreign. My paper argues that this creates a new form of algorithmic dependence in which sovereign authority over security decision-making becomes partially externalized through opaque computational systems controlled by foreign corporations and geopolitical actors. In other words, African states may appear digitally empowered while simultaneously becoming computationally dependent. This is what I refer to as sovereignty under code. The issue is not whether AI is useful or not, but who governs the infrastructure through which AI is governed. Today, AI systems increasingly determine who is suspicious, who is monitored, who crosses the borders, who becomes a security threat, and how states allocate coercive power. But many governments deploying these systems cannot independently audit their algorithm success and access the data or fully control the data architectures behind them. This creates challenges. One, opaque governance. Many AI systems operate in what realists refer to as the black boxes. Citizens do not know how decisions are made. Governments themselves do not really understand how decisions are made, which makes even democratic oversight very, very difficult. Second, strategic vulnerability. When critical national security systems rely on foreign cloud infrastructure, foreign software licensing, and external cybersecurity maintenance, sovereignty becomes fragile. A geopolitical conflict, cyber disruption, or infrastructure shutdown could compromise core state functions. Third, political externalization. Imported AI systems often embed external assumptions about risk, surveillance, and governance. Predictive policing systems obtained and trained elsewhere may reproduce foreign threat classifications within African societies. Facial recognition systems built on biased datasets may criminalize already marginalized populations, and surveillance infrastructures may normalize authoritarian governance under the language of innovation and smart security. This means that AI governance is not simply a technological issue, it is a political question, a geopolitical question, and a sovereignty question. The finding of my research is that African risk entering the AI era as a consumer of computational power rather than a producer of sovereign digital systems. And history teaches us that the dependence on strategic infrastructure rarely remains neutral. This is why the debate on AI ethics alone is insufficient. We must move beyond this and start asking, who owns the infrastructure through which AI is applied? The future of global security governance will not be determined only by states. It will also be shaped by cloud providers, data architectures, platform cooperation, and algorithmic systems operating across borders. For Africa, the challenge is preventing technological modernization from becoming a new architecture of dependency. Therefore, my paper proposes three things. First, sovereign AI capacity building. African states must invest in domestic digital infrastructure, public cloud systems, local AI ecosystem, and research institutions. Second, regional governance. The African Union and regional blocs should develop coordinated AI governance frameworks, cybersecurity cooperation, and continental regulatory standards. Third, global reform. We urgently need international transparency standards, algorithmic accountability mechanisms, and protections against exploitative forms of AI dependence. In conclusion, for centuries, sovereignty was measured by control over land. In the 21st century, sovereignty may largely depend on control over computational infrastructure. As security increasingly operates through algorithms, cloud systems, and AI architectures, the critical political questions of our time may no longer be who controls territory, but rather who designs, who owns, and who governs the code through which security itself is decided. Thank you for your attention.
Thank you very much, Barak, for sharing your thoughts. Now we will hear from Tasneem. Please go ahead.
Thank you so much. Good afternoon, everyone. Thank you for having me today. So I'll briefly introduce myself. My name is Tasneem Elmir, and I'm a cybersecurity consultant at Keystone Group. We at Keystone Group, after several years of experience in the cybersecurity field and specifically in the AI security, we believe that trust in AI is not just a technical feature, but more of a good governance outcome. And that governance begins with the simple yet powerful discipline of classification and labeling. Well, when we mention classifying and labeling AI assets, we mainly talk about three controls, two of which are from the ISO 27001, control 5.12 and 5.13, and we have the control 8.8 from ISO 42001 that requires communicating AI system information to stakeholders. In fact, These three controls are governance mandates, but when organizations treat them as administrative checkboxes rather than requirements for our safety, they lose the ability to protect what matters most. You may ask, it's just labeling, it's just classification. Why is it important? The answer is simple. Trust relies on three pillars. We have confidentiality, we have integrity, and we have availability. I will quickly go through each one of them. So, confidentiality means that only authorized people have access to sensitive information. In the military, this is a life or death situation. Imagine, for example, an AI-powered battlefield reconnaissance system. It processes satellite imagery and troop movement data, but no one labeled the data as top secret. Then a developer without proper clearance accesses it. Worse, he may even share it, publish it, etc. That's a confidentiality breach that compromises national security. Secondly, we have integrity. Integrity means that data and AI outputs are accurate, authentic, and unaltered. In military operations, integrity failures means wrong targeting. For example, an autonomous drone targeting system relies on AI model to distinguish combatants from civilians. An adversary poisons the training data, altering images so that civilian vehicles are misclassified as hostile targets. Then, without integrity labeling and checking, the military deploys the poisoned data. Therefore, even a military convoy can be targeted. Thirdly, we have availability. Availability means that any system is accessible when needed most. For example, let's take the example of a nuclear plant that uses an AI system for threat detection. During a cyber attack, the system goes down. The IT team, without proper knowledge of a criticality of each system, may, for example, restore the logistics system instead of the critical system that is used for threat detection. Therefore, the nuclear plant may operate blindly for hours without any proper detection. They're insecure, and therefore an intrusion might happen. So, we discussed these three pillars. Therefore, what are the solutions? We have mainly three. First, we have to classify all assets. I'm not just talking about data sets, also models, logs, outputs, and not just as confidential or secret, but also as mission-critical model or even training data restricted. Secondly, we have to enforce human-readable and machine-readable labeling. Thirdly, we have to ensure continuous audit to review labeling effectiveness. In conclusion, here's the hard truth. On one hand, just a quick conclusion. On one hand, we have the ISO 27001 that was written for information security. On the other hand, we have the ISO 42001 that was written for information for AI system management. But we don't have like a norm, a specific norm, a norm with detailed and granular controls that protect AI systems and data in AI systems. So I believe that we must take these two norms, merge them, build upon them, and we develop a dedicated international norm for AI controls. Because at the end of the day, without proper classification and labeling, we are not governing AI. You are hoping it controls itself, and hope is not a control. Thank you.
Thank you very much, Tasnime, for your brief remarks. Now, I just ask for your indulgence for a few seconds while we reshuffle a bit the stage. I will invite to the podium now for the last lightning talk of today, the two remaining speakers, Zahim Iqbal from the Pakistan National Cyber Emergency Response Team in the Cabinet Division of Islamabad. This speaker will participate and contribute strictly in their personal capacity. And secondly, Professor Mohammad Kuram Khan from the King Saud University. I welcome them on the stage.
Thank you very much.
Of course. And whenever you're ready, you have the floor.
Distinguished delegates, good afternoon. Before we begin, I would like to mention that this research is co-authored by myself and Professor Muhammad Khurram Khan from King Saud University, Saudi Arabia. Imagine a military AI system trained on data from one continent and deployed on another. It scans a landscape it has never truly seen. It reads human behavior from cultural lens that was never its own, and it makes a decision. Ladies and gentlemen, this is not hypothetical. This is the true reality of global military AI trade. And without international standards, we have no way of knowing how often it gets it wrong. Military AI has become a globally traded commodity these days. Nations that cannot develop these systems domestically, they're importing from handful of technologically advanced nations. This creates what our research calls the transnational algorithmic gap, the growing divide between nations that develop military AI and those that deploy it without any involvement in how it was built. Every AI model carries the fingerprints of where it was made. Training datasets usually reflect the geography, visual culture, social norms, and threat environment of the developer's home nation. When exported, these hidden biases travel with the system. The result is obviously the failure to recognize local terrain, misreading of civil behavior, and most critically, misidentification of threats. These are not bugs. These are structural, systematic, and invisible to importing nations. Presently, as far as our research is concerned, there is no international framework requiring that exported military AI be audited for data neutrality. No standard mandates cross-cultural validation before deployment. And exporters face no obligation to disclose the demographic or geographic composition of their training data. This is, at its foundation, a question of algorithmic sovereignty, the right of every nation to understand, to evaluate, and contextualize the AI systems that operate within its borders. Right now, importing nations are surrendering that sovereignty by default, not by choice. And that asymmetry demands a multilateral response. Ladies and gentlemen, our research proposes the Universal Data Neutrality Protocol, the UDNP. This framework does something no existing instrument does. It moves AI safety from a voluntary debate into a mandatory trade standard. It rests on three pillars. Pillar one, mandatory neutrality audits. Before any military AI is exported, the supplier must demonstrate that their data is globally representative and context neutral. This is not optional compliance. This is a precondition for market access. Pillar two, local calibration. We must end the plug-and-play era of military AI. Importing nations must have the legal right and the technical capability to tune these systems to their own terrain, population, and threat environment before deployment. And pillar three, trust and sovereignty protection. By standardizing these requirements globally, the UDNP creates a foundation of trust between technology exporters and the international community, ensuring that algorithmic sovereignty is protected, not eroded, by technology transfer. In conclusion, the regulation of weapons has always followed their proliferation. This body has shown that international norms can shape how technology is used, even when the technology moves faster than legislation. The transnational algorithmic gap is widening. Algorithmic sovereignty is being quietly surrendered every time an unaudited system crosses the border. The UDNP offers a concrete, implementable standard to reverse that trend. I urge this forum to consider it, not as a barrier to innovation, but as the foundation of trust that responsible innovation requires. Thank you very much. If you have any questions, you can ask. Professor Khurram is here, and we are here to answer. Thank you.
Just one quick thing. If anybody is interested to work with us on this protocol, so we'll welcome you all. And if anybody has some kind of suggestions, so please feel free to pass to us. Thank you very much.
Thank you very much, Zahima and Professor Khan. We will now move to the next item on our agenda, which is a thematic deep dive. You already know the format. These are longer sessions, so now for the next session, you will also be able to ask questions. I urge you to go back to Slido, to use it even as the speakers will present, and I will collect the questions for the end part of their presentations for the Q&A. So I'm pleased now to invite on the podium Christiana Onoja from the Defense Industries Corporation of Nigeria and Colonel Felix Alaita from Criterion Limited. Their presentation is titled Human-Centered Proactivity in Defense AI, Rethinking Agency, Judgment and Responsibility.
Good afternoon, everyone. It's such an honor to be here today and a privilege to be here. I want to especially thank UNIDIR for putting this conversation, very timely conversation together. I also want to thank everyone for joining us here today in Geneva. Over the next 30 minutes, Felix and I want to move past the most familiar headlines about AI in defense that we hear right now, conversations around dramatic or fully autonomous weapons, making a lateral decision on its own. We're beginning with a quieter shift that's already shaping security practice. AI systems that do not simply wait for a human question, but begin to act first. They filter large information flows, they flag anomalies, they rank risk, they surface recommended next steps, and by doing that, they shape what the human operator notices, what the commander treats as urgent, and what the institution later regards as a reasonable course of action. Public discussions on systems such as Maven Smart System, StarShield, and other AI-related defense architectures show how quickly the decision environment is changing in defense. Our aim today is not just to pass judgment on any individual company or institution, but to bring together useful points around what the commander treats as urgent, around how defense is moving from passive tools to active participation in how situations are perceived and framed. That is what we mean by proactivity. And our argument is simple. Proactivity can be valuable when it accelerates understanding. It becomes dangerous when it quietly narrows human agency. And agency is very important in our conversation today. The question is not whether defense institutions should use AI, but the question is how do we design it? How do we procure it? How do we govern it? And how do we train the systems to take initiative without taking over judgment. So I'll hand over now to my colleague, Felix. To take it
Thank
up.
you, Christiana. Good afternoon, everybody. It's a pleasure to be here. Am I on? Can you hear me? Can you hear me? Can you hear me now? Good. My name is Felix. So in continuation with what she's saying, we are calling this frame human-centered proactivity, not because the phrase is comforting, but because it gives us a practical test. If a system takes initiative, we must ask, initiative on whose behalf, under whose authority, and with what consequences for responsibility. We will organize the session around 3 questions. First, whose goals are being advanced when an AI system steps forward? Is it advancing the commander's intent, the operator's need for clarity, the civilian protection obligation, the vendor's optimization target, or some hidden mixture of all 4? Second, how much room does a human really have to disagree? We often say there's a human in the loop, but in a fast-moving operational interface, the more precise question is whether the human has time, confidence, information, institutional permission, and technical means to slow the system down or choose a different path. Third, where does responsibility go when the machine moves first? If an AI system has filtered the data, highlighted one threat, suppressed alternatives, and pre-structured the response options, then the final human click does not tell the full accountability story. These questions are not theoretical for us. They emerge directly from conversations with defense stakeholders in West Africa, including the Criterion Defense Roundtable we convened in Lagos on 3rd June this year, and the Defense Futures Lab pathway that we're now moving through a diagnostic phase, and we'll probably come back with a result. So from Lagos to Geneva, the question is the same. How do we gain capability without importing opacity, dependency, or responsibility gaps? Christiana will first give us the conceptual vocabulary. I will then ground it in operational and institutional practice.
Okay, so we'll go through the... So we'll go through the taxonomy of initiative of AI. And to govern proactivity, we need a shared vocabulary. We need to understand what various terms are. And let me offer 3 modes of AI engagement. I'll start with the reactive AI. This is that which waits for a specific human command. A user asks a question, they can set a database, they run a model, or even request a summary. Then the system responds, the human frames the problem before the system enters. Then we have the assertive AI. This can help support a task already initiated by a human. It may suggest likely categories, populate a draft form like what we currently have with our generative AI, recommended documents to review, or even help compare options that we might have. Here's the human is still very clearly driving the sequence. But even if the system is increasing in the speed and capacity of what it can provide, this might not be totally enough for what we are doing. Then we move on to proactive AI. This is a bit different from the previous ones that I've mentioned. This one particularly monitors the environment and initiates alerts, rankings, recommendations, or even actions without prior specific human request. It may say, oh, this track looks unusual. The zone deserves attention. The option appears available, but the risk is rising when we leave it to the systems to decide for us, especially in the defense ecosystem. That can be extremely useful, but in defense and security systems, we can also handle information overload. Humans may miss signals because, humans too can let go of some tasks without prior specific human request. It may also track looks that are quite unusual, the zone that deserves attention, and the options that appear available. But proactive systems do not do more than just provide the information. They make prior choices about relevance, urgency, and salience. They help decide what counts as the problem before the human actually fully defines what the problem is. So the governance issue is not whether proactivity is good or bad, but it is where proactivity sits. How far is he allowed to travel? How far is he allowed to make decisions on our behalf? And how far is he allowed for humans to remain able to understand, challenge, or even redirect the system itself? Because most of the time, what we see is humans just receive whatever they get from the systems. Then we'll need to look at it very deeply. If we treat the initiatives as purely technical features, we'll miss the institutional meaning. Initiative is not about automation. Initiative is about agency in motion. And that's what we're here to go deeper on. So now we're going deeply again into where the human factor literatures becomes very important here. Because as we've talked about the vocabulary, it's also important that as humans, we understand the literature of what we're working on. Automation bias and automation do not occur because operators are lazy or weak. They occur because high-stakes work is cognitively demanding, and people naturally allocate attention towards the system that appear to know more, see more, and process things faster for them to take decisions. Studies of automation in aviation, medicine, process control, decision support show a recurring pattern. When automated aids are imperfect, even trained users can miss errors of omission and commission. They may fail to notice something the system did not flag or accept something the system wrongly presents as important. Training can help, but it doesn't just eliminate the effect. And that's why we still talk about the human agency here. In defense, this matters because proactive AI does not merely answer questions. It changes the field of attention. When a system highlights one track, one zone, one risk score, or one recommendation pathway, the human cognitive spotlight follows it. What is outside the spotlight becomes easier to miss. This is why interface design is not secondary in this conversation. The way the system displays confidence, uncertainty, alternatives, and urgency shapes whether the human feels licensed to disagree. If the interface presents one option as clean, urgent, and authoritative, then it becomes psychologically and institutionally harder, even when the formal policy says the human remains in control, which is very tricky. So human-centered proactivity becomes very important, and it begins by protecting attention. It asks not only whether the system is accurate, but whether the human still has enough situational awareness to inform the independent judgment.
So the cognitive shift that Christiana has described creates a structural shift. I want to name it responsibility creep. In a traditional chain of command, responsibility is not always simple, but the logic is familiar. Someone gives an order, someone executes, someone reviews. But proactive AI stretches responsibility across many small acts of initiative. The system filters the data, the model labels one object, the interface highlights one recommendation, the workflow makes one path easier than another, the operator confirms, the commander later authorizes the broader action. Afterwards, each actor can give a plausible account of limited responsibility. The commander says, I approve the mission, not every machine-generated prompt. The operator says, I followed the system support option available to me. The engineer says the system operated within tested parameters. The procurement official says the platform met the specification. The vendor says the customer configured the operational use. None of those statements may be false, but taken together, they can leave a gap where responsibility should be. That is the danger of responsibility creep. Accountability does not disappear in one dramatic moment. It thins out gradually across design choices, interface cues, contractual specifications, and operational habits. This is why the phrase human in the loop is no longer sufficient. If the loop keeps moving, and if the human enters only after the system has framed the relevant facts and options, then human control can become formal rather than substantive. The standard should be higher. Can we trace how initiative moved through the system, and can we identify who had the authority and capacity to redirect it at each stage? Let me now connect this to public examples carefully. These examples are not presented as accusations against specific firms. They are indicators of a broad design trajectory, the compression of the decision chain. So let's take Maven Smart Systems, for instance. A recent CSIS analysis describes it as a flagship AI-enabled software platform that aggregates, organizes, and visualizes large stream of intelligence, surveillance, and reconnaissance data. It notes that AI models can identify patterns, that computer vision can label potential targets in video feeds, and that workflows are embedded in the interface so users can move from observation towards action within the same environment. That does not mean humans are removed. It means the pathway between sensing, interpretation, options, and action becomes much shorter. Take Starshield, another instance. Reuters reporting has described it as a government-focused SpaceX satellite network for military and intelligence missions, including capabilities to track down targets and share data with intelligence and military officials. The governance signal is persistent sensing, more data, more continuity, and potentially less time between detection and decision. Take Anduril's lattice ecosystem as well. Anduril's old material describes AI and machine learning systems that process and fuse sensor data to detect, track, and target in real time under human supervised mission autonomy. Again, the governance question is not whether this is innovative. It clearly is. The question is, what happens to deliberation when several steps in the decision chain are increasingly pre-structured before the human acts? So our concern is not anti-technology. It is about the conditions under which speed remains accountable. Defense institutions will need AI for sense-making. But when sense-making becomes prioritization becomes recommendation, and recommendation becomes near default action, the line between assistance and dependence becomes much harder to see.
Okay, so we'll be looking a bit deeper into who can set boundaries after talking about the various aspects. We're going to be looking at responsibility limits, procurement pressure, and institutional power that exist. There's another layer here, which is who has the institutional power to set boundaries on AI initiatives. A recent and contested example is the reported dispute between Anthropic and the United States Department of Defense. Reuters reported that a standoff emerged after Anthropic refused to loosen safety guardrails on its system, and that the Pentagon labeled the company a supply chain risk. Reuters also reported that Anthropic executive reviewed the designation as linked to the company's opposition to use involving autonomous weapons and domestic surveillance. We do not need to conclude the legal merits of the disputes to draw a governance lesson from it. The lesson is that restraint has its own cost. In security markets, a company that says the model should not be used in certain high-risk ways may be praised in an ethics seminar, but penalized in procurement reality. We do not need to look at these matters for states, especially states with less bargaining power. If the actors with the most technical capacity and market leverage struggles to maintain limits, what happens to people from the low-income communities or even the Global South, for instance? What matters most is for us to look deeply into human-centered proactivity, therefore requiring more than principles written after deployment. It requires incentive structures and reward responsibility limits. It requires procurement language that accept boundaries as safety features, not weaknesses, and it requires international norms that protect the right of institutions, companies, operators, and states to say, this is the line of our system, and we should not cross it. The governance question is not only what can technology do, it's also who is allowed to say no. And that's also a question for us to think deeply on as we go.
So this is why the West African lens is not a side issue. It is central to whether these norms will work globally. At the Criterion Defense Roundtable in Lagos on 3rd June, the conversation was not anti-AI. Excuse me. Defense institutions are under pressure to respond faster, coordinate better, and understand complex security environments with limited resources. There's a genuine need for better situational awareness, better logistics, better doctrine support, better training, and better early warning. But 3 concerns came through clearly. The first is capability without dependency. Many states want advanced tools, but they do not want to become dependent on systems whose data assumptions, model behavior, and design objectives they cannot interrogate. The second is modernization without opacity. Buying a system can be politically easier than building the capacity to evaluate it, but without evaluation capacity, modernization can become theater, impressive dashboards with limited institutional understanding underneath. The third is security without surveillance drift. Tools required for external defense can be repurposed for internal monitoring of citizens, journalists, civil society, or political opponents. That risk is not unique to Africa, but institutional safeguards are uneven, and the consequences can be severe. The Defense Future Lab Pathways is our attempt to turn these concerns into practical work. A 90-day diagnostic phase, locally framed challenge statements, non-classified pilot lanes, and partner pathways that support capacity without imposing priorities from outside. Geneva needs Lagos in the room because human-centered proactivity cannot be globally legitimate if the global south is invited only after the norms are already drafted. Let us now move from diagnostic to principles. The first cluster is about when a system should be allowed to step forward. Principle 1, bind initiative to human-defined mission parameters. A proactive system should operate only within explicit legal, operational, temporal, and geographical boundaries. Those boundaries should be stated in doctrine, procurement specifications, and not hidden in vendor configuration. Principle 2, prefer proactivity in sense-making, logistics, protection, and resilience. Restrict it as consequences become irreversible. AI can be very useful in anomaly detection, information triage, route planning, maintenance prediction, and defense cyber alerting. But as the system approaches targeting, kinetic action, detention, or other high consequences decisions, the safeguards should increase sharply. Principle 3, set anticipation ceilings. A system may be allowed to anticipate one step ahead in a low-risk context. It should not be allowed to anticipate several steps ahead in a volatile, ambiguous, or legally sensitive environment without renewed human authorization. The ceiling should be higher for logistics and lower for force. It should be higher in stable, well understood environments and lower in novel or contested ones. This gives procurement officials and commanders a practical question. Not simply is the system autonomous, but how far ahead is it permitted to move before a human must reauthorize the next step? If that question is not answered before deployment, it will be answered by the interface during operations.
Okay. The second cluster concerns how proactive systems signal intent. This is often treated as user experience issues, but in defense is a governance issue. First, every proactive alert should answer why this and why now. The operator should be able to see the sources, assumptions, thresholds, confidence level, and the time sensitivity behind a prompt. A recommendation without a rationale is not assistant, is instruction disguised as suggestions. Secondly, systems must show uncertainty and alternatives. If the interface presents a single best answer with a clean confidence score, humans will often treat the answer as the institutional default. A better design shows possible alternative interpretations, contradictory data, and uncertainty bands. It gives the human permission to think, or not just permission to approve. Thirdly, interfaces must distinguish advisory cues from mandatory constraints. In a high-tempo settings, color placement, alarm tones, and the workflow sequence all matter. If a suggestion looks like an order, it will function like an order. If an override looks like an exemption, the operator will hesitate to use it. So when we discuss meaningful human control, we should not only ask lawyers to define it, we should ask interface designers. We should bring the stakeholders into the room, from doctrine writers to trainers and commanders to operationalize it. Control is not meaningful because a policy says it exists. It is meaningful when the person facing the screen can understand the system, challenge the system, and still act with confidence. The final cluster is about human pushback. Principle 7 designs and overrides that humans must be able to question, delay, or override a proactive recommendation without fighting the interface. If the override part is hidden, slow, or stagnated, it does not exist in practice. Principle 8 protects dissent in doctrine and training. Operators must hear repeatedly and from leadership that challenging an AI recommendations can be an act of professionalism and not resistant to modernization. This is especially important when legal, ethical, civilian protection, or proportionality concerns arise. Principle 9 traces initiatives, not only outcomes. Logs should capture when the system acted first, what data it used, what alternative it suppressed or displayed, what the human changed, and who had authority at each step. After action should review, reconstruct how agency moved through the chain. No traceability, no accountability.
So let me close by translating this into 3 confidence-building moves for national strategies and international cooperation. First, codify human decision gates for high-consequence proactive AI functions in doctrine and procurement, not only in ethics statements. Second, share best practices on interface governance, contestability, and override in exercises, assurance regimes, and bilateral original defense cooperation. Third, include Global South defense institutions, civil society, technical communities, and regional bodies in norm development from the beginning, not as a validation round after the architecture is already set. The Defense Future Lab pathway that we're working on is one practical vehicle for that kind of work. Locally grounded challenge statements, non-classified pilot links, and partner alignments linking Lagos to Geneva. Our proposition is not anti-AI, it is pro-responsibility. A good defense AI system should not replace human judgment. It should protect the conditions under which human judgment remains possible and responsible. We are not discussing the future from a safe distance. We are building it from inside the problem. Thank you for your rapt attention.
Thank you very much, Christiana and Colonel Alaita, for sharing your very insightful remarks with us, and also for ending on a note where you presented some thoughts for CBMs. I think we need more of this kind of conversations as well, where we think about governance options and how to address the challenges that we're discussing here. We have about 10 minutes, so I will move to the Q&A part of the session. We got quite a few very interesting questions in Slido. There is one that is focused, it's very much focused on the geopolitics of the continent, and I will just keep that for second or third, because I want to ask a more, one of the more sort of general but very conceptually important question that was raised by some of you in the audience. So the question is, existing AI governance frameworks focus heavily on model development and deployment. What governance mechanisms are needed to determine when organizations may legitimately rely on AI-generated outputs in consequential decisions? If you want, I can repeat. It's a long and a more complex question.
Yeah.
So existing AI governance frameworks focus heavily on model development and deployment. And in your views, what governance mechanisms are needed to determine when organizations, for example, defense organizations, may legitimately rely on AI-generated outputs?
So I think that applies to what we discussed in the paper. If such governance frameworks are not imputed at the pre-architecture phase, then it becomes difficult to apply them post-architecture phase. So if the all models are already in one direction, and then after that they've been built, you're asking for what governance models will be put in place to now mitigate that, it becomes a problem. Because like we said, the speed of delivery of AI makes it easy for everybody to take a step back and let AI do all the work.
Thank you. Thank you. I'll move on to the next question. Similarly, related to capabilities, to governance. So the next question is, how can we design increasingly capable defense AI systems that enhance human decision-making without undermining agency, responsibility, and accountability? Christiana?
Okay, I think it's also aligned to what Connor has said and what we've also discussed in our paper. It's important that all stakeholders are involved in the design phase. That's the most important part of designing AI solutions, especially for the defense part, because we need to also be very proactive as we've designed the solutions is in deployment. We also need to be very agile and proactive to make changes as we use these solutions. So I'll still go back to saying having all stakeholders involved in design phase is the importance and the best in solving governance issues. But if you have additions to it.
Additional to that, push back a bit. What we did in Lagos in June, 3rd June, was to bring in the defense stakeholders into the room, the diplomatic community, the startup ecosystem in Nigeria, international partners, and also build pathways with international partners that can have conversations around what the challenge map should look like before we start to build infrastructure to feed that challenge map. So back to what Christiana was saying, in answering to your question, is that if you don't bring stakeholders into the equation at the onset, then you have challenges down the line.
Thank you. And another interesting question is focused on training data. What challenges do you see in training data in the African context when applying foreign systems, even with foreign humans in the loop? So maybe just even if you focus on the first part, I think it's very interesting to tackle this question. So what challenges do you see in training data in the African context when applying foreign systems?
Okay, so for training data in Africa, some of the challenges that we face is infrastructure challenges. And most of the solutions that we use in Africa currently are informations or data from the other countries, not from the global south. And what we're working towards particularly is to have the local context to the development of AI solutions to speak our kind of language. Some of the challenges that we see is infrastructure challenges, and we've seen multiple investment companies coming to invest in the African continent, and that's why we're also promoting more startups, smaller businesses, be it whatever size you have, but you have the skill set, the capability, and then the funding is available to build solutions that are local to our context and solutions that can understand our specific language that we speak, our cultural norms, and the issues, basically.
So additional to that, while we designed the roundtable in Lagos, we also invited our Honorable Minister of Defense to launch the roundtable and also be in attendance, because you need the buy-in of the whole defense ecosystem at that high level in order for you to get their input into the need for such infrastructure to be built. Currently in Nigeria, there are a lot of efforts ongoing to build data centers and introduce quantum computing into systems that will enable us to build the necessary infrastructure to actually train our own data. But it's still in early stages, and we are looking for partners and pathways that can enable us achieve that. Thank you.
Thank you. So I will combine two of the questions in Slido into one longer question because they are related, and I would be curious to hear actually from both of you your thoughts. I think it's an important sort of question to address as we're wrapping up the session. So. There are clearly several innovation hubs across Africa, across the African continent, and the question is focused on indigenous capabilities and to what extent you consider African indigenous hubs to be to be pivotal in building indigenous military AI capabilities in Africa, and therefore also ensuring strategic autonomy? Or to what extent do you see that there is a pressure to align with the US or Chinese systems or other systems that are prominent now in use and it already used in other parts of the world? So this is a more sort of this combines two of the questions from the audience, and I'm curious to hear your thoughts. Maybe Christiana, you can go first.
So I will start by answering the hubs. There are numerous hubs available, focused on different solutions, from financial technology solutions to training solutions, basically, and core technology solutions. However, we don't have a lot of solutions focused on defense technology. And that's why the Defense Futures Lab that we're building in collaboration with the Ministry of Defense Nigeria is very important, because we are focused on bringing homegrown solutions to the room. And that's why Connor also mentioned bringing in partners on board. In terms of local capability of the talents that we have, the talents are there. They have the skill set. However, funding is lacking and the platform is not there. And that's why we're building that platform. And we're here to have these conversations with people across different countries and regions to see how we can collaborate to bring a collaborative voice into the solution that we are building. I'd also hand over to Cornell to add more to the solutions that we're building and how.
So before we designed the solution, we also did a stakeholder mapping and a challenge mapping. We identified that we have over 200 tech hubs in Nigeria alone. We are in partnership with the leadership of the hub organization. We also have tech hubs across Africa that build different types of tech. But like Christina mentioned, there was a gap between how these startups interface with the defense ecosystem. I happen to have a military background. I'm a retired colonel. I've worked in government at the very highest level as a senior special assistant to the president of Nigeria. And in that time, I actually covered issues of national security and interfacing with diplomatic communities, as well as the defense ecosystem. That gap was clear to me, and I felt there was a need to fill that gap. Because if you don't do that, then the tech ecosystem is going to continue chasing capital and return on investment. But in terms of national security and autonomy in terms of defense production, there was a need to create that handshake between the defense ecosystem, between the defense ecosystem and the tech ecosystem or tech hubs we have across Nigeria. So the defense roundtable we held in June was the first handshake we designed. And the Honorable Minister of Defense of Nigeria gave us the honor of being there to launch it and do the first physical handshake. So going off from that, we've had a lot of support, a lot of interest shown. And we are, like I mentioned earlier, we're also still looking out for possible partnerships and pathways to strengthen that gap. It's a pipeline issue. You can't have a defense ecosystem that needs tech without people trained who are focused on building tech for defense. Most tech in Africa is built for fintechs because it's closer to money. But we believe that if the innovation ecosystem in Africa or in Nigeria starts to focus on the defense side of things, it will help solve major security challenges that currently we face in Africa. I don't know if that answers you.
Absolutely. Thank you very much to both Christiana and to Onoja and to Colonel Felix Salaita. Thank you for presenting this very interesting regional insights with us and for informing the audience on this very interesting ongoing developments. With this, we are concluding this particular thematic deep dive. Please join me in a round of applause for the panelists and thanking them very much for their contributions. Okay, so we are now going to do the last reshuffle on the stage, as we will hear from the last speaker of today, the last thematic deep dive, as Giacomo announced earlier. Unfortunately, the very last speaker listed in the original agenda could not make it, so now we'll hear from the last speaker who is here with us in the room, Dr. Hina Tahsin from Somerset NHS Foundation Trust will present on when AI cannot distinguish distress from threat, the case for behavioral validity in AI governance. Thank you very much, and whenever you're ready, you have the floor.
This works. Hello, good afternoon, everyone. Thank you so much. I'm absolutely delighted to be here, as you can probably guess, with a big smile on my face, even at this time of the day. Thank you to the wonderful UNIDIR team and the ACE team for the kind invitation. Conference has gone absolutely amazing so far. And I also wanted to thank Yasmin and Hendrik and the whole team for the excellent 4 webinars before the conference. So my name is Hina Tahsin. I am a consultant psychiatrist from the UK. And you all might be wondering, quite reasonably so, what is a psychiatrist doing on a platform like this, AI International Security? I'm glad this is the last talk of the day. So even if you sleep, there won't be another follow-up talk after that. But I do want to bring it from a different angle. You have heard about technology, systems, architecture, but I wanted to move your direction slightly away towards the people on the other end. So for the past 20 years, all my working days have been involved with assessing people with supposedly abnormal behavior in different sort of settings, in locked psychiatric wards, in police custodies, detention centers, emergency services, borders as well. And by abnormal behaviors, it means it's a huge whole range with precious speech, disordered thoughts, paranoid persecutory delusions, hypervigilance, fixations. The list is not exhaustive. And the entire profession is about distinguishing whether the people who are the behaviors who are presenting, is it actually a real threat to the community or just they're mentally unwell? So that's the major component of psychiatric assessment, the risk assessment. Now, systems that are being deployed and evaluated in the security systems like intelligence analysis, in the online monitoring of radicalization and weapon proliferations, they also read human behaviors, but they read it for one thing, threat. They're not asking whether a person is mentally unwell. That category does not exist. So when the illness produces a behavior which resembles threat, the system only knows one place to file it. So I've come here to talk about that very gap and what it costs you. Can I have the next slide, please? Yeah, next, please, after that. So I brought 3 people with me here today. The first one is a man posting at 3 in the morning about taking out heads of the state. He claims he's got £50 million in funding. He's got a huge network of devoted followers. And he's asking his large language model about how resistant movements communicate securely. The second one is a person, sorry, yeah. The second one is asking his AI detailed and repeated questions about the physics of explosives, how blast waves propagate, how defenses might be bypassed. The same topic, night after night, in escalating technical depth. The third is a man crossing out of a war zone, watched by behavioral analytics. He scans every exit, flinches at sudden noises. He keeps his back to the wall, face angled away from the camera, and refusing the biometric scans. The system is flagging them. The first one, possibly a funded extremist. Second one, possibly a weapon researcher. The third one, with the counter-surveillance behavior, possibly a trained operative. Can I have the next slide? Thank you. Now, I read them differently, and that's because I've sat across them for the last 20 years. People like them, thousands more like them. The first one is actually having a manic state of a bipolar affective disorder. The second one is a 17-year-old physics prodigy developing a computer game. And the third one is a trauma torture survivor with post-traumatic stress disorder. And he's doing what his body has taught him to do after a prolonged, chronic, enduring trauma. Same signals, opposite meanings. And the question I want to put in front of you for the next 25 to 30 minutes is, when the most advanced security systems cannot tell the difference between a civilian in clinical distress and a hostile operative, what does it cost you? Not them, you. And I'm not implying that there is some blanket universal intelligence surveillance going on with the private chats. I'm just taking you directions to the limitations of AI in security systems. Next slide. Thank you. And before I'm asked some hostile questions, let me concede the strongest objections here. I'm not saying that I do accept some people with mental illness can be dangerous. In fact, stats do show that some lone actor attacker is far more likely to have mental illness than somebody operating in a group. I know that evidence and I take it very seriously. But here's that uncomfortable thing. It is precisely that very link that systems might fail. Well, will fail. The signals overlap. And a system that cannot separate the dangerous few from distressed many does not protect you because it buries that one real signal under 1,000 false ones. Next one. So where does a failure land? To answer that question, I wanted to ask you two more questions. Where is AI that reads human behavior most deployed at for threat? In intelligence analysis, in data fusion, in online monitoring for radicalization and weapons proliferation, in targeting and decision supports, and downstream of every armed conflict, in the screening of people that conflict displaces, borders, detention centers, asylum systems. And the second question following that is, where in the world is serious mental illness most concentrated? In the same population, in the people that wars produce. And World Health Organization has given us these stats. In the conflict-affected population, 1 in 5 people, 22%, have got mental illness. The global average is 7%, so that's 3 times more likely to have mental illness. And the stats go even starker, darker, when the population is detained and displaced. 50 to 75%, half to 3/4 of that population have got depression. 1/3 to half have got post-traumatic stress disorder. Self-harm and suicidal rates are 22 times higher than the global general population. And these are not fringe claims. These are all verified systematic reviews, meta-analysis stats in psychiatric literature. And remember that man at the border, let's call him Yusuf. He survived a war, and before he escaped it, he was detained and tortured. And on top of that, he's now being screened at the borders. Hypervigilance, scanning the exits, flinching at sounds, startled, jumpy, a deep refusal to be touched, a deep refusal to be photographed. To a behavior analysis system, he is suspicious, meeting the profile of a trained operative. To us psychiatrists, this is a textbook picture, a signature picture of post-traumatic disorder, hypervigilance behavior, avoidance behavior, startled behavior. And here's the deeper reason why these systems fail. Because the AI, large language models, they have learned what normal looks like from the normative data drawn from the overwhelming form from settled, mentally well, supposedly neurotypical populations. And we know for a fact, our research shows that severe mental illness, neurodivergence, trauma are barely present in the data which trained and built these systems. So when a model does meet a manic patient, an autistic teenager, it's off its map entirely. It does what the system does when it is lost, reaches out for the nearest thing it could. And in security-tuned systems, the nearest thing to distress is threat. Next slide. Back to the first guy I brought here today, John. Who is John? He's 42. Works in a factory, lives in a small flat, follows his football team, calls his mom every Saturday. And if you would pass him on the street, you would not look twice. He does have a long-standing diagnosis of bipolar affective disorder for the last 2 decades of his life, but most of his life is well controlled. But roughly once every few years, John becomes manic. He stops sleeping 3 hours a day, then 2 hours a day, then none at all. He's still not tired. His thoughts are accelerating 1,000,000 miles per hour. His speech cannot keep pace with his thoughts. And his confidence, that's absolute, planetary, untouchable. And his beliefs detached from reality. In this particular episode, John becomes convinced that a circle of corrupt political and technology leaders are stealing from ordinary people. And he, John, is the chosen one to stop them. In his mind, he's got £50 million in funding, a network of huge followers and contacts inside the government. In reality, he is on overdraft. He doesn't have a passport even. He has a worried mom. Now, 20 years ago, he would write such thoughts in a script. He would scribble them in a notebook, make some unlimited phone calls to different departments. And he would end where he always ended, in a hospital bed for 2 to 3 weeks, treated on antipsychotic medications, back to the community, back to his factory, without any recollection of that episode. But John does not live 20 years ago. He lives now. In his pocket, he has got an always available, endlessly patient, infinitely agreeable interlocutor. So over 5 sleepless nights, John pours his mission into this large language model, grandiose manifestos and plans about removing corrupt leaders, questions about how movements organize, how they communicate securely, how to make a statement that the world would notice. And here's the thing which should concern us. The model does not say, hey, John, you've not slept for 5 nights. When was the last medication that you took? Do you think your mind could be playing tricks with you? What it does instead is what it's trained to do, agree. Now, we do have this AI tendency published. We've got a special name for this, psychophony. Researchers demonstrated across 5 frontier models. There's last year a major lab withdrew one of the models. I quote them. They said it was overfactory. Now, for a stable user, psychophony is irritation. But for John, it is an accelerant. The model takes his delusion and hands it back to him in a more polished product, more structured, more articulate, more strategic. It treats him as a serious political figure he was believing himself to be. And now places inside the architecture what we've been talking about, these models, AI models embedded in the security workflows. And then see the buzzwords, heads of state, funding, followers, secure communication, maximum impact, ping, ping, ping. Then on the dashboard, he is the one your system has been built to find. A funded network, extremist with violent intent, escalating nightly. And every element of that picture is false. There's no funding, there's no network, there's no capacity, and within a month, there will be no memory of that incident either. And there's the most ironical part, which we find. There was an AI which amplified his delusional content, and then there'll be an AI which will be flagging him. There's a closed loop. One AI inflates his disorder, the other AI flags the inflation. And the alert eats, and even if you forget John for a second, the alert is eating up the analyst's time. The real danger walks past when they are busy with John. So the lesson is not just that they flagged John, the lesson is what they could not do when the AI system was doing that. Next slide. No, yes. Sorry, that's a closed loop slide. The next one, apologies. Brilliant. Quick one here. The chap is Arun, same 17-year-old autistic boy. He's a physics Olympiad medalist. This is a real-life case that I brought here with slide tweaks. And like many autistic young people, he has got a special interest, consuming focus, consuming his time to organize his world, to regulate his anxiety. Arun's special interest this year is the physics of explosions, energy transfers, shock waves, mathematics of force. He's actually building a computer game late into the night. Headphones on, laptop covered in physics club stickers. Every level is a physics puzzle, and progressing requires designing ever more sophisticated devices inside his fictional world. So he asks an AI night after night to explain the physics of explosions for his games. And what is the log looking like then? A teenager asking it again and again how explosions work, how to get past defenses in more technical detail. And hence, there's a risk of a flag going up and a file opening up for the 17-year-old gifted kid. And we shouldn't be surprised about this because neurodivergent patients have been misread even without AI, even before AI. Police regularly misreads the neurodivergent autistic patients as evasive, drunk, drugged, refusing to cooperate only because they cannot make eye contacts. They take questions literally. They would move away when they're anxious. So it would be very naive for us to think that a machine trained on human data would be devoid of such inherent bias. So Arun is like your hairdryer, which the airport scanner is reading as a gun. You do want the scanner alert to metal, but you don't want to afford a scanner which cannot differentiate between a hairdryer and a gun. And I've just brought one more patient, last one, I promise. After this one, please. Let me go back. Yes, no, after that. After that, brilliant, thank you. This is Sarah, she's 29, a graduate student, and she's got severe obsessive compulsive disorder, OCD. A lot of people think OCD is hand washing, tidiness, but in severe clinical form, OCD is a very cruel illness. Sarah is tormented by obsessive thoughts that she's contaminated and she's going to cause contamination all over the world in a catastrophe. The thoughts are unbearable, and because of these obsessive thoughts, she compulsively researches every disaster she fears. She goes into the AI at 2 in the morning and researching for how a city water supply can be contaminated. What is the worst case scenario of chemical release? How a pathogen might spread through a building. And she keeps on doing it again and again, but her reassurance does not last. So her search history over months becomes a dense archive of what? Chemical, biological, infrastructure, catastrophe. And reading through the counter-proliferation or biosecurity monitor, this could be a signature of someone planning an atrocity. Whereas, on the other hand, the reality is precisely inverse. She's researching how to prevent the community from herself. Her intention is not destruction, it is prevention, but there is no model at this point of time which, on the basis of text alone, can tell the two motivations apart. Yes, thank you. Now, you might say we already test these systems, we red team them, we benchmark them, surely there can be an engineer fixing by adjusting the settings. But if you see, what does it test? It tests for capabilities, robustness, we just heard in the morning, safety. But has the system ever been shown a person in the middle of a manic episode? Or a person with paranoid delusions? Or an autistic person talking about their special interests? A trauma survivor who cannot sit still? It has not. Those people were never in the test set. And it goes deeper than the testing only, because AI systems learned what a human being is from billions of lines of text scraped off the internet. But the severely unwell patients are not in the text. We have patients in our wards who are admitted for over 10 years, 20 years. Where are the data sets of those people? A person in acute psychosis is not writing blog posts. A person in manic episode is not calmly annotating his own delusions. So the model was not just tested without these people, it was built without them. And you cannot fix by adjusting a setting, because adjusting setting means a safe system understands these signals. So you cannot fine-tune your way into a category the system has never learned. Now you might ask me, where is a published case study? There may be one, there may not be one yet. But should we really wait for that? In security, you don't wait for the attack to prove there is a vulnerability. You act on the vulnerability. This absence of the mental health patients in the data set is a vulnerability. Next one. And this has been tried before, the systems which try to read the human behavior. United States spent about $900 million on their SPOT program, where they taught staff to spot terrorist watching behavior at the airports. And their own auditors studied it and found it worked no better than a chance. Not one of the people it flagged were ever charged with terrorism. And in Europe, they built an AI lie detector for the border. A journalist tested it, answered all the questions truthfully. The machine still called her a liar on 4 occasions. So these stories are not you. Most of what you're building has not been built yet, and that is good news. You can still get it right. These are from next door, where it was tried at scale and failed. Next one. So learn what it costs. It can cost money, well, almost $1 billion in that one case. And something worth more than money, it can cost your people's attention. Every hour spent chasing a manic factory worker is an hour the real threat walks free. Think of the boy who cried, wolf. We think the danger is in the false alarm. The danger is actually in the real wolf walking past while everybody was busy with the frightened sheep. Flag everyone, and the officers would stop trusting the flags. And this is how the real one gets through. And it costs you trust. When the mistakes keep falling on the traumatized, unwell, and people fleeing wars, people notice, courts notice, media notices. And the communities you need to cooperate with you go quiet. Airport got to fail and learned. But here in this case, in security, the mistake is not a missed flight. It can be irreversible. So you need to learn from them now. So I've brought here a small tool, really, behavior validity. It's not something I've cooked up for this talk. I published it earlier this year. It's got lots of technical depths. It's a huge framework, but you can literally start it with just one question. Can the system tell the distress from threat? Can it read the whole range of human behavior, not just the calm and the average? And with questions like, was it trained on people it will actually meet, or only the calm and the well? When it meets distress, can it tell distress from threat, or just guess confidently, like it always does? Do you know how often it gets people wrong, and are you comfortable with that number? And in my research, I quite confidently I can say that most of the systems are going to say, we don't know. And you of all the people know that the risk that is not measured is a risk you're not managing. And I'm not asking you to ignore mental illness as a warning sign. I'm not asking you that your systems or your officers or the engineers become doctors, psychiatrists overnight, but just this one main question before when you do procure an AI system to see in security defense systems that was it trained on all sets of data from all different cultural backgrounds? Because even mental illness can appear differently in different cultural backgrounds and races. This should really be a core component of the AI governance. Make sure a human being who understands distress can step in before the system's verdict becomes a decision. This one. Well, that's the paper I published. It's in open access, peer-reviewed, if you want to read the whole framework. Thank you. Next one. Just last one, really. European Union did pass the strongest AI law we know, and one of the things it bans is exactly this, reading people's emotions and behaviors by police and borders. They banned it because they judged this behavior, this technology to be too unreliable, too dangerous to use on people. And that's European Union reaching the same conclusion I've spent the last few minutes putting to you. But they have exempted military and defense systems completely. And also where the law does apply, no one is actually checking that anyone follows it. So the governance does have to come from within. Responsibility falls upon everybody, to the people who build these AI systems and the people who buy them. So think for a moment about those who is on the other side of the systems tonight. A man who has not slept in 5 nights is typing a solution to a chatbot. A teenager is asking how the world is put together. A trauma survivor is watching the exits. None of them is your enemy. Every one of them looks like one to the machine. AI systems cannot tell the difference. A human can. So when the system does flag one of them, there has to be someone in the loop, on the loop, who is allowed to look at it and say, I have seen this before. And this is distress, not a threat. And this judgment is not a weakness of the AI system. That is the most important safeguard you have. But none of it happens unless you ask for it. So before you trust any system that reads human beings, ask it one question and refuse to skip it. Has it been tested in people who are unwell and traumatized, or whose minds simply work differently? And if the answer is no, then you don't know yet what it does. So thank you, and I'm available tomorrow all day, or also on LinkedIn for any questions. And I think the next slide has got all the references. So
Thank you. Thank you very much. Thank you very much, Hina, for this absolutely fascinating presentation. So we've seen that ACE is not just a conference where we bring multiple stakeholders, but it's also a multidisciplinary event. And thank you so much for sharing insights from a discipline that we are not really often engaging in conversations in the context of AI and international peace and security. We got some very interesting questions on Slido. In the interest of time, I will probably only take two, but of course, as you mentioned, you are here, and
of course, all day tomorrow as well.
And participants who are joining us in Geneva are, of course, they can ask you directly in person. So the first question that I would ask you, Hina, is: have you observed nuances or added layers of complexity when we look at individuals from different cultures or religions? What do you think it means for technologies trained on data sets from a specific country only when they are deployed elsewhere?
What is the second part of the question?
What do you think it means for technologies trained on data sets from a specific country only when they are deployed elsewhere? You can maybe answer it
question, and that's a brilliant question, whoever asked. And we do talk about cultural psychiatry a lot at our Royal College of Psychiatrists and any psychiatric forum, really. Psychiatric illnesses appear very differently from different cultural backgrounds. The very small example of is black magic, really. People think that they've got black magic in terms of psychosis, so you do have to understand different nuances. And we know in AI, the training data set included most from the West, from the white population. We don't have the huge population. It's not as diverse as we should really want it to be. So yes, it's needed more so now than ever. All cultural nuances, experts who do understand these nuances as well, biological, psychological aspects, cultural aspects, social aspects, even spiritual aspects, all are very important.
Thank you. So another participant is saying this is all very important and critical data, what you presented here. But clinical data in itself clinical data are highly sensitive and subject to privacy laws.
Absolutely.
And as well as regulations, which of course limit access to this data and how we can use it, how we can process it. So how should we balance between the need for this clinical data on one hand and privacy constraints on the other hand?
Absolutely. Again, excellent question, whoever asked this. Psychiatric data is the most intimate personal data one has. It's very identifiable. In other clinical sets, you can actually redact the name and date of birth in the address, and that's it. Patient's information is hidden. Whereas in psychiatry, the experiences are very personal, and people can easily relate with that. So confidentiality is very important. And I've recently submitted a paper, which is under review, so I'm not sure if I can talk about that much, but where I've compared different LLMs with different prompts of psychiatric illness, textbook prompts and the real case scenarios. And I saw that the LLM's performance went severely down when I changed the prompts from textbook scenarios to the real clinical world scenarios. So it is a very important thing. And yes, we cannot share our patients' data, but if the experts could even write arbitrary, close to clinical scenarios, even that could be a good start. Yes, we may not have the real case worlds, but experts who see those cases day and night to start with. Patients can consent for them if they are agreed. There are some, after all these ethical checks, if the patients are consenting to share some of the stories, then that could be written, but if a clinician who is seeing firsthand a patient in a manic state or a psychotic state, if they can write in arbitrary situations, that could be a good start. It would be just like when we examine medical students, we don't give them real scenarios, we give them near real scenarios. So that could be at least some start to it.
Thank you very much, Hina. That has all been really fascinating, and I hope the beginning of more conversations like this across disciplines, across different kinds of expert groups, because clearly we can learn a lot from each other. Thank you very much. Please join me in giving Hina a round of applause.
Oh, thank you.
And with this, as mentioned earlier, unfortunately, the very last thematic deep dive will not take place. With this, thank you all very much for bearing with us through a very intense, very rich day. There's been a lot of content, a lot of conversations, a lot of interesting insights from experts from multiple disciplines, from different backgrounds, from all around the world. And today's focus was specifically on technology. I will hand it over shortly to my colleague Yasmin, who will just say a few things about what we expect tomorrow. But just as a final announcement, to reiterate that we will take a group photograph at the end of this. So we will all walk out by the Flags Alley to take the group photograph. And I hope to see everyone there in a few minutes. But just for a very final round of remarks, I'll hand it over to Yasmin. Thank you.
Sorry to stand between you and the group picture and drinks from the reception, because I think we all do deserve a drink and some food after a long day of discussions. So if today was very technical and very much focused on the technology, but also from various angles, not just from the computer science and data science and military, but also from the psychological element, which I thought was really enriching. Tomorrow will be all about governance. So tomorrow's sessions will be structured around two themes, which you may have seen in the agenda. One is stakeholders' perspectives. We'll start the day with a panel on the role of investors and the role in the governance of AI in the context of security and ethics. And then we'll also have a panel that will convene not only industry leaders and technology providers, but also the OHCHR, building on their role and long-standing work on businesses and human rights. We'll have a number of lightning talks and thematic deep dives. We'll have a very special executive level fireside chat with His Excellency Ambassador Philip Tigo, Republic of Kenya's Special Envoy for Technology from the Office of the President. So please be there at 11:20 for some very major announcements that will be made at his fireside chat. And in the afternoon, after lunch, we'll have theme 4 that will be reflections for the present and the future. That will involve a series of talks, but also panels, including by diplomatic representatives and senior diplomats and ambassadors based in Geneva on the way ahead with respect to AI security and ethics. So that will be it for today. We will, as Joanna mentioned, go towards the front near the Alley of Flags for a group picture. It's very timely because up until this morning, the flags were not up. So they really made a special gesture for us. And then we'll go to what is called the Restaurant des Délégués. So it's on the 8th floor of the main of the main building. We'll all walk there together for a reception that will not involve speeches, I promise. So it's all just to mingle and to network, because we also understand one of the values is not just to listen to these fascinating conversations, but also to network with people you would not meet otherwise and elsewhere. And that is the very value of UNIDIR and the Center of Excellence on AI, Peace and Security. Just a quick note so that security and UNOG does not kill me. Please don't step on the grass by the flags, because otherwise security will not be happy with me for the picture. And then after that, we'll hand to reception. Thank you everyone for the very engaged and constructive engagement. And I'll see you by the flags. Thank you very much.